Right. So, as I said, this is the 159th edition of the Zak World of Façades conference series. We're doing this event all across the globe, from New Zealand up until Canada. Different regions, different countries, facades are designed, engineered, installed differently. So if you see, this is our calendar of events in 2025. We've got events all across the globe. All events are different, as I said, because facades are looked at differently. In some regions, it's about carbon reduction. Some regions, it's about complex geometry. Some regions, it's about cost. So for us, every event is bespoke, and we try to curate what is interesting and what is important for the local market, and the agenda is then curated that way. Today's event is a reflection of what's happening here in Europe and in Belgium, more on sustainability, more on embodied carbon reduction, hence sustainability is the main theme. Of course, we do mix it in a little bit of structural glass and other innovations which are there in facades, but the overall core theme, I think most of the people would be talking about, is on sustainability. These are the events we have planned for 2025. We're doing a lot of interesting new places. We're going to Georgia. Georgia has never had a facade conference over there. Uzbekistan. Of course, we've got the usual suspects as the UK, France, the US, where we are extremely strong, India, a lot of other places. But we go to the respective places and we organize these events where, am I okay? Yeah, right. Where we customize to that local region. These events are all courtesy our event partners. I'd like to start by thanking all of them, starting with Shuko. So Shuko is the presenting partner of this event. We've had a very strong relationship with Shuko globally. They've been a great supporter of this conference series. Shuko does not need any introduction, but for those who don't know Shuko, Shuko is from Germany. They are the world leaders in aluminum door, window, curtain wall systems. They are the presenting partner of this event. I'll start with our associate partner, AkzoNobel. So AkzoNobel have powder and liquid coatings, which are used for the aluminum profiles and cladding. The powder coating brand is Interpon, and their liquid coating brand is Trenar. Axalta is also, again, a global leader in powder and liquid coating solutions. Cosentino is a Spanish company. Their facade product is Decton. Decton is a new age cladding material, non-combustible, sustainable material. You'll be hearing from them later today. So I think these kind of products are now picking up than your standard aluminum panel or a composite panel. Euromax, Belgian company, so they've got coil coating solutions for building envelopes. Façade Steel is a new joint venture company between Martens and Façade Engineering, where they have some innovative steel solutions. Obex is from the UK. They've got tapes, membranes, vapor barriers, and other value-added products to seal and bond your facade. Sage Glass is by Saint-Gobain. This is their electrochromic glass division. This is the glass which tints on demand. Very popular here in the Belgian market, I'm being told. Trespa is a leading solutions provider of high pressure laminate. High pressure laminate is again another interesting material that can be used on the facade as a cladding material. And of course, I'll quickly run you through our next few events which we're doing in the European region. So our biggest one in the series is London. Most of our friends here would have attended the London event, so this is our largest in the series. They seem to be drawing the highest amount of delegates year on year. It's a 700 to 800 people event. It's a full day event. We have the gala awards and dinner post the event, so that's a big party there in London. If you're in town, it's just a train ride to central London. So 6th of November at the Old Billingsgate. We're doing Stockholm, which is on the 14th of November, part of our Scandinavian region. We're going back to Morocco. So Morocco is going through a big transition. A lot of new build projects over there. A lot of French companies, a lot of Spanish companies working in the Moroccan region. And of course, our events for next year, we go back to Madrid, Birmingham. Tbilisi is new for us. Athens is new for us. We go back to Milan, we go back to Paris, we go back to London, Frankfurt, and Copenhagen. So these are our events in the European region for 2025. And yes, for us as an organizer, it's very exciting because the way we have to curate these events with the respective people in the respective markets is very unique for us, because no two events are same. Different regions have different outlooks towards facade. So for us, it's an exciting curation time where we get to also learn a lot of things, and we try to bring innovation from one region to another region. We've also recorded today's event, so the presentations which we have permission to share with you, we'll send you a YouTube link, and you can watch those presentations. All our partners have their booths outside. Please do drop by and network with them. It's because of these companies we are able to organize these kind of events. So please, during the lunch, tea, coffee breaks, please do network with all of them. They look forward to meeting all of you. That's it from me. Before we start the program, I'd like to call upon Geert Mikkel. I got it right. Okay. He's the country director for Schuko in the Benelux region. He would be giving a quick introductory note. And after that, we'll have Diter, who will take this event until the end of the day. So I hope you'll enjoy today's event. We've got some nice storytelling from our speakers. I believe the agenda is excellent. I've not seen the presentations yet, but my colleague who produced this event said it's excellent. It surprised her that it's of the highest qualities. I hope all of you will enjoy today. And over to you, Geert.
Thank you very much. So, good morning, everyone. Also from my side, a warm welcome to all of you attending this Zak event, World of Façade conference here in Brussels today. As mentioned, my name is Geert Michels. For those who don't know me, I'm the general manager of Schuko Belgium, and I have the honor and the pleasure to open this conference. It is in challenging times that sustainable solutions more strongly pave the way for the future of building construction in general. The importance of the quality of the building envelope in each building project today challenges us all, whether we are private or public investor, architect or contractor, to seriously consider circularity, CO2 emission, and the process and product sustainability, and many other things. This is only possible in approaching each and every project as early as possible in a transparent way, involving all potential partners whom influence the performance of the building and its envelope in relation to the rapid changing technical and thermal requirements. This to maximize the satisfaction of its owner and user in perfectly balancing living and working in the near future. Sharing knowledge today is key in order to fulfill all requirements necessary to come to this performance achievement. Sharing knowledge and best practice is one of the reasons why we are here today. Looking at the agenda, the speakers' content, and the panel discussion topics, I'm sure that each and every one of us will take home some important new and interesting insights today. I wish you a constructive, instructive, and inspiring day, and look forward talking to you and meeting you during one of the network moments later for a discussion. Thank you.
Thank you, Geert. So our event host for today is Diter. He's from Arcora. Arcora is part of Ingenieur-Architecten. It's a big French group. They are facade engineers, structural engineers. They do a lot of stuff. I think he'll introduce himself to you, but we've worked very closely with Arcora in our events in France and other French-speaking countries. So he's going to be your host for today, and I'm sure he's going to entertain you. He is from Belgium, but he's going to introduce himself and take you through until the end of the day. Over to you.
Okay, thank you. Hello, everyone. Welcome to the 159th edition of the Zak World of Façades, and the first one in Belgium. For me, it's also the first time that I have to present the Zak World of Façades, so it's a new one for me. They choose me. I thought it was because I speak French and Dutch, so I thought that makes a key point to be here, but then they told me that I have to do it in English. So, well, I will do it in English also. I'm not here only to present Arcora. I'm from Belgium, that's why I think I'm here. I'm not only in the world of the facade, I'm also actually freediver. I represent Belgium in the World Championship. But okay, I'm not here to talk about freediving, but if you want to talk about freediving, during the break we can talk about it. We are here because it's a great opportunity to present our different solutions, our work, to talk about the environmental innovation and challenges related to the building envelope. It's not the secret that we are facing as a whole the challenge of the century, the climate change. Buildings are responsible for more than 1/3 of the greenhouse gas emission in the European Union. In 2019, the European Commission presented the Green Deal to make Europe climate neutral by 2050, with the goal of reducing the greenhouse gas emissions by 55% by 2030, when we take as reference the levels of 1990. Today, about 75% of the European Union's building stock is energy inefficient. It's possible to reduce this energy loss by improving existing buildings and seeking smart solutions as energy efficient materials for construction. And in Belgium, in 2021, the residential sector accounted for 26% of the final energy consumption, most of which was used for heating buildings. As for the tertiary sector, it accounted for 14% of the final energy consumption in Belgium. That is quite a bit. So the question is therefore crucial. How will the European Union, but also Belgium, achieve its carbon neutrality, given the technical and financial challenges that we have at the moment, and especially considering the economic inflation? The construction of new projects and renovation are essential to succeeding in the environmental transition, along with a massive transformation of the construction sector, requiring necessary reevaluation of the use of it. We have to look on new habits, how to use the building, but also how to design them. And at Arcora, for example, we have developed through our research and development department a software named ECAL, which is a carbon assessment tool for building envelope. It's a result of several years of research since we started in 2019 to develop this software. ECAL is freely accessible online at ecal.io. We can all use it. It's so good for the architects or for the other engineers that don't have a tool like this, or for other clients. It's a tool that takes into account the construction processes, exterior cladding materials, the types of insulation, the types of glazing, and to accurately evaluate a building's carbon footprint. But I know that many of you here are also actors that have launched brilliant innovations in favor of the environmental transition, which we will discover during today's 3 presentation sessions. Before that, I welcome our first speaker. She's already excited, I see it. She's in front row. I will remind you to ensure that you put your phone on flying mode or on silent mode. And there will be no questions or answering sessions after each presentation. And please remind the speakers to stay until the end of the session, because we want to do a picture with everyone. Okay, so please welcome now Maaike Berckmoes from Ingenieur-Architecten and Engineer, who will present lessons for today's news and retrofit facade projects.
Okay, thanks for the introduction. As the title of the conference is Redefining Sustainability, I used this phrase to frame a bit the presentation that I will give, evolving back to the future, evolving perspectives and challenges in facade design. who am I and where do I come from? I think it's a bit, I used a bit my process in my career in the facade industry to make the story about what happened, what is the evolution in the old times towards in facade technology, towards where we are now. At the Zak conference, I think it's a unique thing happening in Belgium because all facade experts, all people busy with facades are here in one room. Unique for Belgium, I think. It shows a bit the growing awareness of the importance of facades and the importance of experts working on the facade design on an integrated level. I started my career in 1999 in Belgium with BEL Facade Contractor. And during 15 years, I worked on Belgian high-rise projects and international projects. And then 11 years ago, I started the facade engineering team in Ingenieur-Architects and Engineers, which is now part of Sweco. We are now 11 years doing really facade engineering, assisting clients and architects from the first line of the sketch of the building to really extend the performance of our facades connected to the building. Framing the story is also a bit about where do we come from. I'm sometimes going back to 1950 projects from 1950. It's also because we see now that we are at the point where we are dealing with these old projects. The market is moving from newly constructed to more renovation, retrofitting. And I will guide you a bit through, with examples of these projects, through some critical questions on what do we need to deal with at this moment to reach actually the goals in the future. Goals in the future, we have to take energy as a big part. How did our facade design had an evolution in the time? It's very driven by energy regulations. In 2006, in Belgium, the EPB standards were there, and actually up to now, we lived through an elongated path of suboptimal improvements of our U values, for instance, of our facades. Together with lots of certification schemes that came up to improve also the other parameters, comfort, well-being of our buildings. Okay, where are we now? Are we maybe in? We are there with the energy levels going down. We are there. We try to at least design our buildings with optimum energy demand levels. And you see from when you look to the buildings in the past to buildings now that we in the past you had a lot of the percentage of operational carbon was much bigger than the percentage of the embodied carbon of the materials with which we built our buildings. By optimizing the operational carbon, the energy demands of our buildings, is actually going as a shift towards 50% operational carbon and embodied carbon. And you see a shift towards the focus on, the important focus on working on this material level. How can we lower the embodied carbon of our building materials? So the shift is there, and the goal is there. The goal is by 2050 we need to decarbonize the decarbonization and the energy reduction is in place via lots of European and national standards. And we see that if you look to the future, we will have to work on material revolution, I call it. How will we do more with less, harvesting, harnessing from energy to materials. And it's not from only, but it will be both. We will have to play on both levels to reach the goals. When we look to facade technology, how did it move in time? We started in 1950. It's a bit black and white. There's a lot of middle solutions, but it's to frame the story. In 1950, we started with the unitized panels for high-rise buildings, pressure equalization, structural glazing, and the performance of the glass was mainly made by body-tinted glass or reflective glazing. And then in 1980, the thermal breaks. It was at the time of the energy regulations setting in place. Or the first awareness of KPL of our buildings. Thermal breaks came in, the metal spacers in time then changed into the warm edge spacers, and we optimized U values and airtightness of our facade systems up to a point where we say, okay, are we at the limits of these values, the U values of our systems? Can we still innovate? Because we also see, for instance, in the graph, doing better will always have a less big effect on the energy demands of your building. Okay, that's energy. We focused a lot on energy. It's not only energy. When we look to the design approach, it's energy, but it's also comfort. It's material use, structural integrity. I think I used the first project that I worked on. I started in Metal working on the Berlaymont building. The Berlaymont building, renovation of the Berlaymont building was with a high-tech facade, was double skin facade with automated louvers, with white dots in the front for reflecting the sun, black dots at the inside for the good see-through and the visual comfort of the. So we, in the time in 2000, for instance, there was already a very integrated design process to make our buildings much more energy and comfort optimal. And we see a bit a shift, I think. We now have all these digital tools to use to optimize all these parameters in a multi-parameter analysis together with the architect. So I think the tools are there for the future to optimize our buildings much further in the future. A critical question. In time, the regulations, they got stricter and stricter and stricter. And it's a sort of a cumulative process. If you see, for instance, not only energy regulations, but also wind loads, water tightness, air tightness, acoustics, safety, the fire regulations, and it moved us a bit towards maybe over-designed? Question mark. It's just a critical question. In our facade systems to reach all these goals. And sometimes it's even not possible anymore. Laminated glass at the moment in high-rise buildings is not fitting with Class A regulations for the fire for regulations. So maybe we have to think about rethinking also the requirements that we set as guiding decisions for designs. Glass went from 12 millimeter up to plus 14 millimeters, plus 8 millimeters. Is a bit correct. It's so it's sometimes needed, but maybe we also have to rethink this, because if you save a bit of glass there, then you have already saved a lot on the material level by not even starting recycling and stuff. This I will not go into because Diter, you explained already a bit, and it's maybe a bit with other percentages, but 40% is going to 40% of the global energy-related emissions comes from the built environment, 15% from the facade on building level, this 50%, we need to work all together to even lower this because innovations are needed also on our facade system material use, and there is no single solution. A tool that we use to then improve for the future is the LCA tool. We use it as a design tool. Just also a critical or a consideration is that design decisions based on LCA calculations are actually based on very large amounts of assumptions. So also there in the process of making decisions based on these tools, we need to be critical in analyzing, are we going, did we take the right steps? Also CO2 equivalent that comes out of the LCA calculations is not the same, or don't give you the same comparison, for instance, as an environmental impact of materials where you take into account the depletion or the scarcity of materials, for instance. And then, a bit for fun, in our life cycle analysis, most of the time, I'm focusing quite a lot on aluminium high-rise curtain systems for in aluminium. But when we see, for instance, in our life cycle analysis, we say after 30 years, we renew the facade system because the lifetime of a facade system, aluminium facade system, is 30 years. But when you look back, then you see that it's much longer that we use the facades of these buildings. Okay, and then you can think about what can we do in the future. I think there are 4 main steps: minimizing the waste, extend the lifetime of your buildings and facades, material reuse and recycling. How can we can we extend this 30 years of our facade systems? Then you have to look to the life expectancy of materials, all the components of the facades. When you take a look at glass, glass itself is a very robust material that can long for 60 years. Insulated glass, we say 25 to 30 years, but then there will is already included with the degradation. If there are no visible defects, can we not accept this degradation to prolong the lifetime of our facades? It's a question that we have to make. Surface treatment of aluminium, sealants and gaskets. There is an issue with our thermal breaks. The profile and the thermal breaks have another expected lifetime. Can we maybe rethink and innovate on that part to again extend the lifetime from 30 years to more? Because probably we will get some more common sense decisions maybe in the design stage. Critical questions, maybe there's no one solution also there. Looking back again, when I saw in old buildings, old unitized buildings, lots of times we use, for instance, a sort of a pre-frame to structural sealant, but a pre-frame where you can replace the glass as a unit later on. Due to thermal issues, it was not thermally performing very well, and also airtightness and due to technical issues, but also due to budget savings. These kind of principles, we forgot it a bit. Probably we think about it every time, and you guys are thinking about it every time. But sometimes we are facing this reality of economics that we have to save, and you save some aluminium if you don't do it. But we have to go back to these kind of ideas of how can we incorporate in our profile design easy replacement, easy access for inspections, and maybe a replacement of a rubber somewhere to extend the lifetime of our facades. The reuse is also one step in reaching our goals. not easy on facade level due to this degradation of materials, but also due to architectural dimensions and other stuff. So very exemplary projects at the moment, but we don't see a lot of evolution in the reuse at the moment. I think there's still a lot of opportunities. It's a storytelling, but in the time that we were working on the renovation of the Madou Tower, I think there was a story that we took out the facade panels and that it was shipped to a building in Romania. I don't know if it's true. Maybe somebody in the audience knows still if this was only a storytelling or did we do it already in 2005? This reuse, maybe in the past, someone can tell me. And then recycling. Recycling, I think the industry, aluminium and glass, is moving. Has taken lots of steps in the recycling of their own materials, aluminium, glass, but also they're a critical point. It's the reality at the moment. If we are using glass with a percentage of, let's say, 20% recycled content, then there's only 1%, less than 1% coming from post-consumer waste. That means that the 90% of recycled material is only coming from actually the waste of the production itself, and it goes back into the production. So I think we are here as an industry to think about how can we, each partner, the architects, the engineers, the facade industry, how can we change, for instance, our design process to increase this 1%? How can we help the industry to increase the 1%? And what can the industry do themselves? Design process, maybe again, we have to rethink these cumulative standards and requirements, doing more with less. In our design, maybe design towards not having too much waste itself in the cutting losses of glass. Okay, all open questions for the future. We don't have to, we need to, also it's sustainability, but it's sustainability that goes together with the architecture. It's sustainability that goes together with buildability. We need to, it goes together. Needs to be built, buildable. And it's sustainability and money, and not or money. A sustainable solution. Is a sustainable solution more expensive, yes or no? But you can ask yourself, what is the price of the unsustainable solution? Maybe it's cheaper now, but on the long end, where are we? So the economic drivers and the financial business models is also something that needs to be revised or rethinked to move towards the future. I have 1 minute, 2 minutes. This is, it's a reality that sometimes we are not starting from. Sometimes we have questions. It's a very complex situation where we are in to optimize. But sometimes you have also the economical facts that a building newly built in 2007, 2025, new owners, the old tenants are going to the Zin building, there are new tenants, and the clients are thinking about doing lots of renovation measures, interior works. And then, okay, what are we going to do with this facade that is 18 years old? 18 years, that's it's a bit, what do we do? Because you cannot say that we can extend 18 years, it's only 12 years. This new owner, if he knows that he has to do lots of measures in 12 years' time for his facade, he's going to think maybe in a commercial way of thinking, why don't we retrofit, and why don't we demolish and strip and do a new facade on the current levels. So I think what we do is making a thorough technical analysis of the current state and compliance to the current standards. And we propose like steps of optimization from doing only smaller measures up to the full stripping and new facade. And explaining or calculating what the capex is, so the investment cost, but also the operational costs, because that's a very big, important parameter to make the right decision. And then we have all these tools now setting in place EU taxonomy, the CREM analysis, who can help investors and developers to really frame and to make the sensible choices for their real estate assets. And then for this project, for instance, you cannot forget also that actually this building and these materials are already there for 18 years, and they are like there's a depreciation of these materials already for 18 years. So maybe it's better to prolong this depreciation than to go for new materials in your building. Drivers for change. Regulations are a driver for change in the Zin building. And I'm not going to go into details, but we saw that putting strict and challenging the industry, putting strict specifications is also a way of moving the industry. Yeah. A way of moving the industry towards innovations. And then I want to end with a bit of a message of we've maybe worked closely together, industry and architects and engineers in design and builds. We see now a bit as broken glass. I feel a bit of broken and fragmented design or construction process at the time. More and more split lots. It does not help us to do these innovations and to change. So it's a plea for a better collaboration. We need to reinforce each other because we are collectively responsible to reach the goals for 2050. So that's our group of facade engineers on top. And then we design the future. I think it's we all together in Belgium. Let's hope that we can make the change for the future.
Thank you very much, Maaike. Okay. Thank you very much for this map to the future. And now please welcome Joost. Sorry, you have 5 minutes less. You have 5 minutes less.
Yes, thank you very much, Maaike.
No. It's just a joke. Please welcome Joost Declercq, Director of Research and Innovation at Archipelago Architects, who will talk about facade as interface.
Thank you very much. Yes, great. Thank you for this introduction. Thank you, Maaike, for this magnificent kickoff and for the time that you left me. No, thank you for putting emphasis on the embodied carbon of facades. I think there's still a lot of work there to do. Thank you also on emphasizing the aspect of rethinking. I think indeed we should hit on rethinking, and that's also one of the reasons that I want to talk about the facades as an interface. And the balance between inward and outward. So I'm gonna zoom a bit out, also from perspective of an architect. So we're an architectural office with offices with some 140 collaborators. We are based in Brussels, Leuven, and Paris and Barcelona, which is sometimes nice if you think that I should see the colleagues in Barcelona. And we do like science at Archipelago, although we are not actual office. We have our in-house research group. Some 12 people are helping and doing research closely related to projects, feeding directly into our projects on topics of well-being, sustainability, and programmation, but all also in the context of the economical aspects, which we like to look at life cycle cost, not as only as the initial investment cost. So, but we do like science, so you will see in my presentation that there will be some data, there will be some evidence to show what actually is now guiding us and moving us in looking at the facade. The research work that we are doing also leads sometimes to publications. This one is one that we recently have launched for OVAM, thinking about, does a building only have one life? No, it can have multiple lives. What can you do to do that? Now, circular building is just one big pile of terms, but actually you should use each strategy at the right moment in the right way. GRO was already on one of the slides of Maaike, so we are collaborating already for almost 3 years on the new version of GRO, which will be launched end of this year, beginning of next year, which will be an inter-regional GRO, so also for Brussels and the Walloon region. And also when it comes to adaptability of buildings, also touched upon by Maaike, we did a research for a Brussels environment also in actually trying to quantify how a building can take other functions. Okay, but to set the scene, well, I'll promise I will talk about bacteria, about shorts in this presentation, so I think not bad for a Wednesday morning about facades that these topics would be addressed. So I hope that I make you curious to see how it comes. But actually the beginning of our reflections is that and not only our reflections, actually also quite now already established in academia, is that as a biological being, so actually of course we make buildings for people. As people, we see that we are more and more inside of these buildings, but as biological beings, from the moment that we were just amoebas in the ocean, we have developed a very close relationship with just the environment. Our biological system has took up a whole lot of influences in how we function. And indeed, we see that the last 70 years, we have been moved towards this indoor generation, and 90% of the times we're indoor. I think this kind of data you already have heard. So, but that makes, of course, that this facade as an interface between inside and outside, it has a very important function, because maybe suddenly we're cut off of all these influences that we had for hundreds of thousands of years to our body, and maybe you have indeed done some overshooting. And in this context, I want to do a big shout out to this lady, and now I think I come back to your old courses at school. Florence Nightingale was the, let's say, pioneer of nursing, of healthcare, and she worked a lot on the battlefields of the Crimean War at this time. And there she built up a lot of field knowledge on actually how a hospital building, and she was also one of the first to actually make this kind of hospital buildings on the battle sites, how it interacts actually with the well-being of their patients. And she has seen that, for instance, patients in north wings of her hospitals had less chance of surviving than patients in south-orientated wings of her. She saw that patients who were more exposed to outdoor air cured better than patients who were not. And when she came back into England, she felt the need to write a book, 1863. I advise you to read it, because her insights which are in there are actually striking and very, very, let's say, up to date with actually the new scientific insight. It's you can find it on Google Books. It's online. For me, it was a very, very interesting reading. So on this kind of insights, end of the First World War, Spanish flu, again history. They've seen that actually patients who were cured outside cured better than people who were inside of the hospitals. And that actually this kind of insights brought a kind of architecture where buildings where people are cured actually interact quite intensively with their neighborhoods. Here you see one of the first sanatoria, and here you see this kind of curing procedure that they had, exposing the patients for a certain time towards sun and daylight. So this is then one of the most known sanatoria, where you see actually that this building is this facade design of this building is actually part of the medicine, is part of the curing process. If you look closer to this kind of drawings, you see the building, how it actually orientates himself to the course of the sun. And if the architect, Alvar Aalto in this case, drew a room of the patient, he actually drew the connection with the outside. And in between, there is the facade. If you then step, let's say, some 50 years further in time, we see this kind of drawings by Professor Delru, who was one of the big hospital designers of the, let's say, the 70s and the 80s. Also, the university site of Leuven has been drawn by him. You certainly see that the outside is not important anymore. It's about how the connection is with the corridor, how the connection is with bringing medicine to the patients. And so the interaction with the outside is neglected. So let's talk about the facade as interface. What kind of topics can we address? There is light, of course, daylight. There are views. There is exchange of air. There is temperature, sound, and odor, which you can bring in front. Within this time frame, I focus on light, views, and air and temperature to show actually how we are now looking towards this facade as interface. So let's start off with light, one of the most obvious ones. And well, Florence Nightingale already had insights from her field work and from the data that she has gathered. But with these people, new insights has come and the scientific evidence has come that actually daylight and sunlight has healing effects. Actually, the Greeks and the Romans already knew it. If you look at the writings of Hippocrates or of Vitruvius, it's clearly written in there. Some things that we completely have forgotten about orientation of rooms, or implementation, impact of health towards the people. So, but in the 19th century, knowledge has grown on microscopes. So they saw that there were kind of little animals creeping under the microscopes. And they saw that if they put them in the sunlight, these creatures died. And if they put them in the darkness, these creatures start to multiply. So quite quickly they saw that it has a relation with a part of the sunlight, the UVA part of sunlight. And so Niels Finsen has got the Nobel Prize even for medicine for his therapies, his healotherapies for tuberculosis with actually sunlight. Beginning of the 20th century, Edward Mellenby has got also the Nobel Prize for showing that UVB, also a part of the sunlight, is responsible for actually the production of vitamin D, which is actually not a real vitamin. It's a proenzyme made by our skin when UVB is hitting it. So that importance of that. So certainly there is also scientific evidence. And that's scientific evidence, and how now here are the shorts brought actually the beginning of the 20th century, we all forgot about it, really a kind of insight that sunlight has a healing effect. And actually for the anecdote, this is the moment that sunlight soap has been launched. The soap has nothing to do with sunlight, but sunlight was associated with health. That's the moment where, and there are the shorts, where in the 20s in Britain, the Men's Dress Reform Party was launched to play for more naked in the clothing of the people. It's still moderate, but let's say that was then a revolution in the Victorian age. But then coming back to facades, already in 1930, Pilkington put a glass on the market in which they advocate that this glass lets UVA through, and that's actually an inherent quality of a good, healthy facade, and it's a quality which will last for 100 years because they make a prospection of 2036, so we're almost there. So there you see it. Then already there were insights that the facade as an interface had a crucial part in the well-being of the building occupants, and that letting in the spectrum of the daylight was so important. This is one of my favorites when I give a lecture to students. Luckily enough, here I don't see yet a lot of people sleeping, but this is actually as true as it can be, as some people now are pretending, I assume. Actually, our buildings are not made to activate people in a lot of cases because we don't receive the essential parts of daylight which activate our body. This is actually, for everybody now here, this is what your biological part of your body now is perceiving. Biological darkness. It thinks it's night because we don't get this kind of information. These are insights of the beginning of the 21st century. Actually, these three people got the Nobel Prize 10 years ago for their, they have been mapping the whole effect of the circadian cycle of the human body. So actually, in our 24 hours, all these elements in our body are fluctuating. And there is actually a receptor in our eye, which only has been discovered beginning of the century, which is called the IPCRG, so the intrinsically photoreceptive rectal ganglion cell. That was my most complicated word today, which actually is reacting to another wavelength of daylight than our rods and cones in our eyes. It's around 480 nanometers, and it is really a kind of kickstarter. If it receives, this receptor receives this information, it kickstarts our whole circadian cycle. Why is this necessary? Well, we have a kind of automatically drifting cycle, and of course also through the seasons, the length of the days are changing, so it's important that our body receives this information. And it's not by coincidence that this 48 nanometers aligns with the blue clear sky, so it's often called as a kind of a blue sky detector. So if we cut off this kind of information, above is a healthy day-night rhythm of a healthy person. Below you see a disturbed one, which is typical for people with different pathologies, for instance, people with dementia, but also people who are completely blind also start to create this. Of course, this is not a lot of living quality, but also for the nursing people, this is not what you really want. So in the US, this kind of topic is now very hot because there is also a big financial issue of part in it. How do we address it in our architecture? Well, we design our patient rooms in such a way that the morning sun is hitting the face of the patients. The evening sun is away from the bed because for our body to sleep, it needs to be able to cool down almost between 1 and 2 degrees. So it means that for each orientation, we have a different facade design which aligned with the position of the bed. Of course, in West, we cannot do miracles. There we just can keep the sun away from the patient. But in East and South, you really can do a big job. So we are really also putting most of our rooms in this orientation, and we really avoid to have rooms on the north, taking back to Florence Nightingale. Actually, there's even an ethical aspect on this. You don't want to have your closest family in rooms which have this kind of qualities. But again, that it does not stop, because then you have, let's say, your architecture, but that daylight needs to get the right frequency, the right wavelength of that needs to get to you. And what you often forget is that a lot of glazing is blocking off this 480 nanometers in the daylight. That's why we only apply clear glass with a high color rendering index, which allows this kind of information passing through. That means that, of course, in our architecture, we can't rely on sun blocking glass, so that we need to think upfront, how will we cope with these solar heat gains? That makes a nice challenge as an architect, but that's what we like. This is a project in the city of Leuven. It's elderly housing. It does not look very spectacular, but in this project, each window has been very precisely located. The spaces where the people are in the morning are east orientated, where they get this kind of activation, this kind of boost. And of course, also a lot of attention has been given to the outdoor spaces, because of course, to give these people kind of what they call a daylight shower, to bring them outside is of course always the best. So we're creating this kind of microclimates where people can easily be outside. We're scaling this up to a hospital, actually 5 hospitals that we are designing for the Walloon region, also in collaboration with VK actually, where we are working on this concept on the level of the facades, where we study the exposure of each facade, how sunlight is influencing this perception of daylight. Okay, I think that on this level I've shown that a facade is already a very important interface towards daylight, and it has a very proven neurobiological health benefits. So we take it into account. Views, well, I kindly refer to this kind of book that's on the screen, but I also have it with me. It's appeared last year. I've had a very nice reading during my summer holidays with this kind of book. Lisa Haichong is an architect, but researching already for all her life on daylight, on the effects of views is now one of her latest topics. And she puts a focus on the fact that our body, our brains, but even our let's say on the level of our spine, knows very well what's nature and what's not nature. because in our survival, we need to be able to assess it very quickly. So now a lot of things are put on the market called biophilic, teleological nature. In US, it's apparently a big business, this kind of things. Our body knows it. It knows when an image of a sky is not emitting the 480 nanometers. It knows when an image is 2D and not 3D. It quickly knows this. So nothing better than the real thing. So this circadian stimulus that I just talked about comes from what we look at. And these cells, as already said, are kind of blue sky detectors. And that brings us also to the importance of view, because views, I think everybody of you has been also in a school, especially primary school, where actually they had this kind of stickers on the windows because the kids should not look outside because then they are distracted and not learning right. That's actually a completely wrong approach of this aspect. Actually, mind wandering, has proven to be a very crucial part of how we actually process knowledge. I had a professor at university who said, when my assistants are with their feet on the desk and looking outside, I'm happy because then they're working. So this kind of processing is very important. So the more people daydreamed, research has shown the larger their working memory is, better long-term memory consolidation, better planning, and better incubation of creative things. So actually your brain is, and maybe that's a good news for a lot of you, your brain is working even while you're resting. So I think you should put it on top of your desk when your boss is passing by. And at the University of Lausanne, also a lot of research has been done with eye tracking devices. And they see that people actually who are doing a task are 40 to 80% actually looking to the window to this kind of processing. And if I recall how I was studying actually my courses, it was the same way. I had a window at my left side, and often, let's say each few minutes, I was processing what I have learned. So views, a room with a view, of course, if you are lucky to build in such a site as here, Sergi-Liège, which we have delivering last year, then of course you can take this kind of landscape and views and give this as much as possible to your building occupants. So that not only the patients get this kind of views, also the people who in some other projects would almost be in a blind out space get this kind of connection with nature to let them work harder actually. In this project, a hospital that we are designing now near Lourdes, France, we are even more lucky because there we can give the people views to the Pyrenees, which are there close by. Of course, something that we try to do at max. But sometimes you're more in an urban context. This is a hospital that we're constructing near Doornik, where we are at the edge of the city, but the city of Tournai, people who know Tournai know it's actually a very beautiful city with very, very nice cathedral and ancient buildings. So there we have also been studying the view and the impact of the sun on the rooms, so that actually with this kind of faceted facade, we can also let daylight in from multiple directions, but also give this view even more widely as the kind of old er werd in English more erkers, so how you could sit. Okay, that brings us to the topic of air. And also in air, there are quite some interesting things, because not a lot of people imagine or are conscious of the fact that actually we drink quite some liquids, not only water, but liquids, let's call it that. Food, also the same, although my wife sometimes says that I'm doing more, but let's say it's 1 ton. But air, what we don't perceive, actually we breathe in 2.5 tons of air a year. So we cannot underestimate the importance of air. And what we also don't realize a lot is that actually polluted air is up to 5 times more, indoor air is up to 5 times more polluted than outdoor air. So that brings us to the other bacteria. This is a quote of Jessica Green, a biological researcher in the US. Good germs make good buildings. And when I read that study, it caught me that actually ancient wisdom say, if you have spiders in your home, it's a healthy home. Actually, having the right air biome in your house actually is also healthy. And in this study, which has been made, they actually have discovered that the biome, so actually the composition of the air with also all the small bacteria and all kind of things which are of a big part beneficial to our cars because it helps us in all processing. Some are not beneficial, but if it's in a condition that we are used to be, our body can cope with it. So we see that the outdoor has a very typical kind of biome, while indoor, they have seen, especially in mechanical ventilated buildings, that these biomes are completely different. And they even have seen that by measuring in different rooms, they could say to what air handling unit this was connected, because each air handling unit is creating its own biome. And it brings us back again to Florence Nightingale, who said we should expose people as much as possible to the environment where they are also used to at home, to the outdoor. And if you look at buildings which are naturally ventilated or have openable windows, we see that we have a biome which is much closer to the outdoor air. The topic of microbiome air is quite new. That's Google Trends. If you look at how much it has been looked for, it's only the last 5 years that's actually a topic looked at. But already the American Normative Commission, ASHRAE, so the American Association of Heating, Refrigeration, Air Conditioning Electricians, which normally is a kind of a bunker of technical guys, they have special guidelines for healthcare facilities, and they have got a kind of insight. They said, okay, but actually American hospitals are consuming much more energy than those European ones. How comes? They've seen that in the German and UK norms, actually natural ventilation of hospital buildings is a quite normal thing. It's allowed. Up until recently, in ASHRAE 170, it was not permitted to have openable windows or natural ventilation in healthcare. So they said, oh, how comes? And okay, yeah, we should not do it because there is an Aspergillus bacteria or is a fungus which maybe can come in through our cells and things like that. But they said, let's be objective. Let's look, are there in Europe more pathologies that we describe than in the US? And they've seen, no, there are none. So there is only advantages by having openable windows for better comfort, better well-being, having kind of resilience if there is a problem with the ventilation, just the way that people can control their environment. So a working group actually has come to the clear conclusion that it should be allowed in most of the healthcare spaces, 2020, so very recently. The German law was already in advance, and they say if you have natural ventilation, even humidification is not needed. People who are a bit in HVAC know humidification is quite a hassle in buildings. So in this school near Leuven, we really have made a breathing facade, and often is said, okay, facade with vapor open materials, that's a breathing facade. No, which goes through a vapor open material, that's not really air. I will say it has not some benefits. But there we really have worked in how can we bring outdoor air in a controlled way for several reasons. And you see that architectures even made around that. You see beneath the window, you see a kind of closed masonry, and you see a grille in the facade. Behind the closed masonry, there is actually a controlled grille, pressure-controlled grille, which brings via demand control fresh air inside, but through actually the ventilator convector. So in winter, it's preheated, in summer, not. And depending on the occupation of the space, there is more or less air. So actually, it's a very good, well-communicated thing. With quite very low investment, you can easily bring in more air also during summer if you want to cool down. So, and that looks like that, this element. And at the left, you see this lid. It's actually also a motorized lid, which if during summer, at night, it's outside cooler than inside, the lid's open. So you have automatically cooling down, natural ventilative cooling of your classroom. And even if the teacher is opening the door via the staircase, which also have an opening cupola, they even have a kind of chimney effect, creating more air changes per hour. If they don't do it, maybe they will be a bit hotter the day afterwards, and they'll do it the day afterwards, they will do it. So, but also in this project I already shown, if you look closer, and these are recent construction site photos, you see that, or maybe it's not that well visible, but here we have in every room this kind of ventilation ring part, which is operable in these rooms. Last topic that I want to address is temperature. again, very recent scientific insights. Our norms, which a lot of you are comfort norms, which you know, the higher the class that you go, the more stringent the temperature range is that you should be in. It should not fluctuate more than 1 degree. And more our office buildings are conditioned, our healthcare buildings are conditioned, our cars are conditioned, even our houses are starting to be conditioned. But it has been clear that actually this is not healthy. The fact that we are in a homogeneous temperature is actually not healthy. It leads to issues with metabolic health, insulin sensitivity, cardiovascular problems, and immune systems. And the reason is actually, if you think about it, quite logic. Our body needs to practice. Our body needs to work. Our metabolism needs to be activated. We do that by moving, but we also need to do that by actually experiencing different temperatures. And again, connecting back to what we initially were for hundreds of thousands of years, that's actually what our body is made for. It's trained for that, and it needs it in the end. So that brings us to kind of buildings where we create this kind of temperature zoning, where we create zones where people are exposed in between temperatures, while still creating comfort. So this is near a project near Overijse, where this building at your right is where the let's say the ateliers are for working with people with mental disabilities or physical disabilities. And this glass part, it's kind of a veranda that in summer can be opened and winter can be closed, has natural ventilation, it's not conditioned. So this kind of in-between zone that you have, but actually the building here next to the Flemish government also has this kind of big atra, which is quite equally designed. And to finish off, and then maybe I'll even win some minutes, this is a project we've done in Senegal, Dakar, completely other environment, where the building has been, let's say, based on vernacular architecture, but also how they already knew how you should work with just what is naturally there. But also materials. This is local sand with local shells, which are used in there. But the building is made in such a way that in a lot of cases air can flow through, but by the shading, by the thermal mass, by the orientation, we create a kind of indoor climates which are comfortable to be in. So with this, I thank you for attention and I wish you a lot of good readings.
Thank you, Joost. Should we ask the people to get out between the two sessions?
I think that would be very profitable. Yes,
so that they
you should take your daylight shower for sure.
Okay, thank you very much. So now we welcome Juan de la Venta Granda. He's architect, quality and customer support facade technical team at Consentino.
Yeah.
He will present the sustainable facades with Decton ultra compact surface.
Thank you very much.
Thank you.
Okay, good morning and thank you everybody. Thank you, Zak, for the organization of this event. I remember that I was 5 years ago in another of these events, and it's really great to see that these kind of forums for facades are growing. So today I'm here. I work in the technical department of Consentino, focus on facades, giving support. And today I'm here giving support to our team in Belgium that you are going to meet in the booth that we have later. We are going to talk about sustainability and innovation. That is a main thing in Consentino. We are going to see it in our production. We are going to see what is Decton and the versatility that it has and the system possibilities. And we are going to see some examples and best practices in Belgium. Consentino is a family-owned company, but we have a worldwide presence. The company was born in 1979. It was a stonemason, marble in this area, in Almeria, close to Macael, that is famous for its marble. And the innovation was born from the beginning because the owner of the company decided to start to develop a new material, an innovative material, instead of buying a new quarry. So they started to work on that, and they create silestone, that you probably know, for the countertop application. This was 40 years ago. Now the industrial park of Consentino has around 3 million of square meters. We have 7 factories inside. We have 126 centers. That is the warehouse that we have all the material. We have one here close to Brussels. We have 31 Cosentino cities that are the showrooms that are special areas for designers and architects. We have one in Antwerp, and you are invited to go there. We have more than 6,000 employees all around the world. The turnover of the company last year was around 1,600 millions, and 60% of the market is in USA. Now today we talk about facades. And when we talk about facades in Cosentino, we need to talk about Decton. Decton is an ultra compact material. It is based in a unique technology. It's similar to the manufacturing of ceramic, but we have a special pressing machine that you see in the picture that we can put 25,000 tons on its panel. This means that we can put all this pressure on the panel and we take out all the water and all air. So we have a very high density material with nearly zero porosity. We have a density around 20% bigger than the rest of ceramic. After that pressing process, we put the material in the sintering. We have a kiln to produce the panel, 200 meters kiln, and we reach a temperature of 1,200 for the material. This is in resume how we can produce the panel. Cosentino is very focused on sustainability and on the effective use of renewable energies. The factory is in Cantoria, in Almeria, in the southeast of Spain. It's a very semi-desert area, and one of the most scarce raw materials that we have is the water. It's a very dry area, so we reuse and recycle 99% of the water. We use a lot of water in production, we use a lot of water in cutting, and we don't have water because there is no rain. So we are even getting the grey water from the village around the factory to use it. Another thing that we have in Almeria is a lot of sun. So we have a solar plant, a photovoltaic solar plant, that we get 25% of the energy that we use in the plant. We are quite focused as well in recyclability. We are always using recycled materials in our process. We have some good examples like Trillium, for example. The Trillium material is 80% content of recycled material. We have the certificate from carbon neutral for Decton, from cradle to grave. We have the EPD as well, that it has been renewed lately. And we can give a special guarantee of 25 years for the application in facades. That is something that is outstanding. Talking about the material, if we have to highlight three main things, and this is something that we have been talking with architects and designers, one of the main things is the durability. We are 100% mineral material, so the durability of the panel is assured of the material. We don't have any fading of the color, and the material is going to last like the first day. This is very important because when you specify a facade, for the first years, everything looks nice and pretty, but with the pass of the time, you see the performance of the panel. In that case, we can assure that Decton will last with a good performance. We have as well a very stable material. Because of this pressing process, we have a higher flexural strength than the competitors. We are above the ceramic standard, so we have a standard that is above 45 newtons per square millimeter. And we have as well a very low porosity material and very compact. This allows us to have a very good performance in freeze and thaw cycles. As we cannot get water, then we don't suffer any problem of durability. And the other main thing that is a topic in facade is the uncombustibility. As you can understand, we are 100% mineral. The material is rated as A1 in fire reaction. But we will see that when we work in rain screen cladding, we add a mesh in the back with epoxy. So then we are classified as S2, S1, D0. So we can do any kind of facade in any market according to fire. That is a key point. If we talk about aesthetics and design, we have to highlight three main things. We are talking about big slab format. Our main market is the countertop, so we produce big slabs. The standard is 320, 144, but we can now produce 330, 163. But we can deliver the panel cut to size. We have 2 production lines in Cosentino. that, of course, we were talking before about the wastage of the panel, that this is sustainable as well. When you make a design, we try to reduce the wastage as much as possible. So we can deliver the panels cut to size. The maximum size is the slab. And we can deliver the panel as well with all the drilling, cutting, and all the system that we are going to see. But this is important. Another important thing about versatility is the multiple thicknesses. We started working with 20 millimeters, 30, because this is the thickness that we use in countertop. But on facade, we are evolving from 12. That was the main thicknesses some years ago. Now we are working with 8, and lately we are working with 4. And in Belgium, for example, we are working a lot with 4. And this is quite sustainable as well and efficient in installation. 4 millimeters is 10 kilos a square meter. So we are talking about less aluminium, less weight in the weight of the building. So this is important. And with all these thicknesses, we can adapt the different system that you could see in our booth to the different standards and situations, because you know the facade market is very different from one country to the other. So the system that we are using here and the thicknesses is not the same that we use in other countries, but we have this versatility. And we have to talk about color and texture. This is the main thing. When we talk about the facade, that is the image of the building, is a key point to offer that. We have standard colors, but we will see that we can offer you the possibility to mix different colors and textures, or even do your own design for a project. And we have good examples of that. Another important thing is the safety. You will see that for rain screen cladding, when we put our technical floor, we always put a mesh in the panel. In case of breakage during the installation or during the life of the building, we have the security that with this mesh, the panel will not break. The 4 millimeters, for example, it's always have a mesh, because to handle the panel, as you can imagine, you need to use suction caps and metal frame, but with the biggest slab of 4 millimeters, it's a key point to have this safety mesh. About the certifications, we work in many markets. We try always to be and to have the right certifications, because it's the main barrier to be in the market. So we have the European technical approval for some systems. We are working in USA with the Miami-Dade County, ECC, and we are doing as well a lot of tests for projects. We have done a big scale fire test for the different standards that we have and are available. And we are doing as well a seismic test, wind load test, specific for projects, so we can give you that support that you need in the projects. Talking about customization, what we call Decton ID, that is called Decton Individual Design. We have 2 steps. You have here an example. For example, this is Decton ID Pro. Here we have an existing color that is white color, money, but the architect wanted a texture more rough. So we could do it very easy, because we have the color, we have the texture in the production, and we mix it. This is the first step. But we have another step that you can see in the project in the right. This is Scalebax in Gothenburg. In this project, the property has a material. I don't remember if it was a natural stone or another ceramic from another country. And they say, we want this material because this material is a small size, it's very heavy. Can you do that with Decton? So we start the process with our research and development department, with the architect, with the designer, and we make some samples and we try to convince our client. And at the end in this project, we develop 3 different colors. There is a black one, a red one, and a green one, with veining, with marble. And this was produced for that. And this was the key point to get the project. And this is important because we have a big factory, but we are aware of the importance of the design of the facades. So we can adapt, and we are flexible to offer this possibility to the projects. When we talk about system systems, you will see in our booth that one of the main things of Decton is very versatile. We can work in a direct adder solution without the mesh, with a cement-based adhesive. We can go on ethics as well. If we talk about sustainability, ethics system, AF system is very common. Normally it's painted or with a render, with acrylic render, but we can glue as well Decton if you need it. We can go on a curtain wall projects. Now we are working gluing 4 millimeters to a honeycomb, so we can do 3D elements. So Decton was born 10 years ago in the market, so we are still growing and open to new applications. And I think this is good from a designing point of view. We are going to focus today in the Belgian market in three main systems. DKT1, that is the undercut anchor that we are going to see. DKC, that is what we call the chemical anchor with gluing system. And DKR, that is a screw or riveted. The undercut anchor, you probably know, is a mechanical fixing, non-visible. This is the main thing that the market is demanding. So in that case, we can go with full slab, vertical, horizontal, and we have to drill the panel in the back. We are 35 with a ETA. We have the Claeys solution, Claeys anchor, that you probably know, or the Fisher. We have the certification for both. We drill the panel in the back. It's a special undercut anchor that you can see in some mock-ups that we have. We can deliver the panel with that. It's important that we do the drilling according to the static calculation of an engineer, but we deliver the panel. And then the installer can put the anchor and the hanger, as you can see. Then we have vertical profiles, standard and horizontal. We put the panel and we regulate. It's a very easy system to install, but it has a very good performance of wheel load, because depending on the wheel load, we can put more or less hanger. This could be what we can call the top of our system. This is a nice example of Munich with a unitized panel system. We have as well the gluing system. You probably know that. We are working with different suppliers. We have the vertical profiles. We can go with full slab, visible, invisible fixing, and we have to use cleaner, primer, depending on the supplier. We need to use different kind of systems, and they have their own certifications. This is a nice project in Brazil with a faceted facade. And we have as well the rivet system. This is quite new for ceramic. When we started to develop that, people say, no, this is not for ceramic. People don't want to go to see a rivet if you put a ceramic. But we are working with that, and it's been installed in some projects. This is an office building, for example, that we use, and we are working as well even on Decton screw on wood. This is one of the projects that we have done, and it's been interesting in some markets because you have a modern and industrial look. We work, of course, with big partners, and this is a key point because we are only the cladding, but we need the system, we need the fixings, and we need the installers. So this is a work team. This is some of our main partners in Belgium that you probably know. And as well, we have a lot of partners in chemical anchor. That is the main system that we use in Belgium. And now we are going to see some projects. I'm going to pass it quite fast because I have only 20 seconds for that. But this is a single house. This is one of the first projects that we did. This is 12 millimeters. The 4 millimeters was not even available. So this is glued with 12 millimeters. That is a heavy panel, 30 kilos. This is another project in Antwerpen. This is just a wall that has some waterproof problem, water infiltration. And they did only that with a special design and undercut anchor. This is a very nice project, Music View. Sorry for my pronunciation, but this is a glued 80,000 square meters. And you can see that here Decton is a facade, but it's always a roof. We are not working in roof, but we have some nice examples. And the material performance is quite good. You know that the roof is always very exposed to sunlight. This are some photos of the application, full slab on soffit application. So it's a very interesting project. This is the Duke. This is a renovation in Brussels. We did the courtyard. We supply all the panels cut to size, as you can see here, with a special design from the architect. And we did as well a top volume. This is another renovation. This is a hotel and restaurant. This was an old building from the 70s with problems in the concrete solution of the facade with carbonatation, and we did the renovation. I'm finishing that. Yes, another project, mainly gluing system renovation. And I'm going to finish with the last that you probably know. It was finished in March this year or April. This is the casino in Declercq. We did all the plinth element that you see here, that we see here some photos. This was done with a Decton and Fisher solution. Okay. Thank you.
You did it well. Thank you.
Okay.
Thank you, Juan. Yeah, as architects and as engineers, we always try to find solutions for the different environmental challenges. But it would be impossible without the industrials, that are responding at our requests. So now I would like to say hello to Raimond. Raimond Starmans, Country Director Germany and the Netherlands at Glass. We will present dynamic glazing in smart buildings with case studies.
Thank you.
Yeah, thank you.
Good morning, everybody. Goedemorgen. So I would like to explain a little bit about, let's say, the mainstreaming of smart windows. I think this morning we have learned a lot already about, let's say, how people want to stay connected to the outside in many environments, if it's schools or hospitals, yeah, and I want to explain a little bit more about this. So, which things I would like to discuss with you a little bit is like the macro trends, let's say, who are changing at the moment in the building environment, also about the technology, and I want to show you some projects. When we look at the macro trends, we know that at the moment, let's say, smart and adaptive technologies are getting more and more important and are more and more applied into the buildings. Before, for instance, COVID, it was technology which was nice to have. And nowadays we see after COVID that it is a must at the moment. Let's say to have smart buildings, having adaptive technologies, let's say to be in line with the requirements which are valid at the moment. Of course, wellness, we have spoken this morning before. If you have more daylight, if people have more view outside when they're lying in hospital, study has proven, let's say that somebody is staying, instead of 1 week in hospital, he is staying 5 days in hospital. Yeah. So we have studies which are also underlining that. And of course, we need to talk about sustainability. Of course, we all know sustainability is getting more and more important, yeah. But we should also, of course, distinguish, let's say, the embodied carbon, let's say, which is very important in the facades at the moment. And with our technology, you can get rid of the external sunshade blinds on the outside, which is, let's say, making the CO2 footprint or the embodied carbon less in your building. When we talk about the intelligent window, of course, we have few things where we need to think about. First of all, let's say, how should it look like? What is the appearance? Yes. Of course, we also need to talk about how does it look not just from the inside, but also from the outside. How does a building with smart glass, in this case, electrochromic glass, look like? And of course, it's nice that it is available, but is it also available on large scale? And I will show you some examples out of that it isn't available on large scale. We all know the weather is dynamic, let's say. The sun still comes up in the east nowadays and goes down in the west. Let's say, why do we have these, let's say, shades or buildings at the moment which are still not dynamic? We can change this with our glass. How does our technology look like? For your information, Sage glass is indeed not just supplying the glass which is used where the electrochromic layer is on. No, we supply, Saint-Gobain Sage glass, the IGUs. So either it's an IGU or is it TGU, so a DGU or TGU, triple or double. We have the possibility to produce these on the requirements which are needed for the market. So for instance, if it is for roof glazing, like we see here in the auditorium, for instance, or in the atrium next door, yeah. If somebody says, I have a roof application and it needs to be walkable for cleaning applications, etc., we can supply it with the outside glass of 10 millimeters, for instance, or 8 millimeter, yes. And if you are having this building next to a highway, we can say, you know what, we put some PVB in there with special acoustic properties. So we really can make Sage glass according to the wishes of the user, of the architect, or the owner of the building. So what do we see here? We have, let me see, okay. We have the outer glass. Then we have, let's say, the outer glass is built up out of a SGP layer. And then the inner glass, what you see here, let's say the little gray one, that's the glass where the coating is on. Yeah. That's what you see here. The black line is the coating. Then we have a regular build-up, let's say, of a normal IGU, as I explained to you before, let's say, based on the requirements for the building from the architect, etc., etc. Yeah. I go later on in one slide a little bit more deeply into the technical properties of the product. When we look at Sage glass system, and this is a very simple schedule, let's say how it looks like. We have the glass. Each glass has a connector with a cable. That cable, again, is connected to a control panel. Into that control panel, there is also a sensor. What kind of sensor is this? Either it's a roof sensor or a facade sensor, which is doing nothing else than measuring, let's say, the light. So a certain lux value is going into the sensor. And due to the set values what a customer would like to have, let's say the glass darkens or the glass gets lighter again. Yes. This control panel is also connected to the computer, which is using all these algorithms, which is...
Okay.
Oh, they are testing the next mic. Sorry, it's not me. I thought somebody was sleeping. Yeah. So next to this, to the set algorithms, you also have the possibility, let's say, to connect it to the building management system. So if you have an HVAC system, if you have a heating system or whatever, it also can be connected to this one. Yeah. This can be done completely automatically, but it also can be done, let's say, manual by override. What does that mean? Automatically, you got a sensor on top and where we put in the lux and then the glass gets darker. You also can do a manual override. For instance, in the morning, if you have a meeting room facing on the west side and the sun is still not shining, you might say, you know what, I got a meeting room there. I need to give a presentation. You take your telephone, you got an app there, and you say, I want to have room 2121 darker. And darker means down to 1% light transmission. Or you can do it in a complete integrated system with BACnet connected to the building management system. This is just showing you, let's say, that it can be done via an app on your telephone or on your iPad.
I tell them every time they finish.
Sorry. Here we see the numbers, let's say, up from the glass. So we can see here that we have 4 stages, the clear stage. You can tune it down a little bit, like we call light. Then you got the middle stage and you got the full, where you fully darken it. And you can see we can go down to less than 1% light transmission and still have optimal glare based on this. And you can still keep on looking outside. And you got a solar factor of 0.03. Yeah? Of course, one of the challenges what we had to overcome is the following. The EC light technology is also creating one kind of a color. Yeah? Either it can be bluish, it can be gray, yeah, and people don't like that. Yeah, and that's why we at Sage Glass have worked on a new technology which is called Sage Glass Harmony, which means it's a kind of gradient. What you see here on top to down. On top, you can put the glass on 1%, and then it goes down to 16% approximately, and then it goes down, depending on triple glass or double glass, it can go down to 54 or 60% light transmission. You can compare it a little bit like the windshield which you have in the front of the car, that gradient, that it goes nicely. Yeah, we can also do that with this glass. The great thing of this technology is also, let me see if this one works. Yes, what you see here now, the glass is tinting on top, from top to bottom, or from bottom to top. So that means you have the good combination of sun shading where you want to have it, and also natural light coming in. And you also can do it completely. Yeah? So here is again a kind of diagram which shows what you can do. You can put it completely from 1% to 60%, but you also can do it as a gradient, top down, or you do a reverse. And Sage Glass is the only product at the moment in the market where you can accomplish this. Why have we chosen for this? First of all, we want to have, it was already mentioned before, the rendering index should be in place, that the color really is the color what you would like to see. And it also creates a kind of similarity what the eye likes to see. Yeah? Like here you see the ocean and the sky gives you also that gradient effect. Here we see the color rendering, where you see the clear state, you see the gradient, which is almost the same. And in the full tint, you have a little bit, let's say, different color appearance. Another topic which is very important is also the improved exterior aesthetics, what you would like to have. In the past, it was the fact that EC glass from the outside looked dark, black, which was not what they wanted. So we have also the possibilities of adding bright silver coatings on the outside so that the glass looks far more natural. For instance, here we have a project which is the Nestle headquarters in Switzerland, which was a renovation project which we did. And you can see you got a nice bright appearance of the complete facade. Here we also see some different glasses. The first one is sage glass with bright silver. Then you got two other products which are also in the market, which are dark black again. And then you got the regular sage glass on the right side. This was a mock-up which we did because, as I told you before, we have 3 stages where we can put the glass in. Yeah, but the glass should, from the outside, should look the same in all stages. So if you have glasses next to each other with different stages, thin stages, it should look the same. And what you see here is the yellow ones. Here, these are all at a different thin stage, but they look all the same. Here you see competitor, let's say, material, where we see different thin stages, but also from the outside they look completely different. And that's of course not what they want. And here on the right side again, you see sage glass harmony with that bright silver appearance. The first one is light, and then you got one which is in the clear stage and another one in the light, and they all look similar. When we look at worldwide references, at the moment we have indeed thousands of projects already supplied with our technology, with our sage glass in there. Where do you need to think about? You need to think about offices. You need to think about healthcare. Yeah, like, as I stated before, it really has some benefits. Also in restaurants, our products are very well used, because also restaurants don't like to have these external shading devices. Shopping malls, of course, museums. We have done several museums. Education and airports. Airport, especially in the US, is a very big market for us. Let's say that they are really using our products a lot for skylights and for big facades. We all have experience when you are at the airport and you are waiting in at the gate and the sun is shining. You don't want to stay there. When we talk about large-scale projects, yes. For instance, here we have 4 projects which I've chosen. 5,500 square meters, which was the Castle World headquarters, also in the US. Then we have the Google headquarters in Bangalore, in India, which was almost 20,000, more than 20,000 square meters. Also, a life science project, 15,000, and the Millennium Center in Switzerland, where our European headquarters is, by the way, is also 6,000 square meters. One project I'm very proud of, everybody says, yeah, what's the price difference? How much does it cost? It will be only very fancy for big projects, etc., etc. In Germany, we managed to have a contract with Lidl, and everybody knows Lidl, let's say, I think in Europe, is considered as a discounter supermarket. But Lidl also has chosen our products for their facades. And since 2020, we have almost 275 nowadays Lidl shops in Germany who have chosen our facades. So what have we done with them? We have designed together with them the facade. They have standard sizes for each Lidl shop. The design is the same. We have those products ready for them into stock, yeah, and we ship those products out. What is the main benefit for them, or the reason that they've chosen our products? They were fed up, to say it like that, with the maintenance of the sun shading outside, yeah, in the spring and in the fall with the storms, etc., etc. Yes. And they wanted to have the connection to the outside for the customers, but also for their employees. For Lidl, for instance, we also have the possibility, due to the fact that we have this computer system, to have remote access. So if somebody in Lidl shops says, hey, window number 21 from the shop, let's say in Brussels Midi, that glass is not working, my tech service guys can go remotely into the computer, check it out, and they do adjustments to give a little bit more electricity or less electricity if a glass is not completely functioning. So we can do maintenance and support for these projects. Here you see an example, which we also some examples of projects which I promise you. For instance, this is the Grace Architects in Liège. Here you see nicely that a part of the building is tinted and the other part is not yet tinted. Yeah. This is headquarters of Otto Fuchs in Germany, Meinershagen. This looks a very nice, clean facade. All glasses are tinted. No external shades or blinds anymore. The Lilienthal House, also in Braunschweig, also in Germany. This is a new building, and they also were really against external shades. the Millennium Project, what I told you before in Lausanne. This is a renovation in Aachen, not so far from here, where they also wanted to get rid of the sunshades, and we installed sage glass. This is a renovation project which we did in the US, where you really can see the difference of the facades. What are we doing? We are helping the customer from the design completely until the end, let's say, where we do the studies and the tuning for the projects. Again, from the design phase, construction, installation, and commissioning. And also, if the glass is installed, we give education to the people how to use our products. So we are ready for the future. It can be connected to the complete building automation system. Yeah, so it's almost a must nowadays for the high-tech new buildings. And then you can ask yourself, where would you rather be? Oops, okay, one back, please. Yeah, in the right or in the left room when you are working. These are some of our customers and projects which we did. And just for information, sage glass is a part of Saint-Gobain, so we have some experience, let's say, with glass. And if you have any questions, I'm next door, let's say, at the exhibition area. Thank you.
Thank you, Raimond. Thank you, Raimond. Should we invite the people to Paris?
Pardon?
Should we invite the people to Paris?
Of course, everyone is welcome to come to Paris.
Because like this, they can see your showroom. And Paris La Défense.
Yes.
I make some commercial for myself also like this. Because we have designed with Arcorin and with the architects Valo de Piste, the Saint-Gobain Tower, where at the top you have an extraordinary showroom where you, with the Sage Glass technology, they can make the room completely dark. It's a cube at 150 meters, 160 meters high. And everybody that is working in our sector can go there and have a show about how this functions. So, thank you. Okay, so now for the last presentation for this session, I would like to ask Raimond Preter from Bureau Bouwtechniek and also Ruben van Vooren of the VUB. They will talk about assessment framework to support decisions in facade renovation projects. And please, for all the speakers from this session, stay in the room at the end of this presentation. All the other people, they can go outside, but you should stay for the group picture. Thank you.
Good morning, everyone. I'm not sure if you hear me well at the moment because I was told they need 30 seconds to fix my mic.
Yeah, it's perfect.
Okay. So good morning, my name is Ruben van Vooren. I'm a PhD researcher at Vrije Universiteit Brussel. I'm doing research on the reuse of facade products in collaboration with the Bureau Bouwtechniek. This is Raf de Preter, who is an architect and facade specialist at Bureau Bouwtechniek. And together, today, we want to talk about an assessment framework in order to facilitate or support decisions in facade renovation projects. And I want to start with this last part of the title, support decisions in facade renovation projects. Because if we want to talk about this, I think first we need to answer three questions. Who decides, when and about what, and how do they decide? So first of all, who decides? I made a scheme of the decision-making power in a redevelopment project and how it's divided over different actors. In the center, obviously, you can see project developer and investment committee who actually have a decision-making power, while surrounding you have different actors who can influence or support these decisions. I think as a start, it's important to realize that we as architects or engineers, we're only one of these individual roles who can support these decisions. Then when are decisions made and about what? Throughout the projects, during every project phase, the level on which decisions are made is getting more and more detailed. And quite often, as architects or engineers, we're only involved in a project from the competition or design phase onwards, so to facilitate a facade retrofit strategy. But often before this, during the acquisition of a building by a redeveloper, already quite large decisions have been made impacting the facade renovation project as well. For example, whether a building will be renovated and how it will be renovated, or it will be demolished. And on the other hand, it's only later in the project, often during detailed design, that we're starting to think on a material level and materializing the facade. While we know that the possibility to influence impacts and costs throughout the project decreases when the project proceeds. So that's why we suggest actually to include these facade retrofit strategies into the decision making on a building level. So move it forward into the project, maybe even before the preparation of a design brief. And at the same time, if you start thinking about reusing of existing facade products, maybe we also need to start thinking on a material level earlier on in the project. How are decisions made? Well, in an ideal situation, it's based on a very comprehensive and integrated feasibility study. And in practice, of course, it's sometimes more difficult, so it's separated in different feasibility studies. In here, we will provide a couple of examples of two types of studies. The first one of studies on a facade level, and the second one on a material level. How do we assess these, or how do you execute these studies? Well, in general, it's with this type of framework. So you start with sort of a clear definition of goals, a selection of criteria, the building audits or facade audits. Then you design different retrofit strategies, analyze them based on different criteria. And then you synthesize the entire analysis in sort of a decision-making framework to finally come to a decision or recommendations. In here, it's obviously presented quite linear and quite straightforward. We all know in practice it's more iterative and it's maybe more intuitive as well in practice. And after Preter will now provide two examples of these type of studies.
Hi, good morning also from me. So the first case study is a building in the center or near the center of Brussels in the European quarter. It's a big office building of 80,000 square meter, and it's built in 1968. And the facade is a load-bearing concrete prefab facade, where it's been asked what to do with this building in a very early stage. For this study, a lot of colleagues with different expertise were working on it, or not working, but really give their advice. Not to end up with a very large feasibility study, but just to, from the start, have all ideas together to be sure that from the start we have or can start with a good analysis. As Ruben said, you first have to start with your goals. So in this building, you have some material technical issues. You have a lack of insulation, of course, give comfort problem, but also for energy reason, it's not contemporary anymore and not in the good direction. For this building, there was no issue with the image itself, so there was no question to change it in a way. At the start, we selected some criteria. Ruben put it in a very clear framework of 4 categories, but we did it more intuitively, and of course it's nice to see now that it's part of a bigger concept. The building itself, it was in pretty well condition, but there were 3 attention points. First, we have the car park where there was damage on the concrete. We have a very low free height, even with the small finish package. It's only 2.64 meters. So this will influence finish and organization of the the techniques. And then a last one is, like said already, the skin, which is not performing well with risk on condensation, but also comfort issues and energetic issues. Because we're in a facade event, I go further on this last one. So for this case, we selected 6 strategies, going from inside insulation to outside, a typical outside system, till demolishing completely the facade and putting a new burying construction there. For us, it is, or we believe that it's important to, from the start, make this kind of principle sketches, because it shows the complexity of the project. Certainly, if you're working on existing projects or existing facades, and then each of these strategies we check with all the criteria we selected. We give them a color, green, orange, red, and a small explanation why this color has been given. And then to end up, we bring all the strategies together in a kind of overview. We call it a decision matrix. Not to find the mathematic solution, but more as a kind of guideline in what direction we could go, and what at that moment are the advantage and disadvantage of a certain choice. To end up with a recommendation, also here we like to make a drawing with the situation and also with the questions that we're still having. And so in the early phase, not everything is analyzed. But if not analyzed, we just point out, yeah, this is an issue to work on. And then for this case, we end with an image of Atema architects who, after our recommendations, there was a competition, and this is the competition image. With a lot of potential in this new building, and taking into account also, of course, our recommendations. A second case is in Ghent, Hoog-Ghent Campus Vesalius. It's in the south of Ghent. It's a campus from the university college, so a student setting. And here it was not a question to look at the complete building, but only at the facade. Also here we list up some criteria, and some of them were very specific. For instance, in this case, on the left bottom, influence on the roof renovation, it's of course very specific for this project. Client asked to split roof renovation and facade renovation, and for that reason we put it in the list of criteria. And we will see then that certain facade systems or certain solutions will deal with it better than other one. Also here we could say that the facade was in a good condition, but also here, of course, there was a lack on isolation, and also some damages on the concrete, and also there were doubts, because this is not a load-bearing facade. There are doubts on the anchoring of these panels. So the moment that we would decide to keep these concrete elements, we will re-anchor the concrete. We end up with, in this case, at first time, 7 strategies, but also we added some strategies or on question of the client who would like to check a certain material, or for us really go to material and check or search how we could lower the environmental impact. And then here you see overview of the environmental impact as a small part of the analysis we did. And an overview of one strategy, again, similar as the earlier case. To come to, in this case, a very big matrix with a lot of criteria and a lot of concepts. And we added a line, this one. It's a line that manipulates the weight, because the more criteria you have, the less one criteria will have influence on the overall. So this is a kind of way of bottom to change results. Of course, always in together with the client or everybody involved. We say we're gonna, for instance, maintenance will be more important than we can rise or we can rise this weight. For these two cases, we were thinking on if not the material that is on site, to add new material. But of course, we also interested in if it's possible to go with reuse or refurbished material. And this is what Ruben is going to talk further on.
Yes, so these two examples showed studies on the facade level. We also did a project in which we estimated the reuse potential of existing products. So more study on a material level. The case study is a project in Berlaar. It's a small pilot project, probably not the types of facade or projects you're used to see in these type of conferences. But it's a perfect situation, I think, to test out new innovations and to work with existing materials as a start. So it's a renovation project of about 60 dwellings, which were built in 1982, owned by social housing companies Zonnige Kempen. And during the renovation, more than 400 steel windows and 100 doors, including double glazing, were renewed. And the question from the client to us was, what can we still do with the existing products any better than the business as usual, so recycling for steel and downcycling for glass? That was the main question. Although we entered the project too late, let's say, so we couldn't save all of the materials, we couldn't re-implement them in the same project. Again, of course, there's an entire strategy we proposed how to deal with this study. I'm not going to delve into this because I think you all deserved a coffee break. So we'll jump quite quickly to the results of the study because I think it's more fascinating. First of all, to get an idea, it was a wide range of different types of windows and doors. And in total, it included about 61 tons of embodied carbon, which equals 23 years of heating a single family home on gas. You could say, okay, that's relatively limited in comparison to the structure or large renovation projects. But still, we thought it was worth it to put an extra effort in studying the existing products. Obviously, because reuse is also not only about embodied carbon, there are other aspects, environmental ones, but also social ones, etc., which are relevant as well. First of all, the insulated glazing. The issue of insulated glazing, I think it was shown very well in the presentation of Maaike Berckmoes in the beginning. The life expectancy of an IGU is about 30 years, while the life expectancy of flat glass paints is way longer. Basically, when we discard of an existing IGU, the flat glass paints can still continue for another life cycle of 30 years. And that's when the idea of remanufacturing comes in. So you take a subcomponent of an existing product and you reapply it in a new product. In this case, you reapply a non-coated existing flat glass pane together with a coated new flat glass pane, together with a new spacer, desiccant, etc., in a remanufactured IGU. That's theory. Now in practice, so the windows were demounted from the facades. They were stored locally on site in garage boxes, which were also owned by the clients. And why were they stored intermediary there? Because it was to optimize the transportation by the remanufacturing company, which are located in Almere in the Netherlands. They're called GSF Glasgroep, and they've been doing remanufacturing for a couple of years now. And to optimize transportation, there was intermediate storage until there was a sufficient size of batch to fill the truck. So it was transported to their site in Almere, where first by hand the remaining sealant were mainly removed. And then the two glass panes were separated to a semi-automated process using a machine which is developed by Hegla. Hegla is a manufacturer of assembly machines. Now they developed a disassembling machine in collaboration with AGC and GSF Glasgroep. So the two glass panes were separated, and afterwards they were cleaned, and there is a quality control process in accordance with the existing norms. That's where all the glass ended up right now. It's stored to be reused in other projects, so we could save the glass in the end. For the steel windows, it was a different story. I have to say from the beginning, we weren't able, in the context of this project, partly because we were involved a bit too late maybe, to save all the windows, but one. Because Janssen AG was also involved in the project as a collaborator. They finally made a mock-up of one remanufactured window system, which I will show right away. So at the right-hand side, you can see a rendering of the idea of their manufacturing concept, where they reuse one non-thermally broken steel window section. And they add insulation, a metallic cover as a fixed window part, and they add a new Janisol opening window part. Together, it creates a remanufactured unit. They also made these calculations on the thermal performance, where you can see clearly that the existing situation on the top has been drastically improved in the remanufactured situation on the bottom, which is in accordance with the current standards for window sections. This is how the final mock-up looks like. The white parts are the reused, the reused parts from the existing sections. Which have been blasted, recoated in white, while the dark blue parts are the new ones, the new steel sections, the Janisol sections, which have been added, also with a metallic cover on the top right. I don't know if Ron Jacobs has brought the mock-up with him today, but at least based on this picture, I think it looks as a great result, and we were very happy to have been part of this innovative development. So to round up, feasibility studies allow to increase the quality, reduce the uncertainties, and push innovative reuse practices. They can do so on a building level, on a facade level, and on a product level. But of course, preferably as integrated as possible, because we as architects and engineers, that's the way how we can lever our impact most, and that's of course our goal. Thank you.
Can you give back your micros upstairs? Yes, thank you. Okay, so it's time for a break. We have 25 minutes coffee break. Okay, we will start this second session with Stéphanie Mangé, and that will represent Gevelinzicht Ingenieur-Architecten, and she will present the case study of Canal Centre Pompidou.
Hello, yes, everybody hears me well. So I'm going to show the project Canal Centre Pompidou, and specifically the Piano Nobile Façade, the facade engineering of it, and the approach, our approach, its efficiency, and low carbon reducing approach. Okay. First, I'm going to propose our Gevelinzicht. So we are a team there on a visit in the canal. Now, the other days we were only 10, but now we're 16. We're based in Antwerp, and we deliver these services, so facade engineering, building physics, durability advice, renovation projects, and master planning, and expertise in building pathology. These are all the parties who were involved in the project Canal Centre Pompidou. So we worked for Atelier Canal. It's a joint venture between 3 architect groups or offices. So NOAA, the Belgian one, EMTN, the Swiss office, and then the UK-based Surges and Bates. So we did the facade engineering and the building physics of the existing shell. So not the new volumes. The story about the Piano Nobile Façades, of course, involved other advisors. So, for example, Cal, acoustical advisor, and EPB, the energy advisor, and excuse me, and of course, Claeys, the structural advisor. And we started in 2019 when the tendering stage started. And it's still going on now. We are 2024 now, and it should end, let's hope, in 2025. And then for the Piano Nobile Façade, we involved also survey engineering architecture. It's a structural engineer, Lotens. It's a firm specialized in steel frames, and then AGC Finio. So first, a very short introduction to the project. So it's a big site near Saint-Declercq, or at Saint-Declercq in Brussels, and on the corner with the canal. Here you see the left, you see the old image of the showroom. So that's the iconic facade at Saint-Declercq. It's a building from 1930. It's not declared heritage. Here you see images from the competition. So Atelier Canal won the competition with a statement to build a new interpretation of a cultural institute in Brussels, a stage for Brussels. And here you see the existing spaces. So the showroom on the left and the workshops of the, I didn't say before that it was a former garage for Citroën. So here you see the existing spaces almost intact, and you see also that it's not only for or dedicated for art, it's also kind of in between zone where other things could happen. When starting the facade engineering, we got a very clear vision from the architects. They really wanted to, I quote, touch as light as possible the existing envelope. Okay. This is a plan of the whole site. So left you see the showroom at the Saint-Declercq. Above is the canal, and the architects designed 3 new volumes in the center of the site, and in there are the functions with really high demands of high demands on acoustically, energetically, comfort, safety, of course. The one above there is the Centre Pompidou Art Center. Well, it will be operated by Pompidou. And then right under is the CIVA. It's the archive for the city archive for architecture and cities. And then left, it's more a combination functions of an auditorium and logistics and administration. So here I marked the Piano Nobile Façade. It's so a 3-sided facade. In total length is 600 meters. Total surface is about 2,500 square meters. This Piano Nobile Façade, so the exterior you see kind of modernistic facade, completely out of glass and steel, and a big corniche in concrete. We call it the ribbon. And in the inside you see the former workshops of the Citroën. So a lot of daylight come in through the roof lights and the facade itself. So when we started, this facade was almost untouched, except on the ribbon, the concrete ribbon. There was steel cladding. So here you see images more close of the window of the Piano Nobile facade, steel and glass, and the steel was actually in quite good shape. At the inside, you see that this facade has openable windows with a kind of manually with a bayonet system. And behind the facade, you see the truss columns. Those truss columns bear the ribbon, but also the roof structure and the floor slab. This is a microscopic image of the layers on top of the steel. So up to 10 coatings were found. The base coating was a coating with lead, so very, very good anti-corrosive. And the layers on top were, some of them were having zinc, so also very good anti-corrosive. So that explains why, in 2019 the window frames were actually in quite a good shape. So more in detail, it was not a perfect state, of course. We saw on horizontal surfaces pit corrosion, and then also in some spots, mostly locally, bigger corrosions, and that was related with leaks in water and air tightness. Anyhow, we decided that the frame itself, the steel itself, could be reused. And of course, a retreatment was necessary or is necessary. So it means that we have to blast it and remove the layers which are loose and retreat it with a triple system for corrosive resistance glass of C3. So these are the type details, and more of them, of course, but these are the type details. So it's the framework is built up with T profiles and L profiles. So the T profiles are welded on the L profiles, and then the frames each other are mechanically connected. So the existing glass is a 4mm simple glass. Is fixed with little L profiles, and it's not drawn, but there is of course an outer sealant. It's not a silicon sealant, but it was an old sealant, unfortunately with asbestos, so it was very hard to remove it. Maybe also interesting is to see that there are differences in. I'm going to show. So the depth of the L profile and the depth of the T profile was different. So the T profile, seemed to have more structural function. So it would suggest that it is a kind of curtain wall system, so deeper profiles in vertically. But this slide explains more structural how this facade is working. So we have 3 frames which are completely welded on top of each other, and so 1, 2, 3, and then these are supported by 3 in between horizontal beams. Well, it's not really a beam. The lowest one is a kind of 3D truss beam, and then in between we have what we call the traverse. It's a very small, slender beam, and those two are pulled up by a vertical puller at a concrete ribbon. Yes, okay. When we started the study, we did a 3D survey of the facade just to know how much it was deformed. We could see already that it was not a flat surface. So we did a very detailed 3D measurement, and also to investigate, for the new fixing system of new glass, do we have space enough to put in this deformed facade the glass panels? So we took out, I think, 3 or 4 travées, so in between 2 columns. So this was actually the most risky in terms of wind load. And you see the marked numbers are the ones which were a problem. So these frames were so twisted that it was not possible anymore to have a flat glass panel fixed in it. The deformations were too much. I can explain with this one, for example, that the difference between the bottom left and the upper is more than 3 centimeters. And also these are different, so we have a 3D twisted frame. So the conclusion is that the frames need to be flattened a bit for some parts to get new glass fixed in it. I forgot also to tell is that the retreatment the frames were took out, so it was the dismantling, and so the retreatment could be done all-sided. So then we did a structural control of the facade, of course, and the wind load was important for sure for one orientation. We had a kind of discussion in the interpretation of this wind load because of the canal. It's very open, so it is at least class 2, perhaps even with a stricter interpretation of class 1. So we did the structural analysis together with civil engineering, and the conclusion was that the glass, of course, needs to be thicker. So instead of 4 millimeters glass, we needed 8 millimeters glass, simple glass, and also reinforcements of the framework and the traverse, and so the horizontals need to be reinforced. So the first ideas were, we did it by stiffening the verticals by welding an extra lat on the backside. It's not everywhere, it's only the most heaviest parts of the facade, heaviest loaded parts of the facade. And also the traverse here, extra steel was put in, and also the connection to the truss columns was more fixed, so there was less rotation and more hyperstatical connection. Then another big issue in this story is also the deformation of the primary structure itself. So actually the whole the workshops is a very slender steel construction. So it's a quite movable construction. So when with this heavy wind load of this side, the canal side, the bearing structure moves. Here you see, for example, the column moving 6 millimeters to the left because of this wind load. And then because of the integration of the new volumes, it became actually a bit worse, because in the facade we have the more differential movements of the columns behind. For example, here you see here this column moves 11 millimeters, and the column next to it moves only 8 millimeters. So it this movement of the primary structure induces also twisting in the frame of the frames of the piano nobile facade. So we did together with the contractor did it. Simulation of the glass tensions in the facade, in the glass panels. And it's not very, very visible, but on the top right, you see there's a very critical zone. And that's because of the difference of movements in the primary structure, so the truss columns behind the facade. Okay, now I'm going to show you the, hopefully the as-built details. No, the as-built details. So this is the top detail, so the connection on the ribbon, and you see that the profile is not touching the concrete ribbon. Yes, I forgot to say is that in the original concept, there was any way of movements. The concept was that thermal expansion, there was no space for thermal expansion, so everything was fixed. So we decided to lose the top profile from the ribbon and give a space. So meaning that those frames are a bit shortened to make this 4 centimeter space above. And then instead of a fixed anchor, we put a wind anchor. So this takes only the horizontal load of the winds, and it can move up and down. So now it's not working anymore. Yeah, it's going to move up and down. So in order thermal expansion can be taken. This anchor is not a local anchor. It's a continuous inox plate, and with holes in it. It's marked in yellow for when there is condensation, and there will be condensation. This condensation can evaporate or ventilate through these holes. And then on top of this profile, we have a thermal swell band. Well, it's not only thermal, it's also an airtight swell band, and also with a very good acoustical performance. And then at the outside, of course, we have a slab, a rain-tight slab. Yes, because of the deconnection or the dismantling of the frames, there was also an opportunity to enhance the air and water tightness. So we integrated in between this yellow marked neoprene strips, not only there vertically, but also horizontally. Also on the top, the bottom detail. So in the connection with the 3D beam, you find it. Okay. And we put also we added also a little profile to make this connection between the frame and the 3D beam less risky. And then the openable windows, we integrated a rubber profile there. So not only for enhancement of the air tightness, but for sure for acoustically reasons, it was necessary. And then we go to the glass research. So it was a very important part of the study phase in the aesthetical image of the new glass. So we investigated simple glass with a low emissivity coating, a low E coating, but also other kinds of glass. Normal insulated glass was not feasible because we didn't have enough space, and also because of the deformations of the frames. So we thought about we thought about integrating vacuum glazing and so the AGC Finio glazing. So it's two floated panels put together in between the. Oh, sorry. And in between the two panels, so it's a vacuum. You see, I marked it now in red, some plastic spacers. So normally Finio has a U value of 0.6, but we decided to don't have the very performant low E coating because of the image. It was a bit too pink. So now we have only a U value of 0.8. So this is the fixing of the new Finio glass. If you see well, you see the black points. So the glass rods are not completely into the corner because otherwise we have to measure up every frame because there are differences, of course. At the outside, you see a sealant of 10 millimeters, which is quite a lot, of course, but that was necessary to handle with the deformation of or the twisting of the frame. This it's a project-specific system, fixing system. So together with AGC and Lotus, we did a test in Ghent for water and air tightness, and also the temperature test. Okay. Also, we investigated the risk in condensation. Yeah, of course, we don't have performant isolated profiles. So the top is the simple glass with a low E coating. And you see the steel is, of course, a cold bridge. And then the double insulated glazing, it was just a theoretical exercise because we know we couldn't do it, but it was interesting to see. And you see that the steel is getting more colder, so the risk in condensation is bigger. And then the last one is with the Finio-10 glazing, so with the vacuum glazing. And there you see that the profile is a bit less colder than the insulated. And the reason for that is that the edge of the vacuum glass is less bigger, it's less, it's actually more performant than in the normal double glazing. Yeah, and maybe also to tell is that we did a dynamic simulation, or not we, Garage did the dynamic simulations with these performances of the Piano Nobile facade. So this is showing the climate zones of the different climate zones. It was part of the tender documents showing the new volumes, the very restricted climate zones. Of course, Pompidou with art and the archive. And then the workshops are in a green zone. It's an in-between zone, and the dynamic simulations showed that it was feasible to have a temperature range between 15 and 28. 15 we could manage this or guarantee this 15 degrees with a very low heating system. So only when it's necessary. Low heating system, less than 15 watt per square meters, because in the Brussels regulations, as long as it stays under this 15, you don't have to see it as an EPB zone, so we could exclude it. And then the 28, the strategy was to have a very good ventilation. So also the Piano Nobile facade was part of this strategy. So here you see the openable windows. Before it was manually, and now it's a motorized system connected to the building management system. And there are also big gates, 4 of them, integrated in the facade. So together with the roof lights, the openable bars and the roof lights, you get a very good air flow in the space. So the 28 degrees is guaranteed. Of course, there's also always a bit of hours exceeding, but it was accepted by the client. Then this graphic shows the difference in embodied carbon, so the ecological impact, between a new facade, so a new curtain facade with typical or standard Janssen, for example, curtain wall profiles, and the reuse, so the concept I just showed. There's a big difference. It's 6 times less, and we calculated that we avoided about 61,000 kilo carbon by reusing, and that's comparable with 115 cubic meters of concrete. So this is the result, the first results. It's the last slide as well. I think my conclusion is that it was for sure not the easiest way. A new curtain wall would be much easier and even more economic in building costs, but taking into account the ecological impact and the result, which I think is very respectful. I hope you agree with me. Thank you. Yes.
Did you have any resistance from other actors during the project? Pushing you to this direction to have more a new structure?
Well, we had in study phase, we had the client from the Canal. Of course, they were very happy. They choose also the architects with this vision on the existing building during the execution. So right now it's on the rails, but it has been not so easy to convince to contractor, and some changes has been made. For example, the structural concept has changed. So it was not the easiest way.
We're all facing this problem. So.
Yeah.
Okay, thank you very much.
Yes.
I would like to welcome Joep Römgens.
Very good.
Good, sir?
Yeah, heel good, heel good.
Head of the service marketing and product manager at Schuko. And he will present factors for change, trends in the facade industry. And
I have to look at that time. I'll try. But those who know me, I've got quite some words normally. Okay, I'll skip that part. I wanted to start with myself, but everybody can read, so I'll skip that part. I will start talking about drivers of change. Change, yes, absolutely. Is change needed? I think these things say enough. For example, the big picture is Dubai. In 24 hours, more rain fell this year in April, 14th and 15th of April, than normally in 1.5 years. They didn't know what was happening in such an interesting state as Dubai. Right below Portugal, only last month, September, multiple bushfires, 60 people got killed. And of course, in Belgium, everybody still remembers 2021. The flooding also got killed 50 people just in Belgium. So, yes, do we need change? Absolutely. And this is a picture. This is a book. I read it in 2015. I have to be honest, those days it didn't seem that relevant or far away. But I am sure if I start reading it now again, it will be more relevant than ever. Everybody likes to live on the coast. Everybody likes to have seaside views in holiday season and so on. But having that in Brussels, living in Brussels at the sea, it would mean something for all these peoples in Antwerp and The Hague and so on and so on. But this is the picture if we keep going on like we are going on. It's the picture then, if we don't do anything, this is what will happen. And we will have this country, Netherlands, that we used to know, and we don't know anymore. Talking about these things and what will happen in the future, what can happen in the future, we have to think in different possibilities. This is where the ICPP also made 4 different scenarios, which we are constantly looking at also ourselves to see what does it mean for us. And if we look at these scenarios, the black line is the historical emission, and then we look at what if there is an RCP 8.5, that means business as usual. We keep going on like we're going on now. You see this red line going up, these emissions going up and up and up. The bottom one, the RCP 2.6, that's the one if we have a huge mitigation now. If we fully go on the brake and mitigate all the emissions as soon as possible. This as well projected to temperatures, because that's what we normally know about. We know this, that we don't want to have the temperature rising in Europe. Somebody is ordering something again. The projected temperatures, if we look at the RCP 8.5, this means that we will rise in temperature more than 10 degrees. We don't want that. To be honest, now we are already on nearly 2 degrees temperature rise. So what we are looking at now is that we will, if we keep going on like we're doing now, we will unfortunately not be in the RCP 2.6, but more or less in the 4.5. That's the scenario that we have to think about now when we keep going on like we are going on now. And that means a temperature rise somewhere 3 degrees until 4 degrees, somewhere in that direction. To make it a bit more understandable, what does it mean for Belgium? We are in Brussels now. For the moment now in Brussels, we have roughly 5-6 heat wave days per year. And everybody is talking about it. It was so warm and this and that. If we keep going on like we have been going on, and we have this RCP 4.5 scenario, we will have 18, 19, 20 heat wave days per year. That's 4 or 5 times as much. This means really something. And the heat is normally, you can always think about that, heat has an impact mostly on human beings. So it impacts not that much in Belgium and in the Western world, but especially in the rest of the world, it impacts humans. So death by heat. The right-hand side, that's more to do with flooding and fires, that impacts on assets. And then we get to the next point. Assets come in, and as soon as assets come in, it comes in as well that the economical factor kicks in. And when the economical factor kicks in, sometimes, unfortunately, it's necessary to make change. Because only then people start thinking, and also insurance companies and governments start thinking. This figure is standing there in US dollars, 2.5 trillion. I think trillion, the last time I checked, it's 12 zeros. It's unbelievable. 12 zeros, 2.5 trillion US dollars occurred in 20 years due to weather events. Who pays for that? And who's going to pay for it in the future if we keep going on like this? This economical factor also pointed in The Economist lately, and that I was happy to see that it's a buzz in the insurance world as well, and that's where we see new business models as well. So, what will climate change cost you? Like you have a private house. What's the value of your private house? Looking in the Netherlands, but also in future in Belgium and most of the countries, your value of your house, there will be the climate change and the climate risk factor will be incorporated in it. So if you have a very nice house at the beachfront, but it's a flooding area, your house will be less valued. And this is not only for residential, but also a lot for commercial buildings. We even at Schuko did exactly this research together with consultants. In the beginning of this year, the outcome was that we had one building that was actually in a flooding area, and we had to really look at how to, and it was a building in Wechtingen. We knew it, we acted too late, because in June of this year, the fabrication site in Wechtingen was closed for 1 week because of floodings. And this is something, this closure of such a fabrication, it has to do with climate changes. Never happened before. Also, the European Union started to look at making dashboards of this possibility when a big flood or fire or something else happens. And what does that mean for the countries? What does it mean for your insurance? And it's actually, we're looking at the gap between what an insurance company can pay and what actually then the government has to pay with it. In Belgium, we see we are quite okay. You see that the coverage of the insurance companies is 75 until 100% on all these events. Looking at the Netherlands, it's a bigger risk. Coastal floods in the red-orange zone. This actually means, and it's written there as well, you cannot insure for that. The big insurance companies, they don't insure coastal floods in this, when it's actually related to climate changes. That means something. You can insure your house, but if something happens, everything is gone. So these things really come up now and really make us think in what should we do? What do we need to do? And where can we start doing some things? First of all, well, this figure shows we haven't learned a hell of a lot. To start with, less materials, using less materials. It's important. In the Club of Rome set together in 1968, they already started. It was like a very nice club of politicians, economists, very smart people sitting together 50 years ago and telling and writing an article in 72 saying, if we go on like this and we keep pushing the economy like this and we keep also going on with our consumption like this, it will come to an end. It's not possible. We cannot, the resource consumption will be too high. Since 50 years, we have quadrupled. What have we learned? Not a hell of a lot. We are now there at the blue area, so we need to be sure that this red dot will not occur and will not happen. And that's why we are looking here, and that's why we are, as an industry, needing, this figure has already been shown today, we need to take responsibility, and we together should look at possibilities, what we can do. Also, this already shown, so I heard this morning 15% is the facade. We've got somewhere figures from 25%, depending on what kind of facade maybe, but 25% of the total material emission is based on the facade, at least the windows, doors, and glass. This figure, I think we don't have to go into further deep detail here. We all know the whole life carbon. We all know where we can put and where we can turn on some small or bigger changes. Absolutely don't forget the operational carbon, because that's what sometimes happens. Everybody's just focusing on the carbon emissions in the embodied carbon, but also the operational carbon stays very important. Just keep this building operation with insulating and ventilation and building integrated photovoltaic and so on, keep it up to date. But as well, look at all the other costs, so CO2 costs, so from materials, product life cycle, and so on and so on. We at Schuko, we have kind of bundled everything together to make it a little bit easier, because we've already been working on CO2 and CO2 emissions and all that kind of stuff, and sustainable products, sustainable services for multiple years. And now we said, okay, let's bundle it together into this carbon control and the carbon control toolbox. See it as a toolbox, and every time, depending on what kind of project or what kind of process in a project you're in, we come up with several solutions, and we bundled them then again in the design phase, design to decarb, the build to decarb phase, the operate phase, and of course, at the end of the day, recycle phase. And it's not only the recycling, but of course as well, reuse and everything is in there. I'm not going too deep into all these toolbox parts. My colleagues can help you here in the lobby to talk a little bit more about that. But just to emphasize a few of them, design to decarb, very important. Look all the way at the front of the designing process, because that's where your lever is far most. You can look at the end of the process and say, okay, I take this kind of material, I take this kind of recycled content, and so on. But please look at all the way up front. So that's why we sit together with the architects as soon as possible to influence. Okay, we know we will not influence the full shape of a building because the architect has a vision, has an idea. But what we want to do is we want to talk about the shape of the facade, the shape and the influence that has on the elements, the size of the elements, the amount of material we need to use then, and also, of course, the systems to be used in that. In the operation phase, it's more or less looking at the products and services itself. And maybe even, if there is enough money or the concept is like that, going into building integrated photovoltaic. Because then you have to look at what type, when do you need the money? Because at the end of the day, this saves money, but sometimes you need to pull it a little bit further forward. Or even green facades to get positive CO2 emissions. On the recycle to decarb, that's more to do with what happens at the end. And then we come to reuse, and especially also about renovation. And that's what I want to talk about shortly in the third part. The renovation topic, very interesting and very much needed to look into that. A few facts from the Belgian renovation industry. We want to achieve climate neutrality in 2050, and even in some regions, that's very special in Belgium, we're always divided, in 2045. When we look at that year, we know now already that more as 90% of the building stock that we are looking at then to be climate neutral has already been built. So, left or right, most of these buildings will be there then, 90%. So that means, if you look at the building stock now, 30 to 35% of these residential buildings are energetically inadequate. That's quite a lot for a Western country. But it's the same in Germany, it's the same in the UK, but we really need to step up if we want to achieve this 2050 goal. This means an annual 2.5% refurbishment is required. At this moment, we are at 0.8. So we really have to step up. We have to speed up the process of renovation, and hopefully our political situation will help us, or not help us, but they will see the same and say, okay, this whole process of vergunningen, permit process and all that kind of stuff around it, we will make it a little bit easier so we can speed it up. I think the building industry is ready for it. Looking at the renovation, we can also, we at Schuko as well, we put it in a few boxes. I'm not that happy about boxes, but there is gray areas around it as well. But if you look at the left-hand side, you see the effort versus the extent of the renovation. You really have to look at what can we do with the facades. Maintenance is, of course, the less effort, but it has a really huge impact. So always keep it up to a certain level, a good maintenance level. Reparations is, let's see it, you still keep the same specifications, but you do a repair. With refurbishment, you do kind of a repair, but you upgrade as well your specifications. You get better U values or something like that. With the replacements, we are looking at complete replacing a facade or windows or maybe vent frames. And with a core renovation, you're looking at the full facade, the full body, the core of the building as well. We have been looking in the mirror as well and looking at our systems. What can we do with that? When we look at our systems that we brought it to the market, we kind of drew a line to see what happens. Until 1990, we see, okay, a complete renovation of an element will be probably needed. Everything from 1990, and that's not just 1990. That's when we came up with this nice product, Royal S. From that moment on, our product managers already started thinking about replacements. So everything from that moment on, we can always replace fittings. So we can replace vents and so on. That's a real special feature. So that's what makes us now very easy to replace and to retrofit in buildings. So from 1990 to 2000, let's call it 12, a vent or a complete component restoration or replacement is expected. And everything from then on, you can most of the time go with a refurbishment or replacement of just parts. Here the example of what happens if we take such a window, this Royal S window, 1990s, and we just keep the frame profile and we just replace the vent. You see that we go from a U value of 3.0 to a U value of 1.1. And if you fiddle a little bit with the glazing, you can even go below 1 and you can go to 0.9. Just keeping the building attachment as it is, changing the gaskets and the vent. Changing is be done in 3 minutes. Nobody has to leave the building, which costs a lot of money normally when you do a refurbishment, because in these kind of refurbishments, you're not looking at material costs. Normally, you're looking at logistical costs and time costs. This is done in 3 minutes. Nobody has to leave the building, and you can fully prepare everything in your working environment, your workplace. You don't have to be on the building side. Very interesting. Maybe as well if the frame is not that good anymore because it has a thermal, or it has no thermal break or not a good thermal break, but the attachment is still good, because that's often a very important point. Not only the specifications, but also the attachment to the building itself. Because once you start breaking, it costs a lot of time, it costs a lot of money, it costs a lot of effort. People have to start moving, logistical costs, and so on. And with this kind of frames, add-on constructions, we have solutions to keep the frame as it is, but kind of put a sleeve over it, and then have a solution which is way better and quicker than a complete renovation of the window. Bringing this from windows to facades, actually kind of the same happens. There is a lot of facades from the 80s to 90s. These structures are still very good. The aluminium is in perfect condition. As long as also the connection to the building is in perfect condition, we just need to look at the thermal and maybe also a little bit the aesthetics from the outside, because a building from the 80s or the 90s, a new tenant is in it and he wants to upgrade it. We can leave the building as it is. We build on with adapter profiles, and these adapter profiles secure that we have a full, tight, insulated solution in a new aesthetic look and a new, well, you've got the feeling it's a new building. When we go one step further, if this is not enough, then we go to a full refurbishment. And in the full refurbishment, then we go actually as well, we look at refurbishing from the outside with a facade, integrating directly as well, sun shading, maybe building integrated photovoltaic, and so on, without interrupting the interior. Only at the end, when the full facade has been built, the new screen around it has been built, then we go to the inside. We take away the old windows, maybe even install ventilation system, and we've got a full refurbishment of the building. So that's the next level in refurbish, where you do a full facade refurbishment. One extra example, because these kind of systems are often project solutions. You have to do a full research on what kind of building do we have, because these buildings from 60s, 70s, 80s, unfortunately, they are not all digitalized. They don't have a digital twin, and so on and so on. So we need to look at the situation itself. What do we have? And this, for example, this was such an example of a building from the 80s with balconies. And the idea was we need to upgrade this. So instead of building a complete new isolation around the balconies, we put a full facade in front of the balconies. And the facade has this folding sliding solutions. With these folding sliding solutions, you can open up your facade where you still have a balcony solution. So first, very important, a cost saving of 10 to 15%, but as well, you bring much more happiness with the tenant, because he has got more living space and he can use his space much better. And the whole building itself keeps better protected as well, because it's a screen all the way around and not just on the isolation of the balcony itself. Well, this can be done with windows, with sliding systems, and in this case, with a folding sliding system, we've made a special product, the FD90 Reno. Of course, Reno is for renovation, where it's specific for these kind of solutions, where you don't have to have full size floor to ceiling, but just for these kind of solutions. What's the difference to finalize everything? We've got the difference between resistance and resilience. And I think this morning I heard resilience as well. And to me, this really stands out. Like when I think about resistance, that's what we've been doing quite a long time now. Kind of pushing back climate change, trying to withstand it, but that's as well like a standstill. Because when we just keep trying to push it back, it's like standing still. But with resilience, you have to be flexible, you have to be adaptive, and you have to make buildings which are in a way resistant, but still even maybe resilient and that they can even react to the lower CO2 emissions. And that's where resilience comes up, and that's why I want to, emphasize resistance, very important, but that's a standstill. Let's all go for resilience and try to make better buildings. And that's where 20 seconds to go, I think I did quite well.
Perfect. Should we tell people to sell their houses in Knoppen? Or
Sorry?
Should we tell people to sell their houses in Knoppen?
I wouldn't start there yet, but if we start building resilient, and maybe also the fully, it's not only building itself, but also public areas, and the whole public surrounding needs to be built resilient. So,
okay.
Yep.
Thank you. Don't forget to give me mic.
Yep.
Thanks. Okay. So thank you, Joep. Now we will welcome Simon Claeys with all his team. I guess the others are preparing with their mics. I need to go up also to give my mic. So Simon Claeys is the CCO partner at the B2AI, or B2AI Architects, who will present rethinking the user and building experience through creative facade design. Thank you.
Thank you. Hi, everybody. I'm Simon. The introduction was done already. I won't lose any time with that anymore. I'll try to stick to the time. I suppose you're quite hungry. But who are we? I'm Simon, a partner at CCO at B2AI. We are an office of about 150 passionate people. First of all. We have 4 offices in Belgium. I don't have to explain to Belgian people why we should have 4 offices in one small country, but of course legislation, etc. and local presence is very important for us. So we're in Ghent, Roeselare, one of the founding offices, Brussels and Antwerp as well. But we're just not architects alone. We're 150 people, as I said. but a nice combination of course, architecture or core business. But one of the unique aspects we have as an office is that we also provide engineering, structural, technical, EPB, interior, etc. I have an echo. So today I decided to make it less technical. I'm not the one to explain the most technical aspects of facades. So I want to give you today a more holistic approach of how we see design and facade design as an element, of course, to reintegrate an existing buildings, or of course new as well. So I will do that through 3 showcases. To repeat what Joep said just before about core intervention of buildings. The first one in Ghent, another one in Brussels, and then a new, just a little série sur le gâteau, as we say in French, a last one that is quite unique. First one is the barracks in Ghent. It was a combined design and engineering project that we did with Circuits and Bates as well. And 360 architects and ourselves. Our office is just in the shadow, actually, of the barracks. And those who know the barracks, I'm from Ghent as well originally, living in Brussels for many years now. But it is this building that is really quite present at the border of the medieval center, of course, of the city, and that even these pictures date from the Universal Expo in Ghent of 1913 or just around them, and are exactly the images as I remember them, even passing by the building as a small child, and of course not anymore today. So the question is, okay, this building will need a new program, of course, very much or very important in redefining the lecture of facades in a more holistic way. So what is this program? It is very mixed with a main part of residential. Think of the Green Quarter, Kwartier in Antwerp, for example. It's quite a similar approach. A very public function as well, the province hall, and also combined with a hotel and an art school. Of course, making this very enclosed and kind of secret, unknown building, at least from the inside, beside the major wall we have passing by from the outside, making it now a building with a new public heart that will be populated, will, of course, have a walkthrough between the functions, also create new identities, addresses, and that becomes, as I said, from this closed island, a place with intersections, people, bikes, etc. moving through, and of course giving an answer through facades, to facade design, the answer between a new cluster of old and new. Of course, defining and making it readable of what is happening behind those facades, and creating, especially for the province hall, a bigger visibility, which is located towards the periphery of Ghent, in front of the park. I will just highlight 2 elements that are, I think, as an outsider, very basic, but at the same time, as an architect and an occupant of the new buildings in a large way, some elements that really can and help to define a new building. One of them is the dormer windows. We defined that the existing barracks had 3 types of dormer windows. Smaller ones in the attics, for example, then bigger ones, and more towards the ground field, bigger ones. They were all very aligned within the existing windows, creating a certain verticality with this very massive structure, of course. And it helped us, of course, with the other architects, to define several design types that answers to every function of that building. Of course, the little one, the 1A you see on top, is an element that is just used to bring some extra light in corridors or staircases. But they go until the variation types below you see, where even a dormer window is made that big, and in the same, of course, detailing or with a clin d'œil towards the existing ones. Creating the light, the natural light, of course, because we always have to think about the quality of what happens behind that facade. Creating dormer windows added up with the terrace and making it accessible, for example, housing. Another more complex maybe intervention is the strategy about wall opening. If you look at the image above, you can see a rather, if you want, basic wall that is just, or that was closing this barracks, and it was the main obstacle, literally and figuratively, for this building and in this design, really blocking out every external person from the inside function of the barracks. But if you have a closer look at those walls, it becomes a very complex and interesting element. It goes about what is the structural element, how it is filled. You have a lot of depth in this wall going on, and also, of course, about the materialization between the more structural and stone elements, and then, of course, the bricks giving color, giving depth, and also, of course, the plinth below that you can read there. And so even there, it becomes very important to do the analysis and to think about, okay, also thinking about the Charter of Venice, of course, where you have a patrimonium building that you want to extend, as we do here, and create a good relation and balance, of course, between what is existing and what is added. Also making it very readable between, okay, this is added, can maybe be taken away afterwards. You never know, in a flexible and modular approach of buildings. And as I said, become identified and readable for the functions that it will have tomorrow, so to speak. We just finished this building not so long ago, a little year ago. So what was a building looking like this, very gray, very dull, very enclosed. We don't even see the wall on this part, because this was until 5 years ago a very unknown aspect, unless you were a soldier or an infantry and housed in the chasm. But still, that was closed since a long time. Becoming a building of tomorrow with these interventions, and I like this picture because it really assembles well the two aspects I told you about. It goes about the dormer windows that really kind of disappear, but still are very important in the use of the new functions. Of course, those are not barracks anymore today, but become a province hall. The main facade which we see here, which needed the most identity or openness, of course, towards the building, but also we're using the cladding of those roofs, and where we are adding new volumes using that same materialization, same reading, once again talking about the Charter of Venice, or even about the wall interventions, as I said, referring with on-site poured concrete, referring to the ancient elements, as you can see them in the plinth. That, of course, is a line as well that is pulled through, and of course also poured on-site concrete to have a better texture that works better with the masonry, etc., of that building. If we have a closer look to new interventions, the same principles go along for new added and value-added spaces that we have on the ground, and specifically for residential buildings or the residential parts of the building. That's what I meant. Also, the research that was done to give a dialogue between the old and the new through the facade design, to have a very natural and coming together dialogue between the ancient masonry and the new one, also working with Claeys, etc., giving the right connections, until even the former hallways that were transformed into bright and airy loggias for some housing elements here, where we broke them open, but then completely. And the result is also always easy to look at, but that's a bit my conclusion or idea of today, to show you that to become to this kind of results, a lot of research and interpretation of design facade. How was it used before? How will it be used tomorrow? Is a very important aspect. And even here, where it was before just a basic corridor, actually now becomes the new entrance of a house with respect of the materializations, the new added cluster, as you can see them, and even the double height openings for duplex houses, of course, bringing the most possible light, natural daylight and quality of those new houses. Sorry. Of course, bringing it to an architectural ensemble with the new and the old combined together, and giving another translation, even if you look at this part where the new openings, the old openings were renewed, but with respect of the existing materials, or the new one added that give this clarity to the old ones. Another showcase is one closer to here. It's the Montgomery Square. The barracks are completed, but this one is still under construction. We are busy closing the facades as we speak. Well, it's written quite well over there what the idea is and was. It's about transforming, once again, a core intervention on the building of an emblematic 70s icon into an energetic and efficient office building. Energetic 70s. Once again, this was a first study case before we started this project about 5 years ago when it was in acquisition. Of course, now today in Brussels, we do many of these buildings, and the fact that it's already from the 70s brings a lot of concrete issues, etc. But that's another topic. So, as I said, it's close by. It's in Brussels. It's very close to the Montgomery roundabout at Saint-Cantenaire. It was the former headquarters of the INAMI, RISIF for our Flemish colleagues here. And it was a very enclosed and dull, once again, even for me when I visited, I remember it very well, claustrophobic kind of building with this secret garden. It's about 2 buildings, as you can see. It has 2 addresses with the secret garden inside. So a lot of things had to be done through facade design, of course, to make, first of all, a building that's much better urbanly integrated. How did we do that? It's about, of course, analyzing, rereading, rethinking an existing building until the core of it, literally, where, as I said, it was really an island. It was very introverted. It only had one exit on the main address and just a logistic entrance for the cars and for deliveries, etc. on the other side. It's the Rue du Collège Saint-Michel, which is a very, by the way, residential street, according to the Avenue Tervuren, which is, of course, one of the main entrance areas of Brussels. So, once again, simple things we wanted to do, but with great impact was doubling the height of the plinth on the Tervuren side, and gave it in that way a more organic, readable and identifiable facade, and to give it to the ground floor a more dynamic facade intervention that would stimulate the interaction with the neighborhoods, of course, and also for the identity of the public or passing by, but of course for the workers going there. Also giving more transparency. It was a very enclosed building. It was kind of secret, so to speak, what was happening over there. And even for the new occupier, which is the European Commission, we managed to make it quite open and readable from the outside. Meaning that from this very long and grey and enclosed facade, we go to this more open, more transparent building. Of course, I will get to that with respect, once again, of the patrimonium. We had to respect the architecture that was there already. And from a front view, this is the main entrance on the Tervuren side. Make this very organic drawing that we did in dialogue, once again. Throughout Venice, it can be interpreted that way as well, with a very organic reading of the facade towards a very rigid and vertical reading of the existing facade already. But also, as I said, creating openness, transparency on what's happening on the inside, at least the lobby, and also towards even the greenery, this secret garden we had yesterday, and we are creating tomorrow with the help of Michel de Vigne, by the way, a very famous French landscaping architect. Of course, the revalorization of the site was very important as well. And we did some key interventions by creating new facades, new design facades. One of them, as I said, is the organic part towards the more very rhythmic and vertical part, is or was about creating more functions towards the public with close commercial shops like a pharmacy, etc., to activate and re-equip that facade. but also on the inside where there's this kind of pergola, which is open but covered, or was open and covered. And by reactivating the use of the garden, by just making a little dislocation in that, as you can see on the right, a little dislocation on that corridor, closing it, making it larger, and really making it the heart of the building of tomorrow. Another main intervention was reorganizing the underground floors. This building from the 70s had a lot of cars. Unfortunately, we had to keep them, but we were able to take away 1/4 of the parking volume, redraw with the same parking spots in just 3/4 of the old volume, and to open up with a patio to dig out actually until the -1 and create new office spaces. We did it on both sides. The circle one is where the parking is. The other one is on the only space or side of that corridor that connects the two buildings in the garden, digging out actually the full soil, to keep it, of course, it's full soil, but to create extra and revalorize functions in the office space. And especially on the plan on the right side, you can see that where we redrew, of course, on 2 levels, the parking, keeping the same amount of spots, but in the purple area, creating a whole new office space that was not there yesterday, because it was parking, because it was archive, of course, becoming spaces that are abundant in the use of offices today. And this is what it looked like. I think they invited someone to be on the picture because there was never anyone in that garden. It was isolated. It was not pleasant even to go there. It was bien entretenu. It was well looked after, but that was it. And the same goes for the pergola. But this is what we are making from it. This is the patio, the circular dig out, of course, that we made on the one side. And you can see the corridor that was enlarged, of course, but still is a corridor. Also about separating people getting with bike or car in the parking and reorganizing in that central barista area. I'll get to there with another picture. But first, this is the view in the patio. The young lady is sitting actually today in a parking spot, and this is getting a new office space with more a co-working related way of working. New way of working, of course, as well. And this is the other side where we dug out the full soil, which of course we remain a more park approach in the landscape design, but also creating, because I didn't mention it, the same goes for the barracks. We consider, like we say, the fifth facade as the roofs, but we consider, of course, that part, the greenery, also as a facade of a building, by the way. It is so important to connect it with the inside office spaces, where here, by digging out, this is on the -1, creating areas that are more located or open to presentations as this one that don't always need natural daylight at the working hours. And of course, with this facade design, we can talk a lot about identity. As I mentioned, the neighbors were not very convinced, but okay, the authorities guide us in that way. We had to keep the aspect of the facade. We could change it, we could play with it, so to speak, but we still had to keep it. Okay, the rules are the rules, but of course it's quite interesting. It was an office building, it remains an office building, and it was of course modularized with this normal and quite standard grids of 120 until 360, which made this very vertical reading of the facade and the whole building. Of course, as I said, we had to keep it, but we wanted to play with it. Also, in accordance to identity of this facade, of opening the facade, which was very close, as I said, very dark. Remember one of the first pictures. Opening it, make it readable, and giving extra functions also in a general well and sustainable approach of the building. So if you look a bit farther away, it keeps its characteristics as we kind of know it today, even though, of course, we have the double height plinth now and the organic facade, at least on that first level, ground level and first level. But if we have a closer look at it, and also through landscape, the elements I explained before, we wanted to create a building that is really approachable and readable, and a qualitative building from the outside, towards the inside, and of course from the inside to the outside as well, related to the sustainable aspects in general. And that's what I wanted to finish with this showcase. There was just one last one. That's of course the sustainability part of it. I think the previous presentations this morning approached it from a much more technical approach, which of course happened here as well. Surreal is one of our main partners in the refurbishment or core renovations of these building, which of course is organized around the optimal solutions for well-being in a building that is decomposed by the energy use, the daylight, the thermal comfort of that building, etc., etc. Decarbonize. We tick the box for all these elements. It's one of the best BREEAM scores this building has because it's for Europe. It's completely standardized and organized between the Green Deal 2030 and it is as well certificate, DGNB certificate and LEED as well. But that are just certificates and papers. But I'm talking or I'm mentioning them because it's really a DNA approach of how to core renovate these kinds of building. The offices were organized in a very flexible way that for closed and open offices they can be used. We drew plans for all kind of functions on this building, residential, hotel. So it was a very modular and open approach. And last but not least, to come back at the identity of those facades and the well-being, because it's all related, of course. These are some views we have from the frames that we did in the outside facade to also identify a certain program on what's happening behind. Between office spaces that have a double height, that have a visual connection also with the floor above, for example, until terraces to have a call, a silent call, just a good breath of air next to some greenery, reconverting archive space in fitness and amenities for the offices, or of course in a very basic approach of redesigning buildings, adding staircases to avoid that people just use an elevator to go from the 6th to the 7th floor and use and be interconnected and have, through that general design approach, have a better quality of living, working, and just well-being attitude in those kinds of building. And this is a last view from the barista area, so the location where you come up from the underground and where you can relocate to the building. Very well connected to the green areas that are also connecting, of course, the two wings, but also connecting the two garden areas of that building. And then last but not least, because I only have 7 minutes left, but I'll manage. But this is the fun one, so to speak. Well, fun depends on how you look at it. It's of course a quite known, I think, project. It's the new football arena for the club of Brugge, which of course for Belgian people here present is of course a city with a lot of history, a lot of connection with a very strong football fan club base, all kind of element that had to be respected as well. What does this have to do with facade? Of course, that's a good question. As I said, it's not easy to kind of design this kind of building because it has to look very simple and be very easy in identity, accessibility, in which box I am, A, B, C, etc. Where is my IP area, and this and that. But and so you have to answer with a very basic design and of course facade design to a lot of users of that buildings. Users that come to see a match, but also, of course, users that are just living around it. And especially in Brugge, it's one of the clubs that has the strongest fan base history and one of the oldest one, the Brugge spirit, as we call it, that had to be answered as well. And of course, building a football arena, I think we can say with ease that it's not a very an everyday project that we can do in Belgium, even if this one will see the daylight in the future. but so far so good. And of course, it has a lot of elements to answer to. As I said, it's a very rare opportunity, but it also it goes about integrating a very large building in a difficult, well, not a difficult, but in an ambiguous, let me call it that way, in a diplomatic way, area. It goes about values of sport, etc., etc. And the result is very simple if you look at it, but that's why I wanted to talk about it as well, because to come at that result and at this element through the facade design, by the way, we had to do a lot of research and analysis also to content players, public, fans, neighbors, etc. And once again, we looked at this building as a kind of element that is placed in this sixth facade, so to speak, which is the park around it, because that is a very important element as well. And we looked at it in the way of a temple, so to speak, where you can redefine the plinth as an entrance part, the opening, and then the veil. And that is what I wanted to come to. That is the veil for this arena. It was decided to work also with the clin d'œil, once again, with the veil. As you know, or not, Bruges, of course, has a history in kantwerk. I forgot the word. Lacework. Thank you. And of course, also the motive of the club was very important to integrate. Because only Club Brugge will play in the stadium, of course, or it's their stadium. So that was an very important part. You should know that, and it gets a little bit more technical, but not too much, don't worry, that for fire regulations, we have two kind of interpretations for arenas. It's closed arenas and open arenas. We designed this was as an open arena, because the veil, it's not only a setback towards the history of Bruges, but also respect of the image and the shirt and the logo of the club. But it also had to work and work as a layer, as of course a facade, but a very unique facade that opens and closes a building regarding what happens behind it. Of course, it's let me simplify maybe and de-romanticize an arena, but it's mainly a concrete structure that has to house a lot of people, and so a lot of safety rules and crowd control, etc., has to be regularized. But for the ones who know the existing stadium, we absolutely wanted to avoid that image of a concrete temple. So hence the idea of the veil, which of course technically was not very easy. And to continue my story on the fire regulations, nevertheless, that this arena was designed as an open stadium, the fire department had a lot of questions because of the veil, making it a closed one. So we had to go to the ministry and got an acceptance on the derogation on that part, because of course we had to do a lot of studies, analysis on the smoke development that still had to go through, because it's still a veil, it's an open element, still had to go through the veil and under the veil here. It depends depending on the location of the stadium. And so we worked together with Sion, which is one of the world leaders of textile, by the way. And of course, the technical aspects of that veil making was very important. It could only be done in parts of 3 meters that had to be collided. Referring to the shirt, to the logo, we put them diagonally, also because it was easier to connect them, and on that enormous surface of building had to be applied as well. Applied on invisible profiles that, by the way, Shuko delivered. And of course, one of the main aspects was the movement, the flapping, so to speak, of that veil, the danger that existed in that part, where we had to go until Japan or Japanese engineering to make tests as well. Like a high-rise building is moving with the wind, of course, the veil was as well. And the worst-case scenario showed that until 60 centimeters on both sides, the veil could flap, so to speak, which explained that also the concrete structure was moved to the inside to avoid that the wheel would kind of used or deteriorate too much with time. My time is up, but I'll leave it at that as well. As I said, this was just a cerise sur le gâteau story. It's a very complex project. It looks very simple, but with these unknown techniques, a lot of research analysis had to be done. But I mainly wanted to show you also through the two previous showcases, the one in Ghent and Recife, how much the design for patrimonium existing in general, even new buildings, is so important to define, revalorize, identify it, and reintegrate urbanistically a project in its surrounding. Thank you very much.
Een werf van mij, Labo in Leuven, dat is ons gezas.
So, the next, thank you, Simon and Simon. So, the next talk will be a great panel to present the ZIN project, the first hybrid architecture adding a new dimension to the business district. It will be moderated by Niels Balkan, project manager at the Declercq and Engineer. We are getting the set ready, and everybody is coming down. So from here on, it's you take it
Okay. Good afternoon, everybody. My name is Niels Balkan. We want to present to you the ZIN project. We have titled the panel discussion, Bringing Life and Sustainability into the Northern Court. I think the title says it all. The past 6 years, I've worked together with these panelists, and I think we're really proud of the accomplishments that we have achieved. It's my honor to present to you Wim Plau, project director at BEL, Amaury Leroy, project director with Claeys. Sarah Bernard is operational director at Van Laren for the general contractor. And we have Bram Brakkaerts from a general manager at Geotech. And at my right hand side is Bob Helsen, the architect of Jasper Eyers Architects. And he will start with a small presentation about the ZIN project so everybody can understand a bit the project. Yes. Hello, everyone. ZIN in North is a mixed-use project developed by BEL. It's a design by Jasper Eyers Architects, 51N4E and IUC from Paris, further refined by all the project partners during the process. It's located within the business district of Brussels, closely to the North Station and the Maximilian Park. The building plot is adjacent to 4th Street. The original building was designed in the 70s, and it's based on the master plan, the Manhattan Plan. According to this plan, the lower levels, so the plinth actually was for secondary functions, and the main functions where the passengers would enter the building was above the plinth, approximately 30 meters above street levels. So you can see on the right, that was the old building. You can see a certain closed plinth, and then 2 towers on top of it. And those were the World Trade Centers 1 and 2, and those were the first office buildings in the quarter. The project started for us in 2017 with a competition for the Flemish government. We won this competition with our vision of our design to repurpose the current complex, and with our vision about circularity and sustainability. So you see a timeline and of the project. You can see that we actually started working in 2019, approximately 2 years after the tender phase, and it went on till this day. Right now, we are finishing up the last function of the project, and that's the hotel. All the rest has been already constructed. Here you see a render of our initial design. So you can distinguish the two towers on the left and the right. Those two towers resemble the old World Trade Center towers, and those are actually constructed again. So we only kept the concrete core of it, where the elevators and the stairwells were present, and we demolished everything else except for the ground below the ground. There we almost kept the entire structure intact. So you got the two towers. They are connected with glass volume a bit higher than the two towers, and that's actually 2-story high. On the other two corners of the plot, we have two lower volumes. On the other side, you don't see it in this picture, we have an office building for the private market, and on this side you see a green volume. That's actually, we call it a greenhouse. It's a public space where you can wander around, and it's filled with trees. So it's to give something back to the community and the users of the building. As I said before, it's a mixed-use project, and the main concept of this project is a zebra design. The city council wanted something new in this corner. So I don't know if you know this corner, but it's filled with offices, and after office hours, it's quite a dead zone. So you don't want to walk around at night there because there are no lights, not many people present, because I think approximately 30,000 people work there during days and only 5,000 people live there actually. So they want to upscale the neighborhood to make it more vibrant, more vivid. And that's why we came up with the zebra concept, to give another function on each level of the building. So you can see we have first the office space for the Flemish government. So they relocated there last year, and they got all the uneven floors in the two old towers, and they are combined with the central volume, and that's 2-story highs. So they always circulate through the old towers, through the existing structure, and they have their main working space in the central volume. On the other levels, in the North Tower, we have a hotel that's currently still in development. And on the other sides, at the Maximilian Park, we have residential apartments. Then, of course, some retail to make it, to have some shops nearby, stuff like that. And then, like I said before, private offices still on the market today, I think, with a nice view to the Maximilian Park, big terraces. And those are designed as loggia. And then, like I said before, we also have some green areas, the greenhouse at the ground level, accessible for everyone during daytime, where the gates slide up and back down when the building is closed. And at the rooftop, we have a big green, actually a big garden where every user of the building can stroll around and sit and have a drink on the rooftop bar. As I said, it's a sustainable and circular icon because of a few different reasons. Zin is actually a mixture of a lot of philosophies. For example, we repurposed a lot of concrete on site. We recycled a lot of materials, perhaps not all on this site, but they are purposed to be recycled on other projects as well. We didn't only focus on materials and material processes, but also on the living conditions within our building.
So, for example, within our office space for the Flemish government, we added a lot of trees inside the double height spaces to make it more cozy, more user friendly, and that you really want to work there all day long. Here you can see a graph of how many materials we actually recycled, repurposed on this building. So we kept 54% of the structure intact. That's mainly underground and then the cores above ground. Also the slabs within the cores were kept. So at the two towers, you keep the same story as before, the same level. Only 28% of our building is actually new materials. And 95 to 95% of those are cradle to cradle certified, which means they can be repurposed in a later future if it's necessary. This is a graph of how we reuse the concrete. So we demolished a lot of concrete. Remmerie and his team did study which we could reuse and how we could reuse them. He will tell a bit more of it a bit later. And that's actually how we constructed the new structure of the building. Like you see, here you can see some materials that we recycled, not per se on site, but they are purposed to use again on other projects from our office or other architects. For example, the silex tiles, we reused them on the apartment terraces and the rooftop on some occasions. Here is in a few numbers. I think like 30,000 tons of concrete is reused. 95% of the materials are certified C2C. And the goal was actually to go beyond the nearly zero energy billing targets, which we accomplished. And lastly, an image of the greenhouse where you can all wander around if you go to the North Station after this presentation, and you can feel a more private, cozy space in relation to the high-rise next to it. Thank you. And I will leave it to Niels.
Yes. Thank you, Bob. Please be seated next to us. There are some key points I remember in your presentation. It's about the unusual zebra concept and the high ambitions on the circular approach and in a broader perspective, the entire sustainability of the project. As the first topic in this discussion, I'd like to start with a question towards Wim and Bob. As a developer and the architect, there is a clear choice to go for that mixed use. My thoughts go to why was this choice made and how did you end up by this unusual zebra concept?
Well, I think the mixed use was, as you know, and as Bob explained, as from the end of the 60s, the North District became only office space. And the administrations, as well as the Brussels city administrations, as the regional administrations, wanted to have more mixity, more life during the day in this region. And so our project, the Zin project, is in fact the first big project which is redeveloped in this area. And so we had from one side to respond to this demand, and the easiest way to respond and to create a 24/7 living building is to create mixity. And that's why there are offices. That's why there is a hotel. That's why there are apartments, because each of these functions live in another moment in time during the day. A second point also Bob explained is sharing parts of the building with the public, with the community. When you pass before the building, you can enter the greenhouse. So everyone during daytime can enter. When the hotel is ready, then you will have restaurants on the ground floor. So you will have a rooftop restaurant. So this also gives more life to the building, more life, to the building, and gives an image that the building is occupied during daytime, which is when you pass through the region and now to the North District, there's not much life in this area. And so another important thing is the zebra concept at itself, but I think Bob is better placed to respond as how it is integrated and what it gives of life to the project.
So as I mentioned, the main concept is the zebra concept, which means each layer has another function. So we use actually the existing structure of the two towers for our main circulation, elevators and stairs. Each function has its own elevators, so these functions aren't mixed because of security or wishes from the end client. And some of the stairs are partially shared also in terms of evacuation purposes and security reasons. On the uneven levels, the Flemish government has their offices, approximately 75,000 square meters, and they work from Monday to Friday, 9 to 5 most of the time. So after closing hours, that level comes quite dead with lightning using. And if you walk around the street, if the whole tower was completely offices, it would be completely dead, the tower, by passing by. And by just mixing apartments with offices with apartments in one tower or hotel with offices in another tower, we keep a visual connection between the street and our buildings. And that's how you get a more vivid, vibrant community, actually, because you want to walk there at night. People will be walking there if they go out, they go to the store. And it will be just a more comfortable space to wander around. Another benefit of it is that you use also the same energy system. For example, offices get heated during the daytime. We recuperate that energy also for our apartments and for the hotel, and vice versa.
Okay. For me, if I look at the building, with the layered functions inside it, it's a bit strange because we have a facade design that needs to apply to multiple programs inside the building. So for me, I think every system has its pros and its cons, but are there any lessons learned where we think, okay, these are interesting thoughts to keep in mind, perhaps Bram or somebody else?
Yeah. For the facades, the panels are all the same. It's now the office or residential parts, so the panels are no difference between them. Performance is the same. The only thing is that there are more options. Let's say for the office part with motorized windows, for example, blinds that are all linked to the BMS system, and that makes it sometimes more complicated because every level is different. And the game must go from one level to another level, and that makes it sometimes a bit more difficult for the rest of the systems.
Yeah. And for the delivery of the building, I think it's also quite a difficult task to do so. So perhaps, I don't know, how is it accomplished to have the interaction between the different program?
I think it's more.
I will respond. Yes, it wasn't that easy because we had to split the different entities from each other, and the evacuation of all our workers had to be split up as well. And to organize it and to have a good evacuation for the end client who is already in the building, and the parts who aren't ready yet, it wasn't that easy to realize, but it worked at the end.
Yeah. And maybe a tricky question for you, Bob. Knowing what you know today, would you do the same concept again?
I think there's a lot to say about the pros and the cons of this concept. If you look at it from a design perspective, from the neighborhoods, from the reuse of the existing structure, I would say yes, because it's a concept that works. It adds many positive things to the neighborhood and to the building. But like Sarah mentioned, there are also a lot of cons, which the whole team came across during the execution of the project. For example, the things that Sarah said, other ones are security reasons, because we are dealing with the Flemish government, so higher security, mixing it each level with, for example, an hotel, made it very complex for the types of doors, stuff like that, evacuation plans and other things. And also the legislation isn't completely ready, I think, for a project like this. We also had to isolate each apartment above, below, in relation to the apartments. So I think if you want to do projects like this again, we have to adapt a bit the legislations for certain projects and also evaluate which functions we want to combine. And then also the end user has to think a bit further, like this, in this project we didn't share the elevators, but it's possible. But then we have to think a bit further with every user and every actor in the process.
Okay, thank you. If I can add just one thing, the idea behind it is also to make it as flexible as possible and to have, without very big transformations, to be able to transform an apartment floor in an office floor or the other way around. In the end, it seems more difficult than we thought, I think, in concept phase. And one of the contrasts to have a layered structure and to have this zebra concept is that as for EPB regulations, you have different types of regulations for offices and for example, apartments. And so that means that regarding insulation and also acoustical insulation, you have to isolate every floor, each from another. Whilst when you make one office tower, one apartment tower, you have less that problem.
Yeah. Thanks for the reactions. I think another topic, Zin is well known for its exemplary role in the circularity. I think many of us never heard of circularity before starting this project. We know maybe a bit what it meant, but now I think we do more extensively. So I think it's it was quite challenging overall. But for me, the question again for Wim is, how did Berckmoes end up for this circular approach?
Well, first of all, as you saw, we ended up with two very old buildings who needed to be renovated anyway. And so I think it was Berckmoes' ambition to put a level very high as far as regarding to sustainability on the one hand and circularity on the other hand. But of course, we have our biggest tenant, the Flemish government, which in its specifications, they helped us to put the barrier even higher because they had a lot of demands on circularity, on energy neutrality, integrated in the specifications. And so that's how we ended up in the building as it was designed now. But for example, what you saw in the presentation of Bob in the beginning, for the reuse of the materials of the existing building, this was something we set up ourselves. There was the photos you saw was a kind of a shop on the ground floor, and we had Dres in summer managing for us the sale of the materials and to find people who could use it elsewhere. And I think the most important element in our ambitions, Berckmoes' ambition, was the reuse of the concrete, which demanded in which we invested time and money to be sure to be able to do it and studies.
Okay. Mangé, I saw in the presentation that there is an immense, vast majority of the concrete reused. Perhaps could you explain how that went, how the analysis went?
That's a big part of the story. So how did we get to that? We first began as structural engineers by a very deep analysis and diagnosis of the existing towers, BTC 1 and 2, even before the architectural competition, to define the opportunities or constraint in redeveloping this project. And then we defined the risk of this structure, mainly the capability of conforming with actual standards, admissible loads, vibration, and so on. And then based on all this survey, we defined, together with the architects, 4 scenarios from total demolition to total conservation. Of course, the more we demolish, the bigger the flexibility will be. But it goes, again, the concept of sustainable and circular project. And when we analyze the amount of material in the existing structure, if we just focus on the structure, not the whole building, the slabs that represented the biggest constraint on the project represented only 15% of the total mass of the building. Then, based on that, we decided to demolish the slabs, keep the basement and the 2 cores, and redevelop the project with that for the starting point of the ZIN. But even with that, we tried to be better in reconstruction of the building. That's where we developed this channel of recycled concrete. So rubbles from the demolition of the building were sorted, crushed, recycled, and poured again in the building itself. So that's a big part of the sustainability of the project. It's of course the reuse of the structure, but it was quite complex also in terms of construction on site.
Yeah. So I saw in the presentation the aim of the ambition was quite high. 95% of the materials had to be a C2C certificate. As a general contractor, how did you manage to deliver?
Yes, in the beginning of the project, we had it very difficult because the market wasn't ready for it. The suppliers and the subcontractors didn't want to get certified, and we had to really induce parties to get in to this story. And I can proudly say now at the end of the project that we achieved it. And it's thanks to all these parties who have done this certification. And this certification has changed also the construction world a little bit, because now in every part of a construction we have parties who have this certification, and it's also useful for the future when we renovate and things like that, that we know the classified of the different materials. So it's for the circularity and the reuse very important.
Okay. Thank you. Bram, maybe in the context of this conference, we saw in an earlier presentation that there is reuse of glass. But what did QTech add to this circular approach?
Yes, for us it was in the initial contract. It was only us. They only asked the C2C certificate for aluminium glass and the blinds. And yes, we decided from the beginning that we would go for the C2C certificate for the full panel. I think today we were the only facade company that has a C2C certificate for the full panel, but it's like Sarah said, it's really complicated. We have about 50 suppliers, I think, to build one panel, and to have from each of them all the information to agreements back, and not only the supply but also the fabrication of the things from screw to silicon. It was the wrong way to go.
Okay, thank you. Apart from the circularity, my personal favorite of the Zen project is a bit the louvers at the facade we see in the background here in the loop. I'm asking myself, Bob, how did we end up with this?
It's actually compared to the program. We have a program of about 110,000 square meters above ground. It was actually a small building plot. So to get to as much as renewable energy as possible, we had to put photovoltaic panels at the facade. It's so it delivers enough energy for the project, together with the solar canopy roof that we added on the rooftop of the 3 towers. The photovoltaic panels at the facade, so they are only placed at the central volume, so where the office space, the double-story office space of the Flemish government is. It not only provides electricity, but also provides shading, so we got a lot less cooling load during the peak hours.
Okay. Are there any other sustainable approaches in the project added, Sarah? I think logistically, perhaps.
Logistically, we work together with the materials hub, ship it near to the canal, because in the city center we weren't able to put all the materials on site, and especially for one part of the facades, the central part, where it's 2-story high, the trailers had to come just in time. And then there was a good coordination needed between the tower craneman and the workers of Geotech to place it, to have a trailer just in time to place it, and then the trailer had to be gone for the next one. At the other hand, we also did it for the special techniques in the shafts. There it's coordinated in the BIM model in front. And in that BIM model, they coordinated completely. So in the fabric hall, they installed the shafts completely. So they could put a shaft of 2-story high immediately like that installed, and they only had to make the connection between the different stores. So that was in safety and in quality and in planning an absolute plus for the project, so that the tower crane hours were less and that we could use it for other logistic things.
Okay. Maybe a last general question for everyone. What is the thing you are the most proud of, or the lesson learned you really want to share with the audience? Perhaps Wim could start.
Thanks, Niels. No, I think, where I'm very proud of is what we realized in the end, because as I explained, the demands of the Flemish government, for example, regarding energy neutrality, were also very high. And so we had, with the whole team, during the whole process, we had to be flexible and to adapt and to change continuously. Even in execution phase, we decided to change some elements. I give a small example, but in the beginning of the concept, every function had its own energy production, heating and cooling production. And during the process, we decided there was a big optimization to realize if we went to a central energy production, because then we could use leftover energy for other functions, and that's the advantage. Also, you can only apply that or in this amount when you have a mixed building. But so we finished with a central heating and cooling production, and I think it's this process which makes me very proud to see that we at the end we realized it. Nevertheless, all complexity and demands involved.
Mangé, I think I know your answer, but please go.
For me, the very tight collaboration that is essential for this kind of project. Being sustainable is also trying to avoid materials, and we made a very deep collaboration with architects and with you to keep the structure as it is. We have lots of raw material. We have very big constraints in terms of structure. For example, this deviation at the entrance is a structural constraint due to the foundation, but it has been taken as a big opportunity for architecture to have this gorgeous entrance of the building. So that's for me a lesson of this kind of project, very complex projects. That's collaboration between everybody.
You have the most proud of is maybe the Vooren Cabal, the center of building. Why? Because these are really big modules, the biggest are 9 meters high and 2 meters wide, with the assembly of the photovoltaic cells on it. Yeah. And do the installation of it also, and let it work with cabling in the glazing bits. That was, I think, for us the most complicated. I'm most proud of it for this. And I want to again adding the C2C certificate for the panel, because it depends on the suppliers. Like I said, we have 50 suppliers for one panel. If you change one supplier, you can start all over again. So for this project, I have to be.
Let's change your mics.
Okay. So is there any lesson learned for your part?
Yes, at the almost end of the project, because the hotel has to be delivered still at the end of the year. We can be proud, all of us, that we realized it in such a short time frame. Taking into account all those new sustainable aspects at one hand, and at the other hand, we made also lots of steps in digitalization, in construction, like the delivery system with Dalux is linked with the BEL model, and so it was more efficient. And all of these combinations is really something to be proud of.
Okay. Bob, you have the honor as the last one.
We can't hear you in the back.
Okay. Bob, to finish, what is your takeaway for the audience?
For me personally, it was the first gigantic project that I participated in. Before this project, I did small apartment buildings, so for me it was a whole new world opening up. And I think the most important thing to realize a project like this was teamwork. We had so many different actors involved, developers, studio partners, clients, contractors, and the only way we reached this is to work together, closely together.
Okay, thank you. I don't know if there's time for questions out of the edit. Okay, I think everybody is also very hungry, so perhaps 1 or 2 questions maybe. Is there anyone? No? Oh.
Problem with the photovoltaic cells on the facades for fire issues.
Bram, what's fire?
For fire issues, I think so. There were no questions. The building was done. Connections between it also also very safe. We checked every level, if it hurts. And then if a panel breathes, it's safe.
Other question? Someone? I don't think so. No. Okay.
Okay.
Thank you.
Thank you. Thank you all. Well done. Okay, so that's the end of the second session. It's time for lunch break. Okay, let's start. Welcome everyone. Second part of the day. Third session. I know we had lunch. We need to concentrate again, but please come more in the front. Sit more in the front. It's always nicer for the speakers to see also the people. Well, let's start then for the second marathon of conferences. So for this talk, we will have to find him, Edwin Remmerie, design and operational lead at Binst.
Yes.
Binst Architects, to present the modernist icon from the center, money to Oxy. Really nice building. I was there yesterday.
Thank you. All right, good afternoon. I hope you all had a good lunch. You all look well fed, so I will try to keep your attention for more or less 20 minutes. I see the timing is not on there, so I will make an estimate like the previous speakers. Now, first of all, Oxy, the project that I'm going to present, is a competition that we did with a team together with Snøhetta and Binst Architects. Snøhetta is a Norwegian office, and it was already decided that the execution would be done by DDS and ADE offices from Brussels. And on our own initiative, we also included Surreal in the team for sustainability advice. Now, just a little spoiler, this is a competition from 2019, and we noticed that we won it in March 2020. So most of you already know what happened afterwards. It's going to come back later in the presentation. A second thing, we're used to making presentations in InDesign. It's a very good program, but once you convert it to PowerPoint, it screws up the layout. So I'm very sorry about it. Normally this should have been a very clean presentation, so you will have a laugh from time to time because of the crappy layout. Just short in 1 minute who we are. We are Binst Architects. We're located here in the south of Antwerp in an old warehouse between the river and the park, which is of course a very interesting location. It used to be a warehouse for the docks that were close by, and we converted it to 4 office floors. I'm very sorry. So our team of 60 people is spread through an entire building full of creativity. We also won a couple of awards, among others for this building, Oxy. We won the Renolab Award, which incidentally was also awarded in this very same auditorium as we're in now. This is our team, 60 people. And to wrap up the short introduction, we also have a book if you're interested in our projects, but beware if you want to get it in the store. It is 1,376 pages and it weighs about 3.5 kilograms. So bring a bag. But I don't want to make this a one-man show about Binst Architects alone. Of course, we were an entire team. As I said, Snøhetta and Binst Architects were the design architects, DDS and ADE the executive architects. And to make it a bit more complicated, as is usually the case with projects like this, we had 2 clients who collaborated for the first time. We had 3 engineers, 2 MEP engineers and a structural engineer, and then a whole line of additional supporting parties. There were actually discussions about this diagram even before we started. We're all good now, so don't worry. Anyhow, about the concept, which should have been on one line. Once more, my apologies. For those of you who don't know Brussels, this is the building. So you see it's right in the city center, close to the Grote Markt Grand Place. A zoom. As you see, this is a relatively recent picture because the construction is already ongoing. You can see that the facade is being dismounted. And what immediately stands out, at least what immediately stood out for us as architect in the design phase, is two things. First of all, the facade is, of course, it's old, but that's pretty obvious. You don't need to be an architect to see that. But it's very close. It's very hermetic. You don't feel invited. It's kind of distant. And also the podium kind of gives the same feel. It was renovated. It was nicely done, but it's a very closed program. It's a shopping center. It doesn't really invite you up. So those 2 points were the starting points for our design. In combination with this one, we noticed that within a short distance of the building, there's almost no greenery. So if you want to get to a place that is actually green, you have to walk at least 5 minutes if you're very optimistic and if you count the little square here. But if you want some real park, for instance, the Veranda or the Jardin Botanique, it means you have to walk for almost 10 minutes. Whereas in a city center, you would expect a livable cities, greener and all, something more of a green approach. And another aspect to wrap up the analysis of the site that we started from is it's a very specific site in the sense that you have the 19th century fabric, which is typically low-rise, 5-6 building layers, pitched roofs, quite traditional actually. And then on the other hand, you have the large-scale elements in the city. Of course, Oxy is one of those elements, but right across the street you have the former Philips Towers, which in the meantime has been converted into multi. You have Bru City, the parking that was converted into the city office, and of course the Opera, Monet, and the Bruce that are all close by. So you have this dual scale within the environment, and we tried with our design to respond to both scales. Now, how did we do this? Some of the slides are heavy, so they linger a bit. To open up this existing podium, what we said is we're going to do two things at the same time. We're going to open up the podium by cutting out parts of it, and at the same time we're going to introduce greenery into the project, because as you remember, there's almost no greenery within the environment. So what we did is we created a walk where you could enter on Boulevard Anspach, go through the building, through a series of different terraces, and in the end, you get this really green podium, which culminates in a terrace that has a very spectacular view over the Place de la Monnaie. So this was our competition impression of what that place could look like if you have a wedding party or a reception or something like that. And here you also all see the first image of the facade that we envisaged for the tower. Now the tower, as I said, was very close and uninviting. So what we did is we wanted to bring back we wanted to make it a different scale and more open. So we did some changes to the volume. We extended it horizontally. We topped it up vertically because we had a certain program to adhere to. But what we also did is we made all the facade elements double heights because it makes the scale of the building more readable. And it also, as you see here, refers to the treatment of the podium, which is also more or less 2 double height layers stacked on each other. So you get this coherence in the design. But that in itself doesn't solve the relative anonymity of this curtain wall facade, which, by the way, from what I've heard, is one of the first curtain walls ever built in Belgium. So to answer that question, we said, okay, we're going to introduce a difference between the ends of the facade and the side walls. The ends, they will be very strict, very rectangular, a bit powerful because they have a certain depth. And then the curved facade, we're going to make them alternating because it introduces a kind of variety into the design, which I will get back to later on. And this is then one of the images from the competition, the end result in our eyes at that time, with a specific color, which was a copper color tone. But we didn't only think about this project as architects, we also included, as I said, Surreal in the team, because in the entire facade design, we really thought hard about sustainability. I know the word has been mentioned several times, but we wanted to apply it from the start and not just for the presentation, make some fancy diagrams and say, oh, we're sustainable. And one of the most important aspects was the division of the facade, whereas you would normally say, okay, I have this type module, I make it very efficient, I engineer it, I value engineer it, and then you just build it. We went a bit further and we tailored the individual elements of the curved facade towards the specific conditions. So what we imagined is basically a different type of module according to the orientation. towards the south, it would be more closed because you want to keep out the sun. You don't want overheating, especially for the office program. And the fact that you close it also opened up the possibility of including BIPV panels, because the south is more closed, but it also has most sun. So it was a very coherent design idea, apart from options of integrating technical utilities and so on. And this is one of the diagrams that we made during the competition phase, where you really see how the building creates a shade on itself, represented by the different colors. And depending on the orientation of the facade, you get a different profile of ratio open versus closed. And then in the end, we envisage this prefabrication with CLT for the extension and so on. So this is what it looked like in competition. So you can see the really rectangular tower ends, as we came to name it during the process, and then the more varied side facade, where we have a succession of different programs. We have a hotel, we have an apart hotel, we have residential, and on top we have offices. So it kind of refers to the zebra concept that was mentioned earlier on today. And then a final image of the terrace on the Place de la Monnaie. Now, as I said, the competition was won March 2022, and we were all excited. And 1 week later, lockdown, so we didn't get any PR out of it because there was something else happening. But it also meant, as you probably all know, after the lockdown, prices increased, rents increased, so the whole situation became a lot more difficult. And we still had high ambitions, but at some point we had to be a bit more realistic, let's call it that. And I think this slide, with the courtesy to VK, who actually made the calculations behind this, if I would like you to remember one thing about the talk that I'm giving now, it would be this slide, because this really shows how the facade was designed. It was not this architectural ego thing where we say, oh, we want it to look like this, and we want to have this gradient from open to closed because it looks nice, and well, maybe we make it diagonally. The idea was not to do that, not at all, but just to, as a matter of speaking, let the calculations speak for themselves. So the result of the facade, we have 5 modules, type 1, 2, 3, 4, 5, and so on. The layout on the facade is actually determined by the calculations of how much solar gain we could afford, how open and how close it would have to be, based on the building generating its own shade on itself. And that resulted in a very, I think, powerful and coherent design gesture. Yeah, for the fun, we made an exploded view with the BIM model just to show the complexity of the entire thing. But once we get into detail, this was also I'm sorry for the Dutch word, a bouwteam project. So we made these general drawings, and then we started discussing them with the contractor, Geotech, who is also in the room, by the way. But I'm going to skip through these a little bit faster, just to arrive at the main point, which is basically this. If you add it all up, we could have said, okay, standard modules, very efficient, but in the end, we ended up with a lot of different modules. These are not even all of them, and they had to be repartitioned over the facade in different ways. So for a facade of almost 20,000 square meters, it was a really complicated thing, as we notice also now when the project is in full execution. So we've talked about how the energy consumption informs the facade design, but we also looked at the embodied energy. Because in the competition, we said, okay, we want the facade to have we want to do in copper, because copper has a very low LCA. It doesn't take too much energy to extract it, as opposed to obviously aluminum. So we were all happy because it had a good LCA, and also it created a very warm and inviting building, almost the opposite of what it is now. Now, then you get into the tender phase, and it becomes clear that there are some technical problems with this. It's an interesting point of view for your design and for the result of your building, but copper and the rest of the structures don't combine now nicely. You have this galvanic couple, it will start corroding. So it was technically a no-go. So we had to redo the exercise and select multiple samples and look at multiple options. At some points, aluminum came back into play shortly. We made a mock-up. We made several visits to the mock-up in Luxembourg and on site. But in the end, we decided, based on the same reasoning of LCL calculations, that the best solutions would not be copper, because it's technically difficult, would not be aluminum because it has a horrible LCA, but would actually be in the end stainless steel with a special coating, which is in this image also the one that we finally selected and that is now being installed on site. So the whole reasoning was kept. We still look at the LCA, we still look at how the building performs in its context, but we ended up with a totally different material than the one that we imagined originally. And as a third topic, apart from the energy consumption and the embodied energy, we also looked at reuse and circularity. For this, we cooperated with Roter. Most of you will probably know them. And they made an entire inventory of the existing building. I didn't include it in this presentation because this is mostly a facade presentation, but there is travertine in the entrance lobby that we will recuperate. We are also sourcing materials from other projects. For instance, the public part, which we call the walk that was cut out of the podium, will be paved with facade cladding coming from another building. And we also use other elements from the building. So it's a coherent approach. But the one that is most relevant in this discussion is what we actually did with the facade. Because once again, you see it here, it's pretty gray. It's a bit dull. It's a typical 60s kind of thing, very efficient. But at some point we realized that we had about 3 kilometers of these facade mullions, and they're basically aluminum profiles. There's nothing special about it. So what we could do, we could have said, okay, let's just demolish the facade and throw it out, and that would have been the easy way. Or we could say, and we made a specific study for that for our client, what if we actually reuse these elements and turn them into something that can become an interesting design feature of the projects? Of course, I know this is kind of a gimmick in a way. It's not going to save the world reusing facade profiles, but it is interesting to show that in this project we also thought about reuse of existing materials. And what we in the end came up with was the idea of taking these aluminum profiles, which are just blank aluminum, to have them anodized in the same color as the facade, and then create lighting fixtures out of these. And why lighting fixtures? At some point we even talked about using them in a structural way. But of course, aluminum fire rating, it's kind of difficult. And also you have to have it tested and approved and it becomes a mess. Whereas for lighting fixture, you have a bit more leeway. So we designed a number of different fixtures, where this one is my personal favorite because it's basically the plan of the building. It looks like a cross, but if you look at it more in detail, it's a cross with one leg that's a bit offset. And we translated that shape into a lighting fixture. So it kind of reverts back to the shape of the 7,000 square meter building. And we are currently collaborating again with Roter to make it feasible. So they are making these execution designs of how we can turn this very basic and even maybe simplistic facade profile into something interesting that reflects the way we thought about the project. Another image of the lighting fixture, which is still in the design stage, by the way, but we will get there. And then, of course, it's not just a paper project. It's actually being built right now. But before we had to build it, we had to go through, of course, all the execution details. And I think one of the interesting aspects was also I'm not going to say difference, but the evolution between our original design vision and how it was in the end executed. Because we thought we were being smart, and we thought, okay, if you have large modules and you make in double heights, as is the design intention, it will be more efficient because you need less transportation, less installation costs, and it will save us on the budget. Because we had a budget, Corona, price increase, so on and so on. But it turned out that it wasn't actually that interesting to do it that way. So what we ended up with is that each model is more or less 3 by 3 meters. So they're relatively standard sizes, and they are, of course, prefabricated in the atelier and installed on site afterwards. Now, to get back to the BIPV and the realism, these zones that are marked in black are the ones we originally intended as photovoltaics. But when we did the actual calculation, two things came out. First of all, but that's not really a shocker, BIPV is not very cheap, but that's something we knew in advance. But second of all, and that's kind of what killed the idea, is the fact that these parts, the black ones, they're recessed because we want to have depth in the facade and we want the vertical copper colored elements to stand out. But of course, if you recess the BIPV, it's already expensive, but you decrease the yield. So it becomes a very inefficient solution. And at that point, it was also given the price increases, it was no longer defendable to say, okay, we want to have this because it was in our design. So in the end, it just became an element of the cladding and it is no longer a BIPV panel. Sad but true. But okay, the construction is ongoing. So where are we now? Demolition is entirely done, and we are installing the first facade elements currently. And what we are very happy with as architects is that the color and the detail and the definition of the facade is almost exactly as we had it in mind in the competition process, notwithstanding the fact that we changed the material, that we changed the modulation, that we had to let go of the BIPV panels. The result is still very much in line with the original intentions. I see I have 1 minute left. That's almost perfect. So as you see, we stripped the building up until the existing structure. And then per floor, we also made these extensions. So these are 1 meter horizontal extensions. And on top of these, we installed the facade. So here you can actually see it. As a little aside, this is where the contractor has his offices because it's a very close site. It's closed off by streets on all sides, so there's not much space. And from a logistical point of view, well, it's a bit of a nightmare, but okay, it's working. Some other pictures, and one thing that I didn't mention yet is the fact that instead of having this flat facade, as almost every office building has, we inclined the glass surfaces slightly. Why would we do this? Because if you make a curve and you make it faceted, it really becomes obvious where it's straight and where it's faceted, and it becomes this kind of attention point. And we wanted to avoid that by giving all the glass panes an inclination. And at some point, it was on the table, no, we're going to make it flat because it's cheaper and this is complicated, and why are you doing it? But if you see the actual pictures from the construction, and I have a movie coming up, you can see that the fact that the facade is all curved really ties it into one coherent thing instead of just different parts, and the reflection change depending on the angle you look. One part reflects a building, the other one reflects another building, and that's really something that stands out. For instance, here you see it in the curve. This part reflects part of the construction site, where here you see the sky and so on. And the copper color, it's also very spectacular. You can see the facade floating above the Place Brucaire. And I think the next one is the movie, the view from the Place de la Monnaie. And to end as my final slides, I have a little movie. It's from a construction site, so it will make some noise, but it really shows how the facade curves along the way and how the reflections add to the experience. And I think the historical opera is a very nice image to end my presentation with, and I thank you for your attention.
Thank you, Edwin. Great architecture, great engineering, and great construction. We have to be a whole team to make a building great. Let's continue on with the second conference. Will be Kenny Martens, the managing director at Vitro Plena, who will present innovative glass solutions for the future.
Okay, good afternoon, everybody. I am Kenny from Vitro Plena. We are a project slash engineering slash expertise office for glazing and architecture and structural glass solutions. actually you can see us a bit as the rock and roll of glass, I would say. I will go to 3 topics today with you. First one is the sphere, glass stabilized dome. The Heldentoren, which is a material optimized, or which has material optimized curved facades. And as a last thing, I will talk a bit about some new, innovative, existing or coming glass solutions which should have a nice impact in facade construction. To start with the sphere, so this is the glass dome that is at our Belgian coast at Knokke, which has a steel grid with glass triangular panels on top of it. And to go a little bit into the structure, you can see it has a diameter of 15.5 meters on one side, 13.2 on the other side. It's not a perfect half sphere. And it also has a height of 7.7 meters. Not too big, but for the square, I think the architect did a good job not to making it too big for the square. And basically, if you look at some details, it's not a regular dome. It's actually a giant puzzle of less or very at least repetitive glass panels. Each has its own dimensions almost. There are a lot of nodes, 5.2 kilometers of adhesive joints, which are very important for this dome, I will explain. And also more than 2,000 glass panels are applied on this dome. To go a little bit into the engineering of it, of course, there are some loads to have a look on. We are at the Belgian coast. It's also let's say a spherical shape. So we have wind pressures on one side, suction on the other side. It's a combination of a lot of wind effects going onto that dome and coming from straight over the sea. So it's quite an important wind load. We also have got some snow loads we have to redistribute and stuff. And of course, also thermal loads are quite important in this structure. Going through that, actually there was designed a steel structure which has nodes like you see on the right side, and it's kind of a mechano structure which is built on site and which can be put together like a mechano, let's say, according to a plan. Of course, if we want to make this dome a glass stabilized structure, that means that the glass is activated. The glass helps to carry and stabilize this dome on a daily basis. Of course, if you want to do that, you need to do some, let's say, next level engineering. You can't just make a 3D model of the steel structure, put the glass on it and do some stuff like that. No, we have to make sure that those irregular and custom-made nodes, we have to know how they behave in that structure to see if there are some problems in there, what's the flexibility of that. So we went together with Ghent University and we tested those nodes to make sure with, let's say, high-level analysis methods to make sure we have the curves we need to put in such a model. So we have rotational curves, we have tension curves, which are basically stress-strain curves that we can put as springs in our 3D model, which you see on the right side. So we have a model without glass, then of course we also have a model with glass. And on the next slide, we did some glass calculations, of course, where we see the triangular shape of glass is very different of a rectangular shape. We also realistically model the PVB interlayer in there, because for every load, your PVB interlayer is behaving in a different way. So basically, if you want to optimize the structure and really activate the glass, you need to know how this glass package will form. Pendulum tests were also necessary because we are on the ground. We also simulate that. And of course, we also had a fire safety simulation to check if the glass will break, how long will it take, or how can we estimate a duration on which people can evaluate the building. And purely structural, we could get along with the 442 PVB laminate. Insulated glass was not an option in this project, so we needed to go for laminates. And for fire resistance, to just have a little bit longer duration, we went for 662. Another important aspect here is the detail of gluing the glass onto the profile. Basically, we had a steel structure. Sadly for us, there is a steel structure. We wanted to make it entirely out of glass, but the architect wanted some steel too. And then we made it our mission to make that steel as small as possible. So we went for 30 by 30 by 3 inox stainless steel profiles to make up the grid structure. And of course, you need a minimum bond or a minimum bond length to put your glass upon. Very important here is that we also engineer the adhesive, the adhesive lines, the bonding joints. You have to engineer it because, of course, the shapes are important for thermal expansion and for other loading. If you would do it in an analytical way, like you have a typical facade with rectangular panels, there are some analytic formulas for that. You need to calculate your structural silicone. Here you can do that. You see, we have high safety factors, no problem, a lot of reserve for non-thermal load transfer, because we will activate the glass also. And there's a lot of shear interaction between the glass and the steel under wind loads and so on. But basically that doesn't work here. Because if we model this in 3D in a triangular shape, you will see you have a lot of stress concentrations in your glue, which are here, which you can, of course, need to expand a little bit. These are because your glue is a little bit flexible. But you see you don't have a uniform load distribution on your glue. And it could have been possible that your bonding joint, if you would just took the analytical measures, they would start to tear up in the center of those panels. So basically, we 3D model the entire thing into our calculation computers to make sure with the programs that we have a good design of the bond, which is ended up with this. And we have a minimum safety factor of 4 on the structural silicone. In basic guides, they will say 6. But of course, if we are here modeling in 3D, we have a good, let's say in the production process, we will control it very well. Then you can go a little bit lower in safety factors. Now, maybe the most important slide here is, if you would have this dome and you only take the steel and the glass as a load on top of it, you get a stability factor of 0.14. In engineering terms, that's a disaster, because you have to be at least bigger than 1 to make sure your dome is not falling apart like a house of cards under wind load. And basically, if we bond the glass on top of it like it's now, that factor increases to 1.88 and we achieve stability. Also, if we into deformational aspects, this dome without glass would have deformed at the center just from weight at 30-40 millimeters, something like that. And now we have 16.08 millimeters. We measured it also on site when everything was applied, and there we had actually a measurement of 12.6 millimeters with the glass in reality. So we were very close with our model to the realistic shape. Execution was something different because we are in situ bonding. We are really bonding on site with structural silicone. Actually bonding with adhesives is something you do better in shop and not on site. Of course, here that was not really an option. So there we had to really control the quality parameters. So these are the most important ones: clean, temperature control, humidity control, no dust, and so on. On the site, close to the coast, where you have a lot of wind with sand, it was not that easy. And therefore, we really had to install a whole tent structure that was placed to build the dome in. We also had procedures written out for the build-up and the gluing, and of course, with decent quality control on testing on the adhesives. If you look into execution, we see the steel structure ready to have the glass panes upon. The triangular glass panes, every glass pane had a code where it had to go, where it was placed. And here you can see when they are installing the glass piece by piece with the silicone bonding. And actually, this is the final result. At this moment, it's a restaurant. So yeah, they made a nice place of it, and it's nice to see, I think. So that was, let's say, the first project. Shortly, we go over to Heldentoren. The nicest feature of this tower, I believe, are the duplex facades you see here, which were made out of hot bend glass in facade structure. And I think the most interesting part of this is that the architect really wanted slender profiles on the inside. Now, if you see a decent high tower, high wind loading, also straight from over the sea, with hot bend glass. And you can see we also have a duplex facade. So in terms of support, you're a little bit further away than going standard with 3 meter of interlevel distance. And in plan view, you see the nice bend shape. Now, the challenges here were, of course, the high wind load, but it's also a big opportunity here because we have a bend shape, and we wanted to really use that bend shape to make sure that those profiles were as slender as possible. And one way to do it is to use the bend shape, but also use the glass. Again, activate the glass. It's bent and it has a lot of stiffness, and we can use that to our advantage. So basically here, we also made a 3D model with the glass into it. And these are the slender profiles which have been used. And again, we did some numerical 3D modeling on connection features and so on, so we could have make those spring-like features you see here to really realistically model the entire facade. And again, if you look into bending moments, it gets interesting because you see here in the transoms, of course, you have your bending moments in your vertical mullions, which are straightly from wind, but we also have bending moments in our transoms, and most interesting here are the normal forces we have here in the transoms. And these make sure we have a nice bow action in our facade, which makes that actually this facade works very efficient, and the glass is really helping also in the curved shape, minimizing deformations. Here you can see some details from execution. Like on the right side is an interesting part, which is the connector with the transoms, which has to be a bit robust because all those normal forces are coming there, and they need to be transferred nicely and smoothly into the structure. Here you can see a duplex facade after execution, and basically here we have the final result of the entire building. To end up with, which is just time enough, I've selected for you in facade industry some impactful or highly potential impactful innovative glass solutions you will see in facade design, or as an architect you have the option to incorporate this into your design for sustainability, for aesthetics, actually, or for both. But one of the most important also, I think, is that glass producers are highly increasing their glass cullets, which are used recycled glass to make new glass, which were, let's say, 10 years ago lower than 10%, are now increasing to up to 50%, thanks to highly investing in R&D, in the recycling processes, but also in glass production capabilities. So basically, where aluminium, of course, is the winner, let's say in construction, with almost 95% or even more recycling in profiles, glass is finally getting also there, and we are already up to an increase of 50% in glass recycling. Another interesting feature, I believe there's still a little bit of work to do here, but still, we had the triple glazing with a new value of 0.8, but however, especially in renovation, where you don't sometimes or most of the times don't have the space to put such a thick glass package in your building, you have the vacuum insulated glazing, which already has a U value of 0.7 with just 2 thin glass sheets. So basically there's, I believe, high potential. Of course, to be honest, we have a little bit of these inside. So basically they should do some work to get rid of that too, of course. Another interesting one is everybody talks about a little bit smart glass and how to control sun radiation into the facade of a building. However, all the solutions up to some years ago were actually with a current. You need electricity or a switch to make your glass a little bit darker or to have another feature there. Actually, due to some biochemical processes, it's possible to produce interlayers who do the work without any current, without any electricity, which really auto-respond to the amount of solar radiation. And like you see here on the left side, you have the responsive system, and on the right side, a normal system, which could work. Then we have a nice trend in ceramic screen printing. So the times that you needed glass with, let's say, a press with a shape made and put it on top of it and just have one band in black or one band in blue or whatever is a little bit gone. Now there's digital ceramic screen printing, which is put on glass with this process, and basically you can go pretty far with that. Of course, our colleagues in the Netherlands are very good at that. They have made a structure. They call it a glass form, if I'm right. And actually, that's an entire glass structure printed as a farm building. But you see the details. There's a lot of things possible with the ceramic screen printing. Another interesting feature is a purely structural feature, and that's the cold bending of glass. If you want a nice curved shape, you had hot bend glass, which was made in the factory. A lot of logistic nightmares if you have large panels, because that bent glass with, let's say, 5 meters of length is almost, maybe you can transfer one with a truck. Basically, it's possible if you engineer your glass package in the right way, you can do cold bending on site. Glass is very bendful. It's very unstiff on the other hand. And basically it's possible to produce straight panels, go with them to the site and bend them there and just clamp them and then you're ready. Just imagine, well, another very nice feature of that is actually that you have the perfect reflection through bending. Because a hot bend glass product, production is very well already in hot bend glass too, but actually you always see some visual disturbances over there through the bending process in the furnace. Actually here you can achieve perfection. And just imagine you have a building like this, which is made with hot bend glass. And all those panels are hot bent, but just imagine you can just make a building like this, just with straight panels, put them on site, and just clamp them. I think the economic efficiency we have there is very high. And then as a last part, maybe a small project, maybe a big project, it's something we as a company are very well into, is structurally activating glass in combination with adhesive bonding. Can be with structural silicones, can be with the very stiff adhesives like acrylics and so on. Transparent glass-to-glass connections, but basically it's possible to get rid of spider connections here in corners, but just putting glass panes together, glue them on site with a good engineering like this, it is possible. And that was basically it. For my part, I would just ask you to say, always challenge us, because we are very nice into that. We like it very much. And like we always say, let's classify the world.
Thank you, Edwin. I have a question on your first project that you showed in Knokke.
Yeah.
How do you take into account the tolerances for on the construction site? Like the direction of all the structure, the steel structure?
Basically, and thumbs up for our partner installer, because thank God he was very, very good at it. Basically, our tolerances were very small. I think the maximum tolerance we had there was 2 millimeters. And everything was measured constantly checked.
Okay. Thank you. So we are going on with conference number 3. I'm pleased to present Christian de Belzer. Okay, from Axalta Coating System, who will take us on an architectural color design journey.
Hello, good afternoon. My name is Christian de Belzer. I am for 7 years with Axalta now. Today I'm standing here because Valerie couldn't make it today. She was sick. So let's start to talk a little bit about Axalta. So at Axalta we are with 12,000 employees at the moment, located in 140 countries. We have 150 years of experience. We have global specification leaders, and at the moment we have $4.4 billion net sales. So the factory is closest to Belgium. We have one in France, we have one in Sweden, we have one in the UK, and also one in Turkey. And from those, we deliver our products to the countries around them. So a project journey. So there are 4 steps in the project's journey. So we have project excellence. The second one is continued education. The third one is defining the quality, and the last one is color, effect, and finish. But we go deeper on those on the next slides. So you can discover at Axalta how Axalta specification leaders can elevate your architectural projects by defining coating, quality, color, finish, and effects. We also do workshops and seminars. So on our on-demand workshops, they are designed to advise and inspire. So you can explore topics such as sustainability, lead credits, innovation, and coating product qualities to elevate your projects to a higher level. Defining the quality. So our expertise is at your service to advise and guide your team in making the right decisions, to explore sustainability, warranty, weatherability, and pre-treatment considerations with us. So if you have a projects, please reach out to Axalta and we can advise. Another sustainability is a big topic today. So Axalta is the first manufacturer in the powder coatings industry to receive the International Sustainability and Carbon Certification Plus, the ISCC Plus, for our innovative bio-based feedstock sourcing practices. So our Alista SD products. So our Alista SD products, we have a warranty till 25 years. And when I started working at Axalta, the SD was only, there were not a few clients who were buying those. But now at the moment, we see some clients who radically say 100% everything we buy will be SD, because they want to put their projects on a higher level. So why this sustainability? Well, we have no solvents inside, no VOC emissions. We have less hazardous waste, no environmental hazard pictograms, long life expectancy, no health hazard pictograms. So, so then we can talk about our BioCore. So With our biocore, we have no greenwashing. It's bio-based and not competing with food. So we make the resins only from waste. We have a lower embodied carbon, immediate CO2 reduction impact. So it's a quick win. We have no additional approval process needed. So that's good for your peace of mind. We have same performance and warranties with our biocore products. So if we take any color we have, you can ask us, can we produce them in biocore? And yes, we can. We can produce them also in biocore. So for us, it's also a differentiation for branding, communication. So it's an unique opportunity. And also in combination with other sustainability initiatives like aluminium and glass, can be a big win. So if you look at the lead contribution, so with our SD products, we can contribute up to 8 points of a total of 110 points for a minimum investment. So that's also a good thing to add to your project. If you need more information about this, you can always come to our booth later. Then we have like a color effect and finish. So our expertise is dedicated to guiding your team in exploring a vast array of color effects and finishes available. So here we see buildings where people came to us, came to Axalta, found, okay, what can we do with color in our project? And now we see some nice examples. What was the result of this? Then we also have our Colorit website, and on our Colorit website you can order free samples from our colors. Also on the back of our folders we have a QR code, and if you scan this, you can order a sample like the color who is inside of our folder. You can order this particular sample, and then you get it in a piece from 15 centimeter by 7 centimeter. So if you need a free sample for your projects, that the Axalta Colorit tool is exactly what you will need. So, and then you can also discover the colors in real life. So we have a center in Lummen, and we have about 3,000 colors hanging on the walls around the center. So sometimes people come there with a brick, sometimes people come there with a Trespa panel, and you can put the brick or the Trespa panel on the table. You can take whatever color you want, you can put it next to your brick, and you can choose which color will be nice in the project. Here we have some references with colors from Axalta. So this is a famous building from Ingenieur-Architecten in Milan. We have done here a picture of the European Parliament in Strasbourg and the Philharmonie de Paris. Then we have, like I told you before, sometimes we do case studies. So when people come to us, what could be beautiful? What kind of color are we going to use on this project? So here we see an example from a project in Florida, an example from a project in Milan, one in another one in Milan, and one in Indonesia. So on our website is also a lot of information. So if you need information, inspiration for your future projects, please reach out to us, and we will help you as good as possible. And one time a year, we have a special magazine we bring out, and it's our Vibes magazine. And when we have beautiful project or special things, we always put them on the Vibes magazine. So if you have a nice project and that a project that needs some more attention, could be all kinds of projects, could be chairs, could be a big building, could be something else. We will kindly look at it, and maybe we can put it in our Vibes magazine for next year. So thank you very much for listening, and if you need any information, we're at the booth down. Thank you.
Thank you.
Thank you.
Thank you.
No questions.
Sorry?
No questions.
Okay, no questions. Okay. Thank you very much, Christian.
Thank you.
So we go on. We go on with Claeys, founder partner at Façade Steel. He will present hybrid steel curtain walls.
Fantastic. Redefining sustainability. They asked me to come over here and to give a presentation on this, and actually I was not so keen on. For the simple reason, sustainability, and I hope you will confirm, is one of the most misused buzzwords of the past 500 years. It makes no sense. But when they ask me, you should redefine it, then it now becomes interesting. I'm going to try to redefine sustainability. Before I start, here, hybrid steel. I've seen the word hybrid somewhere in a presentation. And just maybe to clarify a bit, hybrid is a term we registered about 5 years ago for our hybrid technical solutions for curtain walls, as it is a completely new family. I assume you know they have on one hand you have stick systems, on the other hand you have modularized, unitized systems. We have a hybrid technology which combines the best of both worlds and keeps all the rest behind. We are not so active in the Belgian market, but we are much more active all abroad on the 5 continents. Therefore, hybrid steel. We put there a wide range. We do it a little bit different. We are out of the box thinkers. We do everything differently. And why do we think we have to do it? Because we have no choice. I come back on that issue later, and I will follow up on something I heard from Joep. I went a long time to school, you see, but what's important maybe to know, I have 2 diseases. I was in the curtain wall industry since about 40 years, and I had the occasion, let's say the privilege, to work with some of the top architects all over the world. Murphy, Vasconi, Rogers, all over the world. Then I quit out, and my daughter, she's sitting there somewhere. She convinced me to take it up again and to do something to bring it to another level. Okay, that's what happened. It's a disease. Curtain walls is a disease. And I have a second disease, art. I am an extreme art lover. And then, mainly for statues. You will understand later why I'm saying this. Statues in art. When I give a presentation, I don't give a lot. I start with the thing. Here is the main thing. At the end of the story, it's all about money. I'm sorry. It's always about money. Engineering doesn't exist. Engineering has a goal, making money. And if you can't make money, you can't pay your employees, your suppliers. We need to make money. Disruption. I don't believe in innovation. Also bullshit. Situation is very serious, as Joep explained. What can you do about it? You need to be disruptive. Creative disruption. Doing completely different. As well technically as economically. Extremely important. Disruption. And when you manage to do disruption, you can make money. It's obvious. philosophy, hand in hand. In my presentation, and I will try to keep me for 5 minutes, I will have it over 5 things. Steel. Who is using steel in curtain walls? Nobody. But it has some advantages, some unique advantages. It's already disruptive, only the product on itself. Keeping the sun out. I heard about insulation and all that kind of stuff. I'm going to speak to you about something else, about keeping the sun out, because that's a real challenge. And I'm going to prove it. Hybrid. We have some smart solutions to keep it out. I'm going to give you my personal view on circularity. Sometimes I have the impression that we live in the construction world in a throwaway society. It's bullshit. The most beautiful buildings on earth are 500 years old, 800 years old, 1,000 years old. We have to think about that. And not spending time by making big tables, details, and to say after 3 years I have a circular product. Maybe we have to think otherwise. And then I'm going to show you how you do it in concrete. Okay. I heard here somewhere, and this is right, from the global carbon emission, 40% comes from the buildings. 40, approximately. Did you know that? That here, this, how it is? 20% is embodied. 20. And this here has the best one, 80. Nobody is working on it. This is, I call that scrubbing in the margin. I'm going to attack this. But first we're going to attack this on a very serious way. You need to attack both. Otherwise you're washing. I'm going to show you how. That's what we're going to do. From this 20 we're going to make 2. And from this 80 we're going to make 0. We're going to make it positive. For me, it became I've been working on that concept for years. It's a no-brainer. You have to see this all in the global picture. We are here for system houses. No, that's not correct. We make envelopes. And to make envelopes, you need some profiles. But that's a very, very, very small part of it. What is Façade Steel? Façade Steel is a joint venture between 2 companies, a Belgian one and a Swiss one. The Belgian group is what I would call a deep tech firm focused on developing and marketing of globally patented curtain wall systems for mid-rise and high-rise buildings. To give you an idea, we have more than 800 patents. We have a truck full of patents. For us, it needs to be patented. Everybody knows in our industry, they copy like fucking. I don't want to be copied. If they copy, we sue them. It's simple. Innovative, I don't like the term. People say we are disruptive. As I told you, the problems, the challenges we are for, like you explained very well, you need to be disruptive. Therefore, to go on that, on the market, we need a partner. Montanstahl. And my friend is sitting over there somewhere. The owner, by the way. The owner, by the way, Montanstahl, is a producer and a supplier of very special, let's say, not only stainless steel, but also steel products, profiles, and customized. The number one. It's very simple. They're the best. We are a very modest Belgian firm, but we want to have the best around us. That's what they do. Good switch watches. And these bowls, yeah, you know where it comes from. I have to say something else about my friend sitting over there. He is also an art lover. And you know what? Also fond of statues. And a couple of months ago, he asked me the question, what is your preferential statue? And I said something, and you know what he said? It's for me exactly the same. And you know what it is? I'll show you in a minute. And what we did. What do we need to do? We need to make a wall around. We have 3 stakeholders. What was the investor? Value for money, fast execution, cost nothing, should be high performing. An architect should have maximum design freedom. It was my focus. Most of the systems, they are so limited. Totally wrong. Let them do. How can you solve this? By developing by engineering technology that everything sits inside. We call that the engine. And the chassis, he can do what he wants. But what's important about the inside? That your performances should be never seen. Don't speak about 1,000, 2,000, 3,000, 4,000 Pascal. It should be much more. And on top of that, human independent. Our main challenge for the future is finding not only engineers, but skilled people. At the end of the story, it still has to be installed on a site, and therefore you need people. What does a facade contractor want? Minimum cost, minimum technical risk, high performance, healthy margin. You hear everywhere that people in their think that their main thing that is their client. For me, my client is not important. I've seen it in another level. I'm fighting for the maximum profit of my client. I'm not interested in having clients. By the way, you cannot buy, you have to be selected. But clients who work with us, they make profit. They make casa. And it's all what counts. And the more they make, the more I'm happy. And all the rest, sorry, it doesn't work. On the first look, it looks contradictory. But when you think about it, when you're in the thing, it's logic. You see? Just a piece of art. That's what we did. My friend was so brilliant to buy the rights of the thinker of Rodin. The full rights. We made some replicas. Thank you. Mine is on the way. He's over there. And we need it. It will be at the income of all our companies all over the world. And why? We need to think. That's what we do. We need to think instead of copying. And we need to think out of the box. Not because they have been doing something always like that. We developed this. By the way, this is a section of a steel curtain wall. And after months of studying, by the way, by the help of a fantastic guy, he did here a presentation a few hours ago, 15 minutes ago. We came to the conclusion, we do that steel facade in 1.2 millimeter thick coil. Everybody said it's impossible. We don't think it. We are sure. And Mr. Stum told me, Eric, you're going to break the standard, the industry standard. Fuck the industry standard. They didn't study, they copy. What we did, we know it 100% sure that it works. The advantage of this is, it's not so poor. The weight is lighter than an aluminium one, and we didn't do it to save weight. We did it for the people who have to store on site that they can do it. You understand? That was the reason. That was the charge. Not the cost. We don't look at cost. In our region, it's totally irrelevant. We are living in a world where we have labor cost of 45, 50 euros square meter. Don't tell me about 2 pennies. That's what we are. That's what they expect here in Europe. Everybody knows. From which the building industry has 40% of the carbon emission. How are they going to do that? I don't know. Because I'm going to show you something, what happens to me every day. Told you that's a typical building, 2080. You know what you need to do? The first thing you need to do is this. Carbon footprint is a linear relation with energy consumption. When you reduce that, estimate your energy consumption, you reduce your carbon emission. And the rest you need, you generate it in a renewable energy. That's the way of working. I've never seen a building like that. I'm going to show you a few. Then you get 0. Here you get 0%. I'm always coming to the answer. What about redefining sustainability? Keep it in mind. That's my intro. Steel, 10 times less. You can say the figures are not correct. Irrelevant. I only know one thing. If it's not 10 times less, it's maybe 8 times less. It's maybe 6 times less. And when I hear figures of aluminium companies who were driven by a marketing team of 1,000 people, then I can tell you, my dear people, they tell bullshit. Don't believe it. We have in this part of the materials, we have also our business. I can prove it black on white. The problem is that they put their head full of our clients with totally nonsense. It's a pity. Small people, they see it. 10 times less. Not 10%, 10 times. On top of that, we won't make this in steel, it's in stainless steel. Green steel. Good for 100 years. When we bring this, I don't go in detail about that technology. It will take me 2 days to give you an idea how this works. But I've seen there a very good one, Oxy. By the way, we have been working, people who know me, that we have been working in the past on Oxy. This electrostatic coated titanium, we give 100 years guarantee. 100. It's more than 2, eh? And this here, per definition, fire-resistant coated. It's a must. For us, it's a minimum. It's a must. The main problem in high-rise buildings and getting in fire, it's a very serious issue, and everybody knows in the UK. But what is the main problem, and I never hear speaking about, is when you have a fire in an office building and it happens during the day, yeah, people are active, they can move, and at night they're empty. In a residential building, and now at this moment, not in Belgium, but abroad, we have 120 towers going on now. 120, it's a bit, eh? Nobody heard about us. But it will change. We will do some communication in a couple of months. In a residential tower, where you have old people living, and it happened nights, let's say 2 o'clock in the night, and you're on the 30th floor, I can tell you, you're fucked. Unless tests. Unless tests. We do a lot in the Middle East. I don't want to give names. They do all test reports, and they say, have a good product. Don't believe it. The main player, we added a technical note. I think most of the systems they will fail. This seems obvious. I don't know. When I look what I see every day, most of the people even don't understand it. Most sustainable energy is the one you don't need. You remember the 35% I said? By the way, sustainable energy is not 100% sustainable energy. I don't know if some people amongst you ever read something about the non-sustainability of windmills, the non-sustainability of solar energy. I don't know. Worth it to read it. Greenwashing. Keep this in mind. What to do? We did lots of studies at universities. I have in my team a few PhD guys, very smart. And some other ones, and we did studies years in university in Ghent and in Lutich, in Liège. Look at this. This is a standard volume, let's say reference volume. This is the cooling loads, heating, and the sun. We knew this years ago. When you have here in glass, the best glass on earth from 0.20. You can do it we do it 10 times less by dynamic shading devices. And the cooling loads, they're reduced by 55%. Can you imagine cooling? Somebody else was saying, what is the problem with the climate change? Is the warmth. We don't care about the winter. Easy to solve, some centimeters of insulation. All by renewable energy, not by double skins. And people who know me very well, I've published a lot about this. This came now out, I'm not confident. And this here, this you can reduce only by a genius concept. 5,300. Look now. I think my nicest slide. These people, they have the same problem. That's where they use it with common sense. This building, I'm not going to name it, that's not important. It is what we call a greenhouse. This is an energy monster. And it has a gold label BREEAM. What to think about that? This I see every day on my table, these kind of projects. I have nothing against this. But then people, please don't speak me about sustainability. Screw somebody else. You cannot do us. It's impossible. We call that building physics. By the way, from background, I'm also a building physician. I know something about it. And that's what these poor guys, they make clay. Shape, I've seen that from you, the best you can have in a small hole. For the same problem. Short word about hybrid. Hybrid system is a system you've completely installed from inside. It's not unitized. And why? Unitized cost a fortune, sustainability-wise. It is not okay. Your finance is wrong. And you see here, we can do all kinds of stuff. You hang this. And all your exterior pieces you can have in a shop, you do it from inside. Without membranes. Without separate structures. For the people of Costantino, we can hang this from inside. And all the stuff you need, you can do, give it to Africa. And without these membranes, I can give to all people of you at least 100 publications by scientists. Refuse it. In our climate, you cannot be good. So you see this? With all kinds of products. Even with bricks. To give you an idea, such an element, we install 50 pieces per day with 2 people. 50, not 2, 50. Circularity. Best is no circularity. It's obvious. What is the problem in a building? It should be a mechano structure. But you have a grid with infill elements. Again, my friend Joep, he put on the nail. Your grid can be easily 50, 40, 50 years. Even more, if it is well designed. Stainless steel can be 100 years. Stainless steel is green steel. But what do you need? And I can tell you, I'm involved in a lot of commissions, not only here, but in the US. In the US, about here, this. You need from time to time a more performant building. And then I go a bit far. That's my building. We start the construction of this in a couple of months. These are architecture building integrated photovoltaic panels with A2 certificate, by the way. You see this? I'm going to do some. We did there. Our hybrid system. ABPV. Rotable louvers. You see this? The whole mechanics are integrated in the curtain wall, in the mullins and the transoms. This means once it is installed, I have no mechanical firm. I don't want it. I want the budget in my pocket. Here? No, how about the budget here? Here's this here. Oh, yeah. Fun thing. Features. And now I'm going to go not to, and I'm going to come to the end. Finance-wise, investment is reduced by 60%, but the building generates so much energy that the surplus, I sell it from these loading paths for electric cars, and the surplus is more than the financing cost of the building. I come to my conclusion. That's redefining sustainability. Not just zero, but zero finance. That's the way we see it. And that's the way we're going to roll it out all over the world. And who is going to tell this? my friend Fadzi. And this is Fadzi. Like, I stopped with the same thing at the end of the day. And Fadzi is a creature we developed. And he will explain all of the world on social media. I'm Fadzi, and from now on, I will be your technical assistant.
Okay.
Enjoy.
Thank you, Eric. So let's go on. Unfortunately, the next speaker will have 9 minutes less.
Patate.
Thank you, Eric.
I think so.
Thank you, Shuko. Okay, let's go on then with Erwin Ten Brincke, Associate Partner at EBT, to present reuse in design.
It's 1963. It's one of the coldest winter. It's icy, it's slippery outside. Nobody dares to go out. And people who must go out, they wear socks over their shoes because they will not start to slip. Oddly enough, there is a boy riding circles on his moped on a church square. This boy was so obsessed by riding a moped that he took some chains, pulled them together, deflated his front tire, wrapped the chain around it, pushed the tire back up, and he invented a kind of snow chain for his moped, so he could do what he loved most, and that is riding his moped. That boy is my father, and he learned me that if you really would like to solve something, you can do it. And with that drive, I work at ABT, where I find solutions to challenges for my clients. ABT is a Belgium-based company here in Brussels, also in Antwerp, and also we have affiliates in the Netherlands and in Belgium. And what I like about working at ABT is, on the one hand, you have your expertise, like being building physics or a structural engineer, like I am. And on the other hand, you have to develop yourself and answer the questions that are now in the market. You might know of projects like the museum in Antwerp for the curved glass, the Elizabeth Center in Antwerp, or for instance, the library in Malines. And we always go for a long relationship. MVRDV is the architect which we know from the first days on, in Hanover, but we also made with them the glass facade for Hermes in Amsterdam, where we had to find glass bricks, transparent glue, and even transparent glass frames. And the last project that we did with them was the double curved dome in Rotterdam. We also work with OMA, for instance, in Porto or in Taipei. And one of the other projects that I worked on was this Dubai Eye, which is 240 meters high. So the London Eye, oh sorry, I have to go for this one, I think. The London Eye, the top of London Eye is here. And we designed the double curved glass here. The capsules are 5 by 10 meters, so the doors are that large that the Rolls-Royce Phantom can drive in. And well, sorry for the word, but we try to innovate. What we do is we invented this hybrid stair with ultra high performance concrete, which had only a slab thickness of 5 centimeters. It's strong enough to hold you, but you can imagine that if you will stand on it, it's like a trampoline. So that's why we connected the glass balustrade as a kind of stiffener. And the architect, he challenged us he would like to see no bolts at all. So we tried to find something, and magically it works together. We do not only work for architects, also for artists. This is the pavilion which we made for Instagram, designed by Gerben Ermich. And this is an art object at the pyramids of Gizeh. But what I would like to challenge you is, are we building for norms or are we building for people? To us, one size does not fit all, and it already starts with what we had defined as comfort. It is defined back in the 70s, where men are sitting at a desk with a suit on. And we say we should reinvent it because it's very odd. When you're outside, we are still okay that it's minus 30 or plus 10 and we wear a coat. And the minute we walk through the front door, it should be within the bandwidth of 20 to 24 degrees. To us, that's a total waste of operational carbon. So can we look more at the function? At an entrance hall, could it be a bit more of temperature difference? And of course, when you're in the red zone, in your office, you would like to productively work, so it should be within 20 to 24 degrees. So to us, we design our buildings, and our buildings are very obese because we design it for the peak. And after, since we're engineers, we like to have a kind of safety. And after a couple of years, we say, well, it doesn't fulfill the needs anymore, so we throw it away. So everything that's hatched here is unexploited potential. So I think that's the potential for us. So how can we reuse then in design and in facades? And we have a very simple strategy, and we say, well, keep the remaining quality. Look at glass. I mean, it can last over 100 years, but since we're now gluing it together to an insulated glass unit, they will give me guarantee for 15 years. So the only thing we have to do is to increase the performance. And to show you how we do that is one of the projects which we did in The Hague, Palace of Justice, with as a very corporate design back in the 90s. Natural stone, horizontal glass band, and we had to upgrade it. And we did that by making it more vertical grid, and we did it by reusing the existing panels. So instead of having on the left side a horizontal bands, we changed everything 90 degrees. So we reused the glass, we reused the nature stone, and where we need some new glass parts, there will be operable windows. So we can also change the climate system again, not to this machine, but use physics, use warm air coming up. Another example is an office building. Very, well, let's say corporate again, masonry, nature stone, very well detailed because there are cavities where the sunscreens go in on the side, so it's very, very well detailed, but of course leads to a kind of cold bridge. And if you see, we have a horizontal detail and a vertical detail, and normal people would say, well, let's get a new stud wall in here, let's insulate the whole wall, and then we get the energy down. We say that's a total waste of carbon, because you add 50% of material and you gain only 50% of effectiveness. So you should have a close look, because you see the stud wall there, it's red, it's already warm, so why would you change the stud wall? You should, and if you would look physically, you would like to cut it here, because you would like to have a cold bridge on this line. So the glass is cold and the framing is cold. So if you adjust that, I think that's the big win in reducing the amount of energy. So for this project, oh sorry, one back, we are going to have new frames, aluminum or steel, which I heard, and we're going to reuse the annealed outer pane again. So we're going to make that into a new window again. One step further is the natural pavilion, where we have a timber wood structure, which is modular timber wood structure, and we reused glass. There is no installations because we have glass louvers. There is a wind vane on top of the building. In summer, the louvers go open in the direction of the wind, and in winter, it goes in the opposite direction. We reuse glass of another office building, which is 80 kilometers further, and then the contractors come in. How can you guarantee the strength? Well, I got connected to the University of Delft, where we wrote this master thesis. How can we predict the strength of reused glass again? And that's one of the things that we did. Going one step further, why are we still producing glass in these big ovens? In retrospective, I'm a bit ashamed that I made the Crystal Houses project, the one in Amsterdam, with the big stones, because a stone needed 3 days to cool down, because it's that thick, and otherwise it would break. Can I not make a thinner way, thin shade, thin glass, so it can cool down easily? And that's why I came up with the idea, can I not spray print glass? Can I not spray it anyhow? So some kind of container with glass powder in it, inert gas and some flames, and then spray it. I thought it was sensible, and I contacted the University of Darmstadt, and yes, we can. We can spray print glass now. Not on big tiles, but we managed to make a difference. And we see it's a very promising future, because if you look at H glass, maybe we can spray print ribs on it and stiffen it. So you get stronger glass and it will be as good as new. This is what you can do in reusing materials in your design. But if you have to invent a new building, try to make it a bit more circular. The 10 R's we all know, the refuse, reduce and reuse. And I think I agree with Eric. We should use our common sense. And to challenge the status quo. We did that for this glass cube for a private client who has art. He would like to hang art in his glass cube, and this was his dream. And you would, if you go to any structural engineer, you would say, well, let's make some portals, some fixed ends, and then you would have a very good structure. But we should rethink that. If you look at your shoebox, it's stiff. There are no portals in your shoebox because the walls are the stiffeners. And that's exactly what we did at this project. We used the walls to be the stiffeners. So the beams on top are only there for the art to hang there. I do not need those fixed connections anymore. It could be hinged. That's why we came up with this material independent reversible connection. It's a simple inox steel block with some plastic on it. We made some cavities in the glass, but you could also imagine that these are in aluminum or in steel or in wood. It doesn't matter. It's material independent. And this is one of the solutions, and well, it gives a very nice pictures, what I think. But that gave me the opportunity to do the next step. How can I make a fixed connection then, which is reversible? And then I made, well, a similarity to the sashimono, the Japanese sashimono technique, which is for timber. And that's how we, this is a master thesis from Elena. And you can take, well, the middle piece out, and then you have, again, a reversible connection. This could, now you see glass, but it could also be aluminum, wood, I don't care. But we can make designs which are reusable. Another challenge were the glass boxes in Eindhoven, where the architect had the dream to make glass boxes in front of this existing building. And the first dream was, well, let's have a panel of 5.5 meter by 7, some cantilevers on the side, and then we could make it. I hope there are people from the glass industry here, but I think we all know that glass is only limited to a width of 3.2 meter. So we had to reinvent the shape, and also had to reinvent how can I connect it, because I would like to make it glued. The architect gave the challenge. I would like to see no steel at all, so eat your heart out. So I thought of, can I not make a kind of notched connection, because the silicone is not strong enough, and that's why we made a notched connection. You can see it on the right. So we did some serious engineering on this notch, but you should imagine it's 2 times 10 millimeter glass. So use your fingers here, and somebody will put a weight on it of 400 kilograms. That's the force that we have to go through this detail. And you can see very nicely see on the left picture where this little cutout is, and on the bottom you see where the other end is. On the right hand side you see the craftsman. So it's a very big pain. So we didn't only think about the end situation, but how to build it, how to temporarily make this notch and tie it together before you let everything loose. And this is the magic panel which holds the whole glass thing up. The stripes there are for the light artist. He has it's Arnold Meijer, it's a light artist, but you get very nice pictures of a building in Eindhoven. So, to conclude, really winning time. Our DNA differs only 1% of that of chimpanzees. And that 1% makes that we see ourselves, we recognize ourselves in a mirror. That 1% makes that we can make a Hubble telescope. And I don't know if you know the picture left, but it's made of a Hubble telescope. And by this Hubble telescope, we know that beyond our own galaxy, there are 10,000 other galaxies. I think we are over 100 people here. So if everybody uses their 1%, we can make 100% difference. Thanks.
Okay, thank you very much, Erwin. So now let's go for the last conference. They will be moderated by Joep.
Yes.
I'll let you introduce the other speakers.
I made it myself even easier. They will introduce themselves. So,
What is the topic about?
about reuse of facade elements. Right. Perfect. Thanks very much. Thanks very much for sitting the whole day. I am quite sure, looking at all these interesting faces with all interesting stories, you will be happy afterwards as well that you set also the last part of this show today. We will be talking now about exploring the potential of facade reuse. Well, in a world of pushing for net zero buildings and urban developments, how do we push new life into aging buildings? And then it's not about preservation, but it's more about the reducing and the reusing of facade elements. I'm very happy to have this diverse group of panelists. As said before, I will let everybody introduce themselves and maybe just a brief word on what facade reuse in your daily business, how you see facade reuse in your daily business. So maybe we just start here.
So I'm one of the architects working on the refurbishment of the Citra garage on the other side of the canal in Brussels, nearby. And well, the starting point and the base of the concept is that we trust in what is there, and the shell is part of that.
Mm-hmm.
And the whole concept, I think, is built around that. So for this project, for sure, that's the way forward, we think.
Great. Hold that. We come back to that. Tris.
Good afternoon. My name is Tris Verhoeven. I work as project manager and sustainability manager for Nextensa. Nextensa is the owner of Tour and Taxi, so welcome in our house. As you have seen, we have a lot of historical buildings that we have redeveloped in that they can go for a new future. So that's part of my experience in the redevelopment of building and reusing the existing structures, facades, and making them ready for the next 100 years, because they are already 100 years here, and now we go further. And for new developments, of course, we are also seeking for solutions with low carbon, that we can make our impact less on this planet.
Thank you. Eva?
Hello, my name is Eva. I work at Seco, a company who gives technical advices in the construction sector. My main focus is on risk normalization and system and insurability, especially when it comes to the stability, the sealant, thermal performances, and the durability of materials. As specialized engineer, I think and I believe that reusing materials will play a key role in constructions that are sustainable.
Mm-hmm. Thank you.
My name is Etienne Klinkert. A lot of people know me, as I am already 35 years active in the sector of aluminium facades. I created Groven Plus. I was a long time the CEO. And now, in the last years of my career, I'm a little bit independent and try to help people with their new developments. I saw the technology evolve from, first of all, facades who had to have some thermal isolation. Now speaking about recycling, about reuse. It's terms that were rather new here, very interesting to follow. That's my interest today.
Great, thanks.
Well, my name is Mark Vosselmans from a family company Vosselmans, also 54 years in the business as a company. Not myself, for sure.
For sure.
Well, about reusing, honestly, I heard a lot of good and less good opinions today. And for me, this was a really difficult question, reusing. Well, my hope is that reusing is not the next greenwashing in our business.
Mm-hmm.
Because we heard a lot of stories, and we can laugh with Eric's opinion, but in some words, he is completely right. Some other things we can discuss later on the bar, but there will be a lot of opinions, but also a lot of external factors which are not in one hand. We all need together, from the developers to the architects to the system suppliers and so on.
Yeah. So basically, I take that everybody has a daily topic of reusing, but everybody also on different opinions and different usability of this reuse. But that's exactly what we're doing here, exploring these topics of the reuse. I'm going to go back to Claeys, starting with the concept, because you built concepts here and then from there to the tender in the market. How do you put this sustainability topic in the tenders, and how do you keep it in it? How do you anchor it in the tenders? Because we heard today as well, sustainability is often being used, but what does it mean, and how do you put it? How do you anchor it in the tender?
I think the ambition, they come also from the client, because it's the client budgets that are spent. So he needs to see what he can do with his budget and how far he wants to go. But I think a lot of clients wants to go the extra mile to integrate low carbon solutions in their projects. But you need it from the start. Effectively, you need to take it to the study team, and then to the construction team. And in the best case, they are sitting from the start together. Because if you can integrate it from the start, you can have better achievements in the end. Because if you don't have the experience from the field, from the constructor, from the suppliers, then you can't take it into the design. Because in the design, we use most of the time the same concept. And if we want to reuse elements, we also need the supplier and also the other parties to say what is possible, what is not possible, how can we integrate this again. So it's a constant work for all the members of the team. And I think all the members need to be motivated to have this high level of sustainability, or the high level of the ambition to reuse elements and to introduce old elements in a new building or in a renovation to reach the best result.
And Arabella, as an architect, then you have to work with what you see or what you get. The building is the building. How deep do you go into the research in the building of what your existing property is, what you can use, what you cannot use? Is that only the facade, or?
No, I think it's the whole concept, I think. So I think it goes much further than that. And, it starts, of course, with the analysis of what is there. I believe, and in our case, it was for sure also the client who was really on our side, that when you look at the thermal or the climate concept, let's say acoustical concept, which is there are some zones where we have less requirements. So all of that is part of the concept, and that made it possible that we could reuse some of the typical facades. But also, it's not only the facade; it's much more than that. It's also the structure, and in fact, we also wanted to reuse the floor slabs and so on. Some of them are too damaged, so it's not everything went as expected, let's say.
But you succeeded in some of the slabs to be? Oh, great.
So I think it's bigger than only the facade. I think if in our case, we're talking about a building which is 90 years old. So we try to keep as much as possible, trying to find a way to have a new program fitting the existing building. But also, from our opinion, it was needed to make some big interventions in, for example, the existing facade, because we thought that the relationship between the public realm and what was happening inside the building with the new program needs something else. So by doing some big interventions, we thought that we could keep a lot of the rest. We could reuse a lot of what was already there. So also in that So on that side, I think we were searching and trying to find a balance.
Okay. And then we have these concepts, and we talked about today as well about glass reusing, for example. And then we go to Eva and say, okay, now we want to reuse this glass. Are we allowed to? Do we have tests or something to reuse old glass?
Indeed, we have a lot of questions about the reuse of glass. It's a good question, and it's no easy answer. I think recycling glass is easy. Glass is a material that's very sustainable. Like we heard before, it can stay as a single glass for years and years without any problem. But on the buildings that they ask the question, it's not a single glass pane. It are double glasses mostly, and that's difficult. Because the performances of these double glasses has not the performances of today's standards. Then, as we already saw on some presentations, it's possible perhaps to dismantle the glasses. Okay, we can try that. If we do that, I can understand to reuse the float part. But mostly on all these double glazes, even 20 years or 25 years ago, there is a coating. Then the question is the coating still correct? Is the coating still existing? Because the coating, it has evaluated a lot the last years. The performances are much better. So I think it's really difficult to reuse coatings, soft coatings. We know also that the glass process has to be a continuous process to make it. And we also know that recycled glass in this process reduces a lot of the energy cost of making glass. So it's really important to think, where do we want to gain energy costs? So for me, to reuse double glaze, it will be really difficult to give an assurance about that.
Mark, maybe you can comment on that, because these topics are on your desk probably as well. Can you take out this facade and build me a new facade? I know you work in different countries, UK, the Netherlands, Belgium. Do you see differences there, or what do you see in projects?
Thank you. These are 3 questions for me.
In one, huh? Yeah. So
well done.
You ask not to ask too much.
Let me start about the difference in the markets. And the first words I heard from Tris was, is depending on the client and the budget and things like that. Yes, it can be, but I don't agree with that, because it is we as a market, we have to help the client to come to better solutions. And if I compare Belgium with the UK and the Netherlands, in the UK and the Netherlands, we were obligated to work more in pre-construction IDs. I think about 80% of our windows, normal windows, are installed in the precast or in the wooden frame constructions. If we tell that to a Belgian constructor, the answer is no. If I do it traditional, it's cheaper. So let's stay traditional. We won't change anything with that solution. If you think on the long term, we all know that labor is more and more expensive. We have less people to install on-site, things like that. So it's an easy answer, but it doesn't work at the moment. So we have the first 30%, as Eric said, we can. It's on the floor. Just take it, but we have to do it together. Another word I heard it today was bouwteam, the building team idea. It's very popular in the Netherlands. Why doesn't it work in Belgium? At the end, the result is better at certain goals, as well financial, but also quality, safety, sustainability. Everything you can put in the team to reach that. Well, another good thing to be positive about the Belgian market is we see now certain buildings that there will be renovated on demand of especially the government, buildings from the 80s, the 90s, also the early millies, that the facade isn't sufficient with the thermal demands, that we now are replacing the glass. We keep the structure, mostly the stick system, replace the glass, eventually more isolation, whatever. We can reuse the caps, the cover caps, things like that. So in a certain way, this is reusing structure, but the glass, I think it's still a long way to go.
Maybe to pick further on the BOW team, looking here to this side, developers, architects, project managers. How do you see that in BOW team in Belgium?
Yeah, I think it's an evolution. We also see it in our projects. Before it was more the work of the study team, then the tender, and then came the contractor. But now we are also working in BOW team. I have some contractors here in the room, and it's indeed an extra value to the project, because it's what I said. They have experience on the field, and the experience is directly put into the project and not afterwards. And again, you need to have everybody working to redo plans, and now it's done from the first time. Maybe not the first time, but in the first cycle of the design, it's already taken into account all the experiences, and then you can go a little bit further in the design, and you can indeed integrate some also experiences from suppliers and experiences from abroad. And I think that's the way that we need to go, that we need to collaborate to have that better impact.
I will add some words to this. Please take care that a BOW team is not only a developer, an architect, and a main contractor. You need all the industry. And that's something we forget too much in Belgium. It ends with the main contractor, and he's going to shop. And that's not the best way to come to the best result.
No, they need also to be at the table to discuss certain topics. Exactly. Yeah.
Maybe, Jen, something to add to that. You just mentioned already before you are some years in the industry. Have you seen this evolving, or?
I would like a bit to say that maybe in all the 30 years we were not so intelligent as types of construction we make in aluminium facades are still the same. We are still discussing about stick facades. We are still discussing about unitized facades. Still about windows. The technology didn't change it. What changed was the performance of the facade. We had more insulation. During 20 years, that was the criteria. We had to improve the insulation of the windows. So thermal breaks, better glass, better spandrels has been put into the facade. And today, what we want to do is, of course, get this new standard to the old facades. So, in fact, we could say we can use the old facades because they are the same. You only have to improve the thermal insulation and the panels. That's what Mark said already. We can basically take a stick facade, take out the glass, improve the thermal breaks. You show it this morning that it's possible to do, and so it is easy. It's easy to refit or upgrade. I think that's not a problem. So when you say reuse, it's more complicated. As we said, the elements are not performant elements. It will be tomorrow. Because I think today, thermal breaks, we reach the end. So I think at that point of view, we can make today facades we can reuse in 20, 30 years. The old ones is not that easy. But reuse will also say that architects should accept some standardization, modulation, that we keep the same modulations. If we change the modulations, it's not possible to reuse. But if we can grow in this philosophy, I think there's a lot to do. So, yes, there is a lot to do with what we've done in the past. And then I come to what Mark says. It's not evident for an architect of a building owner to say what he can reuse. That's why specialists have to advise architects and owners what can be reused. And that's where the facade company can be a possible partner very soon in the business to change. I will take one example. We saw it this morning. The the Montgomery building. We worked with Groven on the Montgomery building. The whole decorative facade. We proposed to take it off the facade, re-anodizing and put it back. So reuse integrally the profiles without any production other than anodizing. If you have been sooner, maybe we could have kept millions. But that was already too late in that stage. So as fast you come into the business, as fast we can think with owner how we can reuse certain materials. But for what the older facade thought, we will reuse certain elements, not the whole facade. This is not possible because they have not the performance required.
So in that way, it's not that bad that we're not that we're not that evolutionary in the building industry, that we can reuse what we've done in the past quite good. I hear modularity. Is that something somebody wants to comment on? Because first we had it about Bouwteam, one of the necessities to have a good reuse, or Bouwteam, or at least talk with each other as soon as possible. Modularity, for an architect maybe. Modularity, can I still do what I want to do?
It was already done in the 30s. I mean, like the old apartment buildings, like the boutique flat. There's a lot of standardization and prefabrication already done.
Maybe it's me. I don't know.
But yeah, it's a different way of thinking. So I think if it's already there and it's worth reusing it because the quality is good enough to reuse it, it can be a good starting point.
And when you're looking at the future, like future designs, and then when you're designing now for reusing in the future, will modularity be a main topic in your mind in design phase? Or maybe somebody else wants to comment on that?
At the moment, I think it's a bit difficult because there are so many options.
I think for the big buildings in Brussels who have 30, 40 years, they are already modular.
Yeah, but they're modular for their building.
Yeah.
It's not a standard
not always.
Dimension.
There are architects that already do years and years the same modelers on all their buildings. So we know that for some architects, they always have the same width of facade, for example, because also there are a lot of modular systems. I think about the ceilings and so on, and to avoid to have little pieces, they already have thought about it in their buildings. So I think, what you can reuse easily is the brackets. You have to recalculate them perhaps or reinforce them. Perhaps the mullions and the transoms of facades. What's important, of course, is still to check that the performances for the water and the airtightness are still correct, but therefore there are already standards that exist, so it could be possible. And of course, it's the insulation, as already Etienne and Mark said, that has changed a lot. So I think it's possible to place, for example, and that we already saw vacuum glass, who is also still light. They still have to work on it to have perhaps bigger dimensions. But that has, I think, for example, a vacuum glass in a double glazing. You still stay with the same dimension, but you improve a lot of the view values of the building. The same, I think, in the opaque panels, but you can place more insulation, and perhaps we can think about reusing the enameled single pane, for example. So I think every project we have to check what's possible. That's important, and with specialists, of course.
Maybe, Etienne, you can comment on the vacuum glazing in a project you've been working on lately, I guess?
We've used it already once, and that's an important thing to say. We have had facades, we were growing a larger and larger, bigger insulation, bigger glass, triple glass, and we go back, I think, to smaller elements. What's good, because it makes it reuse easier. It's easier to get less than more. Vacuum glass is one of them. We did that in one project on the BEL 9 as first reference. I think the client is very happy. We did it in assembly in double glass to use the normal standards. But because getting less, it's not always easy. Also for aluminium frames, because you have to make something to make compensation for your insulation. And there, to use the standard, we arrived to achieve a U value of the glass 0.4. So it is fantastic.
It's very great. Yeah.
It's fantastic. But I think there are already some tests in also the spandrels to use vacuum. I think this will be the tendency in the future to get less, smaller panels, smaller glass, less insulation, which is better for the carbon in the glass. And it's better for the spanners, and it will be easier for us to work. That's sure.
Yeah, the only difficulty is the coating then, because if there are different coatings used, you might have different colors.
They can use coatings also in the vacuum glass. It's not so that there's not possible coatings. They can use some coatings. It's still growing. Eh? We have not all solutions for all products of glass, but it is growing very fast now. IGC is working very hard on it to make expanders and other things with vacuum glass, but step by step.
But this glass is still very expensive for a normal project, and as you heard already, the budgets are already...
At the end, all a question of money, and today
always a question of money.
It is a little bit expensive, but one is going with another.
But then
more there will be production, less will be the price. So we have to...
On the long term, the warranty of continuous much higher or longer than for standard.
The advantage of the vacuum glass is they give a long guarantee. I think 20 years if you want. And it's completely recyclable. So you don't have the problem of the interlayers. You can recycle the complete glass. That's two advantages, but you still have the more cost of the glass. It still remains very expensive.
Yeah. But I think there we also come to the point that the actual cost is not covering the environmental cost. And the long-term cost, because we pay it now, but we don't pay for the long-term impact. Maybe that will change because they are talking about carbon taxes, but we don't know what it will be in the future. And maybe with those carbon taxes, there will be a shift towards these better solutions, but that's still
question mark. A little
question mark. Yes. Also for me. Yeah.
Okay, a little bit looking at the time. By the way, I hope at least that we picked on some points. The panel will still be in the lobby as well after, so you can all discuss with these masterminds about the reuse of the facade potential. To conclude this session, I want to ask you what, maybe not just for this from this discussion, but from the whole day, what do you want to emphasize? What do you want to remember, or what do you want the crowd to hear one more time? Maybe you can comment on one or another thing that you really think should be mentioned again. Start on this side again.
For me, it's maybe quite common sense, but I think that there's only one way, and that we have to do it together. Like you were talking about Bouw team, but I think it really depends on who you have around the table, and if you want to achieve something in particular, I think you just have to search for the right people.
So doing it together. Yeah.
Different disciplines, different characters, different priorities, maybe also. Yeah.
Mm-hmm. Thank you.
I came to the same conclusion. You need the right person, the motivated persons, and you need them all together to work on the project to get a better project than it would be 10 years ago.
Perhaps you're all right also about working together to be a good team, to trying to do the best, of course, for our world. I think it's important, even sometimes it costs a little bit more. I think also managing the risk of reused materials makes them insurable, and it will make them common in our business.
Yeah. Jan? I will maybe be a little bit negative and say I'm a little bit disappointed. Not about the people here, but these teams are very important. You said it, Erik said it, another. We are coming to an end. 2050 is not so long away. And we're still dreaming of thinking about solutions. We should be executing the solutions today. That's what we should do. Thank you. And for that, the authorities should intervene because you said it. It's too expensive. Yes, it will have a cost. We have to pay it now. Otherwise, we will pay it in 2040, 2050. So I would thank the audience to be interested, but it's not enough, I think, today.
Thank you.
Well, they all told what was in my mind. So let me just, as Etienne, finish with a critical note that we are now talking about reusing, but we are in a certain way not able to recycle in a good way. To be honest, we buy a lot of aluminium profiles from the best supplier in the world, but at the end, our scratch is going on a boat to China to reuse in China. And that's something we need from Europe, from the government, but also from the system suppliers. And maybe it's the same for the glass industry. We have to do it together, and that means start with the beginning and not with wishful thinking in 10 or 30 years. So I hope this is not too negative, because I had a lot of positive input today, but this is a critical note, which is something to think about for all of us.
Thank you. Well, I think critical notes are always very helpful to get further because you start thinking. Well, thanks to the audience. As said before, we don't have time for questions now, but in the lobby we will all be there. Thank you, panelists, for your thoughtful comments. And then I will be handing back over.
Okay.
Yeah.
Thank you.
Thank you.
Thank you all. Thank you very much.